All right, class, a very good morning, everyone, and welcome all of you to Om Institute. Very good morning, everyone. Quickly keep on joining the session. Yes, because this is the mega marathon for engineering mathematics for the GATE 2025 examination. Okay, a crucial subject. Okay, a subject which potentially can make a big rank difference. Okay, because of its weightage. And yes, if you're still not done with it, okay, still there is a lot of scope. You can score good marks out of this. So very good morning, everyone. Come on, everybody, first quickly keep on joining the session. Quickly keep on connecting, quickly keep on joining, everybody. All right. Good morning, Selvan. Good morning, Sandeep. Good morning, Rohit. Good morning, Yakub. Good morning, Ramu. Archana. Good morning, Venkatesh. Good morning, Never Stop Learning. All right, quickly update all your friends that the session is live, and they can also join up quickly if they're looking for the mathematics revision. Okay, or in fact, still if you're not done with the mathematics preparation, then also this session will be helpful. Okay, because in a brief amount of time you can grasp several important concepts. Okay, good morning, Shubhetha. Very good morning, everyone. Yes, good morning, Sandeep. Good morning, Geeta. Good morning, Chandu. Good morning, Venkat. Okay. Good morning, Karthik. All right, I think so. Time to get started. People are joining, and others will keep joining slowly. And let's get started with the today's mega marathon. And in this marathon, we are going to continue. We are going to run as long as you are left with the energy, and as long as I complete several important areas of engineering mathematics. Right. So good morning. Good morning. So that's what. How many hours that I cannot say right now? Okay. How many hours cannot say right now? At least till evening. Okay. Because mathematics has a lot of chapters. So let's get started, guys. This is something about me you're aware about, I hope. Okay, so these are the mega marathons for you, started from 13th of January. Okay, you have completed the control systems, you have completed the EMF as well. Today is the engineering mathematics turn, and let me also update you the next, okay, on 21st of January, a core subject of EE going to come up, power system. Okay, to be taken in two parts by Giri sir, because again the power system has a huge syllabus. Okay, the 21st, be ready. That is on Tuesday. Okay, today is 19th, so Tuesday, okay, you are going to have the power systems mega marathon session. The power systems mega marathon session. All right. Okay, so the timing and all will be updated on the channel. So stay subscribed. That's what. If you are not subscribed, do not forget to subscribe so that any of the sessions you don't miss it. You get regular updates if you are subscribed to the channel. And yes, guys, today is 19 January itself. And okay, if you or any of your friends, juniors looking for GATE 26 or GATE 27 preparation, so for all the online courses of OM, the OM brings to you online scholarship test. Okay, wherein the first three performers will be getting 100% scholarship, and based on your performance, you're getting the different scholarships as mentioned in this particular slab here. All right, guys. So yeah, that is what it is. So today 6:30 p.m. the test is there. You can update your juniors, friends, and etc. The syllabus respectively for EE and EC is mentioned in front of you. And if you're looking for AE offline batches, okay, for the Telangana Transco and Discoms, as well as for AP Transco and Discoms, the new offline batch for AE starts 23rd of January. That is the coming Thursday. For any more queries, you can contact 9515694053. And yes, this is the first concept of the day. Let us start with the concept of rank. Okay, let us start with the revision about rank, linear system of equation, eigenvalue and eigenvectors. Okay, starting from linear algebra, then probably moving towards calculus. Okay, so what topic I'll keep taking next, it all depends on timings. Okay, it all because in between some small breaks also I'll give you, not big breaks, but small breaks we'll keep taking. So based on the timings, we'll keep deciding. Let me start with algebra, and the first important area in the algebra is the rank. Okay, let's understand rank now, because it's a revision session. Our focus will be more on the approach of problem, because mathematics is all about problems rather than, you know, theory or etc. It's more about problems. Okay, so rank, which is the largest order of any non-vanishing minor of the matrix, non-vanishing or non-zero minor of the matrix. Okay, and rank of a matrix will be R if you have at least one non-zero minor, if you have at least one non-zero minor of order R. The rank will be equal to R if you have at least one non-zero minor of order of R, and it automatically means that every minor of order higher than R should be 0. Okay. Now let's understand more with the problem. And then some important key points, very important key points with respect to the matrix I'll keep telling you. Okay, so have a look into this example in front of you. Okay, for simple, I've taken an upper triangular matrix right now, and which is a 3x3 matrix. Okay. I'll ensure that even if you have not studied the topics, you'll get the topics quickly. Okay, don't worry. So even you know, the freshers can watch it. Okay. So have a look into it. It's a 3x3 matrix. Okay, so what is the largest possible minor that you can extract? So minor is any determinant that you can extract from the matrix. So the largest minor that you can extract is a 3x3. Okay, is a 3x3. Okay. What is the value of this determinant? What type of determinant you have? Upper triangular. And what is the determinant of any upper triangular matrix? So important determinant points, directly, indirectly, I will keep covering. Okay. Because, you know, directly determinant questions are not that relevant, but directly, indirectly, whatever points about determinant you need to know, that will, you know, whether it is rank or eigenvalue, somewhere you will keep covering. Okay. So have a look into this particular problem. Okay, so if you have a look into this particular problem, this is an upper triangular matrix, and for any upper triangular matrix, upper or lower, anything, for any triangular matrix or diagonal matrix, the determinant is given by the product of diagonal numbers. The determinant is directly given by the product of the diagonal numbers, and which is actually -8, which is non-zero. Okay, which is non-zero. Okay, so there is a 3x3 matrix, and the largest minor of the 3x3 matrix possible is the third order minor. Okay, the largest is a third order minor. Okay, is it 0 or non-zero? It is 100% non-zero. We have got the value. Okay, so I have a third order minor which is non-zero. I have a third order minor which is non-zero, and hence the rank of this matrix A, R of A, or in some of the books you may find it as rho of A, anything, is said to be 3. Okay, rank is the largest order of non-zero minor. Okay, if there is a third order non-zero minor, rank will be 3. Yes, if this 3x3 minor was 0, then I will go below and check. Okay, then I will go below and check. So let me take another example here first. Before I explain you echelon forms and all, let me take another example. Yes, PDF, just like control system, entire PDF I'll give to you. Whatever we are learning today, theory, questions, etc. Everything in the PDF format I'll give to you. Okay, so what I will do is, let me take another question here. Yes, dear. Let's jump to another question here. Just a second. Just a second, dear. Okay, let us take another example wherein I take this matrix. Have a look into this matrix. This is also a 3x3 matrix. This is also a 3x3 matrix. What is the largest minor of this 3x3 matrix? Okay. Yeah, it will be available, but today also password protected. That rule I will not change. The PDF will be available just like control system, 100% password protected. Okay. 100% password protected, and password is given in the session. It's not like some hidden password. Okay. This basic idea is those who are learning, those who spend time, they actually are in the need of notes. Okay. That's what my philosophy says. So it will be today also password protected. That rule remains to be the same. Okay. Password I'll tell you somewhere in the session. So this is what is a 3x3 matrix, correct? Okay, now if you take a 3x3 minor out of it, again the largest possible minor is 3x3. Okay. Correct. Now have a look into it. Okay, when you calculate this determinant, dear, okay, I hope you can do the calculations. Okay, let's do it quickly. Okay, so this is 1 into 45 minus 48, expanding about the first row. Okay, minus 2 into cross multiply 36 minus 42, and plus 3 into 32 minus 35. Okay, so that is minus 3, and then this becomes plus 12, and then 3 minus 9, and eventually 0. Yes, guys. So what is the determinant of this matrix? Is 0. Correct. What is the determinant of this matrix? Is equal to the 0. Perfect. The determinant is 0. That means there is only one 3 cross 3 minor because I have used up all the elements, and the value of that 3 cross 3 minor, okay, I started with a third order minor, and the value of that third order minor is 100% non-zero. Okay, is 100% 0, I mean. Okay, so rank of the matrix, of course, cannot be 3. Rank of the matrix cannot be 3. Okay, so whether the rank is 2, before we talk about official methods, let's keep understanding. Sometimes this simple analysis will also work for you. Okay, this is what I call it as a determinant method, but then we have, some method known as dependency of row and column. Then we have some method known as echelon form. Okay, so if you take a 2 cross 2 minor, now I am taking a 2 cross 2 minor. Okay, so take up, there will be a lot of 9 2 cross 2 minors. Let me take up this first 4 entries I see in front of me, 1 2 4 5. Okay, 1 2 4 5. Okay, so this becomes 5 and minus 8. 5 and minus 8, eventually not equal to 0. Now I can say that I have a 2 cross 2 minor which is non-zero, and I told you, even if you have at least one non-zero minor of order 2, okay, not necessary to check all the other 2 cross 2 minors. Not necessary to check all the other 2 cross 2 minor. Even if you have one 2 cross 2 minor which is non-zero, rank will be equal to 2. Rank will be equal to 2. Perfect. Rank will be equal to 2. No need to check the other. Okay. Even if one non-zero minor of order R, the rank is said to be R. Clear? So rank here is equal to the 2. Rank here is equal to the 2. Clear, everybody? Okay, perfect. Okay. So rank is equal to 2. Now understand, in the previous case, rank was 3. Both are 3 cross 3 matrix. So fundamentally, if you talk about a square matrix, first an important point. If you talk about a square matrix, n cross n, the largest minor is the nth order minor. Okay. That actually is like the determinant of the entire matrix. And if the determinant of the entire matrix turns out to be non-zero, then the rank will be equal to n. Okay, that is the largest possible rank. We call it as the full rank condition. To understand the first important point here, all these points are very crucial here. Okay, so if you have a square matrix which is of the size n cross n, if you have a square matrix which is of the size n cross n, okay, so first of all, the rank maximum can be n or less than n. Okay, you cannot have a minor n plus 1 size. Na? The maximum minor size will also be n cross n. So rank will be n, okay, or otherwise below n. Okay, but if it is a non-square matrix, suppose if I tell you a 3 cross 4 matrix, what is the maximum minor you can form? If it is a 3 cross 4 minor, 3 cross 4 matrix, then also the maximum minor you can form is 3 cross 3. You cannot add a row. Okay, so what you will do, out of 3 cross 4, delete any one column, you will have a 3 cross 3 minor. Or if I tell you, maybe there is a 5 cross 2 matrix, maybe there is a 5 cross 2 matrix, what is the maximum minor? You have 5 rows and 2 columns. You can select any 2 rows with the 2 column. Maximum minor you can form is 2 cross 2. Any doubts, please keep mentioning me. The maximum minor you can form is the 2 cross 2 minor. Okay, so what about the rank of this matrix? 100% less than equal to 2. Okay, rank of this matrix less than equal to 3. Now, whether it is 3 or not, that we need to check the determinant, that we need to check the 3 cross 3 minor. What I'm generally telling is, if you have a non-square matrix which is of size m cross n, then the rank is less than equal to minimum mn. Rank will be simply less than equal to minimum of either the number of rows or number of columns. Okay, now, if a matrix, important point, attains the maximum possible rank, like in our example, the maximum rank could be 3, and yes, it was actually equal to 3. In the second example, still the maximum possible value of rank is 3. Maximum possible value, I'm not telling maximum value, the maximum possibility of rank here also is 3, but rank is not equal to 3 because determinant when 0. Clear? So, when a matrix attains the maximum possible rank, okay, it is said to have full rank. It is said to have full rank. Okay, it is said to have full rank. Now, for a square matrix, what is full rank? What is the maximum rank? Okay, for a square matrix which is n cross n, what is the maximum value of the rank? I told you the rank less than equal to n. So maximum value of the rank is n, and yes, it will actually have the rank n if it is non-singular. Okay, if it is non-singular. Non-singular means determinant not equal to 0. Non-singular matrix is a matrix where determinant is not equal to the 0. Okay, so yeah, first case, determinant not equal to 0, rank was full. Okay, so this is said to be full rank condition. Okay, second case, determinant was 0, so the rank is not equal to 4. So this is also important concept. A square matrix will have full rank, that is n, if it is non-singular, if it has non-zero determinant. If it has non-zero determinant. Okay, right. Okay. Now next, don't worry, Telegram links also I will share you. I'll share you the Telegram link where I'm going to send a PDF. I'll share you in some time. Okay. So now next point, rank. Okay, rank. So there is one more point written here before I explain you this dependency. This is also a very important point. This one, okay, and especially this one. These two are very crucial points for you. Now, if there is a, sometimes, rank of a matrix is given and rank of, adjoint A they discuss. If a rank of a matrix, consider square matrix A, then rank of adjoint A. Okay, this result I will write down. What about the rank of adjoint A? No need for any derivation, guys, in the session. Let's revise all the points. Okay. So, rank of adjoint A will also be equal to n if rank of A equal to n. Okay. If the rank of A is equal to n minus 1 and next three cases you divide, rank of A is less than n minus 1. These are the three cases. If rank of A equal to n minus 1, rank of adjoint A turns out to be 1. If rank of A less than n minus 1, rank of adjoint A turns out to be 0 because adjoint A will become a null matrix. Okay. Rank will be 0. For any matrix, a rank is 0. That means it is a null matrix. It is a rank equal to 0 only for a null matrix. Rank equal to 0 only for null matrix. Okay, 1 or 2 points. Let me write down here separately. What about the rank of a null matrix? It is always 0. Okay, next important matrix can be rank of, adjoint I have written. Rank of, say what? Identity matrix. Any identity matrix. N cross N. That will always be full rank. Okay, rank of A transpose will always be equal to the rank of A. Okay, and one more condition, rank of A inverse. Let me talk about the rank of A inverse. Okay, again here A being square. In the transpose property also, I have assumed A as N cross N matrix. Rank of A inverse will be equal to rank of A. Okay, will be equal to rank of A, like that I'll put down. Okay, will be equal to n if rank of A equal to n. Okay, because if rank of A less than n, okay, if rank of A less than n, okay, that means the determinant would be 0, and determinant 0, that means inverse of a matrix cannot exist. So the question itself will become invalid. So if they are asking rank of A inverse, they can only ask if the rank of A equal to n, because again I repeat, if the rank of A less than n, what does it mean? The determinant of A will be 0, and if determinant of a matrix is 0, can you define the inverse? Can you define the inverse of the matrix? No, no, because the inverse of a matrix is given by adjoint A divided by modulus A. Inverse is only defined for square matrices having non-zero determinant, otherwise inverse will not exist. Okay, so even in this property, when I say rank of A inverse is equal to n, if rank of A equal to n, A is a n cross n square matrix. Clear? Rank of adjoint A, if they ask, I've given you the results. Okay, now coming to this next important point. Okay, then we'll go to the echelon form as well. So dear, in one of our questions here, the determinant turned out to be 0. See, understand one more reason why determinant actually turned out to be 0. Here I calculated. Okay, let me repeat the same matrix now. Okay, what is the matrix A? I'll show you some numbers. 1, 2, 3, 4 and 5 and 6, 7, 8 and 9. 7, 8 and 9. Okay, now you just see the calculations alongside with me. I am just going to add R1 and R3. First and third row, please add 1 plus 7, 8, which is twice of 4. 2 plus 8, 10, which is twice of 5. 3 plus 9 is 12, which is twice of 6, correct? That means when you add R1 and R3, it is twice of R2. It is totally twice of the row 2. So what is the value of the R3? R3 can be written as 2R2 minus R1. That means there is a dependent row. Anyone you can call dependent, okay? Whether you can say R3 something or R1 as a function of other two, or R2 is R1 plus R3 by 2, anyone. Okay, there is one relation, you can call any one row as dependent. So I have basically one dependent row. Okay, so how many independent rows? Out of the 3 rows of the matrix, there are 2 independent rows. Okay, there are 2 independent rows, and yes, we actually found the rank of the matrix was 2. We actually found the rank of the matrix is 2. In general, always, whether it is a square matrix or a non-square matrix, the rank is equal to number of linearly independent rows or also equal to number of linearly independent columns of the matrix. This one point also being very important. Okay, so I'm telling you, actually, I will tell you echelon method, echelon form, that is the official conventional method for backup, because maybe in some problem it may be required, but most of your problems either by basic determinant analysis as I was doing or either by the dependency of row and column, majority of your problems can be solved. Even this dependency tricks, we will also use it once we go to the linear system of equation. Okay, so have a look into this case here. Okay, what is echelon form? Okay, now let me tell you a conventional method of it. Okay, worst case we should know it. Okay, so there is a matrix A. Okay, a matrix A of order m cross n is said to be in row echelon form. What is the meaning of row echelon form? Okay, I'll write down, in a very simple format actually. Okay, very simple format. These are the official definitions. Let me, write it simple way. Okay, number of starting zeros in rows. Okay, they must be in increasing order. And second, ROZ, row of 0, if any. I don't say row of 0 should be there, but row of 0, if any, must be at last. Row of 0, if any, must be at the last. Okay, row of 0, if any, must be at the last. Clear, everyone? If there is a row of 0, it must be at the last. Okay, so let's have a look into this. Let's have a look into this example. Okay, have a look into this example. Same matrix. We calculated the rank of this matrix, the upper triangular matrix, which was equal to 3. Now understand this example with the echelon form. Okay, here, now let me define a parameter. Let m be the number of starting zeros in a row. Number of starting zeros in a particular row. I am only concerned on starting zeros. That means, dear, if you look into the first row, I don't count this. I'm telling you beginning. Okay, whatever zeros consecutive in beginning. Okay, so nothing here. M is 0. There is one starting 0. So hope you now understand the meaning of starting 0. Okay, and here 2 starting zeros. This is not to be counted. Any random mid zeros or end zeros not to be counted. Okay, now does it follow increasing order? Yes. Does it follow increasing order? Yes. So it's in row echelon form. Second is ROZ, if any, if there is a row of 0. Okay, ROZ means row of 0. You can write down. If any row of 0, it must be at last. Right now, there is no row of 0. Okay, so this is row echelon form. The matrix is in the row echelon form, and then the conclusion. If a matrix is in row echelon form, then what happens? Then the rank is number of non-zero rows. Then you can just observe and answer. If a matrix is already in the row echelon form, okay, then it is equal, the rank is number of non-zero rows of the matrix. The rank is equal to number of non-zero rows of the matrix. Perfect. Okay. So what is the rank of the matrix then? How many rows are non-zero? First row also non-zero, second non-zero, third non-zero. Even if a single element non-zero, the row is non-zero. Okay. So rank is number of non-zero rows, which is equal to 3. Clear? Now next example. Please see the next example. How many starting zeros? 1, 2 and 3. Yes. Clearly increasing pattern. M is 1. M is 2. M is 3. That means this matrix is also in the row echelon form. Okay. And there is the row of 0 that is automatically at last. Otherwise, we will do the shuffling. Okay. But ROZ is there and it is automatically at the last. Both the conditions satisfied. Yes, it is following the increasing pattern also. ROZ is there at the last. That means it is in the echelon form. Row echelon form. Okay, so what is the rank of the matrix? Number of non-zero rows. First is non-zero, second is non-zero, third is a 0 row. Okay, so rank is number of non-zero rows, which is equal to 2 here. Okay. Any doubts? Without any hesitation, you have to post it. Okay. Then only you'll actually learn. Don't leave your doubts pending. Have a look into this next example, dear. How many starting zeros? Okay, this is 1, this is 2 and this is 2. Now, 1 and 2 and 2. 1 and 2 and 2. Okay, how many starting zeros here? In the second and third row, the number of starting zeros same. Same is not allowed. I told you increasing, strictly increasing. Okay, same is also not allowed. It should neither decrease or it should not be same also. It should be strictly increasing. Okay, this is same. That means this is not in echelon form. This is not in the echelon form. Clear, everybody? It is not in the echelon form. Okay, so in such case, you can convert to the echelon form. In such a case, you can convert to the echelon form. What simple operation I will do? This is 1 and 2. This is increasing. Up to here, it was increasing. If this becomes 3 or 4, if this becomes 3 or more anything, then it can be increasing order. Then it can be echelon form. Okay. So what you have to do, you have to increase a 0 in the third row. Okay, you have to make this 0. So what will I do? This is an element of the third row, elementary row operation. You know that any transformation is applied to either entire row or either entire column. You cannot change a single element. So if I want to change this element 6, which is a row 3 element, let me use the above element 2. Okay, when you multiply 3 into 2, it will be 6 and then you can reduce. So I will multiply 3R2 entire row and then I subtract. So 6 minus 2 into 6, here I will get 0. So R3 will be replaced by R3 minus 3R2. Row transformation which does not change the value of the determinant. Okay. So how the determinant would be looking like then? 0, 5, 3, 0, 0, 2. And now see 0, 0 minus 0, 0 minus 0, fine. 6 minus 3 into 2. This also becomes 0. And now again keep counting number of starting zeros. 1, 2, now it is 3. M is equal to 1, M is equal to 2. M is equal to 3. ROZ is there at the last. That also okay. So all happy conditions. Yes, you have the echelon form. So rank is equal to how much? Number of non-zero rows. First non-zero, second non-zero, third is a row of 0. Third is a row of 0. Okay, so you have 2 non-zero rows, correct? You have the 2 non-zero rows. All right. You have how much? You have the 2 non-zero rows coming up here. Okay, next. And now, same example. I've done it. I've shown it you by 2 examples. By determinant method. Okay, by the dependency method. And now see the echelon method. If you apply the echelon method, okay, how many starting zeros here? Nil. Nil. There are no starting zeros. So definitely this is not an echelon form. This is 100% not the echelon form. We must have starting zeros which are increasing in pattern actually. Which are increasing in pattern. So this is 100% not an echelon form. Alright, so if this is not an echelon form, what I'm going to do? I'll again start the elementary row operations. So this element 4. Let the first M be 0. Here it should be 1 or more and here it will be further more. Okay, so first what I'm going to do, let's actually target these 2 elements together. Okay, and see the elementary operation 4. Okay, can be made 0 by 4 minus 4 into 1. Okay, so R2 minus 4R1. R2 will now be replaced by R2 minus 4R1. This is 7, so 7 minus 7 into 1. R3 minus 7R1. R3 will be replaced by R3 minus 7R1. Clear? R3 minus 7R1. Okay, so doing this, okay, what are the numbers inside the determinant? 1, 2, 3. First row I have not changed. 4 minus 4 into 1, 0. 5 minus 2 into 4, minus 3. 6 minus 3 into 4, minus 6. 7 minus 7 into 1, 0. 8 minus 7 into 2, minus 6. And 9 minus 7 into 3, this should be minus 12. Perfect it is. Right. Perfect it is. Now, have a look into this. Now the number of starting zeros. M is 0. M is 1. But M is 1 again. So this time here it is same. So one more 0 in the last row at least. Okay, one more 0. So let's target this now. Let's target this to make it as 0. So see, this is minus 6 and above is minus 3. So just multiply the above by 2. They will become equal and then you subtract. So what operation basically turning out to be? Okay, I have to subtract R3 minus twice of the above row. Okay, R3 to be replaced as R3 minus 2R2. Okay, so this becomes 1 and 2 and 3. Then you have 0 and minus 3 and minus 6 and then subtract 0 minus 0. Okay, this will also be 0. Minus 12 minus 2 into minus 6 is also 0. Okay, the last row totally becoming the 0. Okay, totally the 0. Okay, now you can count the number of starting zeros. Nil, 1 and 3. Whether it directly jumps to 3 doesn't matter. I told you it should be increasing. It increases by how much amount I don't care. Okay. By how much amount I don't care. Okay. But yeah, it is increasing. Okay. So now, and ROZ at the last. Okay. So this is clearly echelon form. Now this is clearly echelon form, and hence rank of the matrix is equal to number of non-zero rows. Number of non-zero rows. Number of non-zero rows, that is equal to 2. That is equal to 2. First row non-zero, second row non-zero, third is 0. Clear? To be honest, I told you, yes, never stop learning. Conventional, when I said it's a proper official conventional method, it is time consuming, but I'm telling you it as a backup. You know, sometimes by chance, worst case, if they talk about a 4x4 matrix, see, normally the determinant calculation or the dependency independency is the best. 99% of your problems will be solved, but you should have that backup. If there is a larger matrix, calculating determinant is taking a lot amount of time, and dependencies we are not able to see directly. Maybe there is a dependency, but I am not able to visualize it. So then this is the method to be used. And sometimes this method will also be used in the linear system of equation. That is also the reason I have told you in the questions based on infinite, no solutions, etc. Okay, so you should know it. The idea is you must be aware about this. Okay, no, the question Chandu will not mention that solve the question by echelon form. Okay, but yeah, let us solve the theme of questions. We'll understand where at all it can be used. Okay. Oh, great to know, Giritharan. Great to know. God bless you. So that is what, guys. That's what I believe that those who have prepared mathematics, this session will be a quick, good revision for them. Even if you are not prepared, so along with this session, take up some PYQs. Still, you can manage good marks in the examination. You can manage a decent good marks in the examination. Okay. Let's move ahead to the next question now. Okay. Right. What is the rank of this matrix? What is the rank of this matrix? Okay, Raj. Good morning, Guru Krishna. Okay, now see, what is the rank of this matrix? Now see, here, now some, miscellaneous questions. Here I am able to visualize there. See, the third row is same as the first row. That means dependency. Third is directly equal to the first. Okay, so there is one dependent row. So how many independent rows? 2 independent rows, and rank of the matrix is equal to 2. Rank of the matrix is equal to 2. Rank of the matrix is equal to 2. See, when it is 3 cross 3, dependency or determinant both are easy. No need to start echelon form. No need to start the echelon form at all. Okay. No need to start the echelon form at all. Okay. What else you can do if you don't see the dependency? Then what you can do? Okay. You can say that R3 is R1, but yeah, whenever there are dependent rows, a property of determinant, whether there is one or any number of dependent rows, determinant is 0. No need to calculate the determinant, but yeah, if there are 2 rows which are equal or dependent, okay, the determinant is always 0. Okay, determinant is 0, that means 100% rank cannot be 3. Now, checking a 2 cross 2 minor is not time consuming. If rank is not 3, I will check 2 cross 2, just like my first determinant method. Okay, so what is a 2 cross 2 minor? 1, 1, 1, minus 1. Check the value, cross multiply, minus 1, eventually minus 2 not equal to 0. So a 2 cross 2 minor not equal to 0, rank equal to 2. Option is C, finish. So for 2 cross 2, even determinant calculations are pretty much simple. Okay, for a 3 cross 3 matrix also, determinant method is also pretty much simple. Or if you see dependency, then the answer was just an observation. 1 dependent row, so 2 independent rows, and rank is number of independent rows or independent columns of the matrix. Have a look into the next problem and answer me. Okay, have a look into this matrix. Find the rank of A, which is 4, 2, 1, 3, 6, 3, 4, 7, 2, 1, 0, 1. Okay, 4, 2, 1, 3, 6, 3, 4, 7, 2, 1, 0, 1. What about the rank of this matrix? Okay, let's figure out. Okay, it's a 3 cross 4 non-square matrix, first of all. Okay, it's a 3 cross 4 matrix. Now, see a particular method here. See, I told you rank is number of independent rows or independent columns, anything it could mean. Sometimes observing the dependency in columns will be easier. Okay, so open your brain both the ways. Open your brain both the ways. See, what I can show you here is 2 plus 1, 3. 3 plus 4, 7. 1 plus 0, 1. So very clearly, the column number 4 is a combination of C2 and C3. When you add C2, C3, you're getting column number 4. Right? Good morning, MSD. What else? This is one observation. What else? Yeah, this is a clear observation. Okay. Numbers are, related by a factor of 2. Okay, this is 2 into 2, this is 3 into 2, this is 1 into 2. That means the column number 1 can be written as twice of column number 2. Can be written as twice of the column number 2. All right. Okay, column number 2. So you have two dependency. How many dependency? This time I have taken in columns. So you have two dependent columns. Okay, so there are 4 columns. So how many independent? Out of 4, 2 dependent or 2 independent column, and rank is equal to number of independent rows or independent columns. So 2 independent columns, rank equal to 2. Okay, rank is equal to 2. So remember, here 4 columns are there. So 2 dependent means not only 1 independent, 2 independent, because the columns are 4. So open your brain both the ways. Dependency in row and column, whatever it is, easy to see. Now what can I say? If the rank is 200%, there will be 2 independent rows. That also reverse is true. 100% 2 independent rows and 1 dependent row. But which row is dependent on how it is dependent? See, sometimes dependency on row you may not find directly. Why? Because, understand, 7R3 is equal to 4.1R1, okay, minus 6.5R2, something like this. This is also a dependency, na? So sometimes they may be dependent, but with some, random coefficient. This is also dependency, na? We can't deny it. So that is why there may be sometimes dependency which you can't directly see. Okay, so if you are not able to directly visualize on rows, you can try with columns as well. But I don't know what dependency, but 100% 2 independent rows and 1 dependent row will be there. Okay, rank is equal to both. If rank is 2 independent columns as well as 2 independent rows, that will not change. Okay. Okay. Rows are 3. So, Sai Shiva, what is your exact doubt? Rows can be any number. Na? Rank depends on the number of independent rows or independent columns. So, please elaborate your doubt. Have a look into the next question, dear. Have a look into this next question. Okay. Rank of 1, 2, 4, 2, 4, 8, minus 5, minus 10, minus 20. What about the rank of this matrix? Keep looking here. So, what can I say here, dear? Okay. If this is my R1, now have a look into it. Okay, the second row is just 1 into 2, 2 into 2, 4 into 2. Okay, just twice of R1. Okay, now if I call this as R1, to like 1 into minus 5, 2 into minus 5, 4 into minus 5. Completely satisfied. That means this is minus 5 R1. Minus 5 R1. Clear, everybody? This is minus 5 R1. That means the row 2 and row 3, there are 2 dependent rows. Both are dependent. Okay, so how many independent? Out of 3, 2 dependent. I am left with only 1 independent row, and rank of the matrix is equal to 1. The rank of such a matrix will always be 1. Okay. So whenever all the rows are proportional to each other, it's like a structure. It's like a structure R1 to R1 minus 5 R1. Okay. R1 to R1 minus 5 R1. Clear? Okay. If it is any case, important point, if all the rows of the matrix are identical or proportional to each other, okay, that means the rows are in this format. You have only one in row R1. The next is, something like AR1. Next is something like BR1. Next is something like CR1. All are dependent only on R1. Okay, so all the rows are proportional. There can be any proportionality number, 2R1, 5R1, 7R1, 100R1, anything. But whenever such a structure is obtained, rank is equal to 1, or vice versa also you can say, if the rank of a matrix is 1, it will only have 1 independent row, rest all will be dependent or proportional to the row 1. Clear, everybody? This is done. Okay, this is a general result. Okay, sometimes the questions can be in the word format. I mean, making you form the matrix. So can you form this particular matrix quickly? Can you form this matrix quickly? Can you form this matrix quickly? Yes, you can try to. Can you try to form this matrix quickly? Let's do it. Can you try to form the matrix quickly? Let A equal to Aij, 1 less than equal to ij less than equal to n greater than equal to 3. So now they are telling n greater than equal to 3. So try with n equal to 3, not a harm. And the nature of the elements Aij. Every element Aij. What is Aij element? Element in the ith row and jth column. That is product of Ij. Okay. So if I try with n equal to 3, suppose. Okay. What matrix can I form? Okay. This is A11. 1 into 1. A12. 1 into 2. A13. First row, third column element. Then coming to the second row. So 2, 1. 2, 2. 2, 3. Any element Aij is I into j. So that is how I'm forming the numbers. Then this is third row and first column. 3 into 1. Then 3 into 3. And then 3 into 3. Clear? So how the matrix is now formed? 1, 2, 3. Next is 2, 4, 6. Next is 3, 6, 9. You can write down this matrix in the format. If first is R1, second is nothing, twice of R1, and third is thrice of R1. Okay, all the rows are proportional. So what about the rank? All the rows are proportional. So rank is 1. Clear, everybody? The rank of this matrix is 1. Option number B. Right? Right? Chandu, I will do examples which are important for you for the first time understanding. Some PYQs also, if necessary, I will take. That's what I told you. At least PYQs, the complete PYQ set you have to try on your own. At least that part you have to do. Okay, I will take problems which are necessary so that every type of model of the, that particular topic is complete for you. Okay. Yes, some PYQs if necessary I will take. Wherever in topics necessary I felt I have taken also. Okay. But I don't commit all PYQs in the session. I complete the review. What I'm committing is the revision. Okay. Chalo. Next question, dear. Let us move to the next concept. And with the concept of rank, see, sometimes you can get the direct question on rank. Okay. Or linear system of equation where again rank is to be used. Okay. More commonly you get the question on linear system of equations. So let's do it. Let's do it. So consider a linear system of equation in 3 variables. Okay, 3 variables, written in the format of 3 equations. A11x, A12y, A13z is B1, A21x, A22y, A23z is B2, and A31x plus A32y plus A33z equal to the B3. Okay, converting this into the matrix format. Okay, so this A11, A12, A13 and this A21, A22, etc. These are the coefficients of x, y, z. Okay. I take a particular matrix A where I arrange the coefficient. First equation, first row, A11, A12, A13. Okay, multiplied by this vector x which contains the unknowns x, y, z. Then A21x, second row contains the second equation coefficient, A21x, A22y, A23z. And then similarly A31x, A32y, A33z equal to B1, B2, B3 respectively. And we write down the linear system of equation as AX equal to B. Okay, AX equal to B. Now, what is the size of A? Before I talk about any calculation, what about the size of A? Here you see A as a 3 cross 3 matrix. Here you say, see, why 3 rows? Because there are 3 equations. Number of rows is always corresponding to number of equations. Okay. And number of columns. Okay, why 3 columns? Because this is X coefficient, this is Y and this is Z. So why 3 entries in a row? Because there are 3 unknowns. There are 3 unknowns. So ideally, if I talk about the calculation, see, ideally if there are n variables, okay, you need n equations, like 3 variable, 3 equation, and hence the size of the A in general is n cross n, okay. Given that there are n variables, okay, but only m equations. Given m equations for n number of variables. In such a case, dear, first point to be noted is size of A will always be equal to number of equations into number of variables, m cross n. A will be m cross n. Number of rows correspond to number of equations, number of column corresponds to number of variable. That is one point. Clear, everybody? That is one point to be noted. So A is m cross n. A is m cross n. Also dear, if m is less than n, If m is less than n, ideally you need n variables, n equations, but if the number of equations are less than the number of variables, we also call the system as underdetermined system. We also call the system as an underdetermined system. If m is greater than n, okay, if more equations are given, as required, we call the system as overdetermined system. We also call the system as overdetermined system of equation, correct? So there can be two more cases, underdetermined, overdetermined, where m not equal to n. M may be less than n or m may be greater than. Ideally, we want m equal to n. For n variables, ideally we need n equations. So ideally, this matrix should be a n cross n matrix, okay, as I have taken in the first example. Now, the system of equations may be solvable, may be unsolvable, may be consistent, may be inconsistent. Okay, so let's come to the method and approach of the problems. As I'm telling you, my major goal will be towards the approach of the problem. So to comment on what type of solutions you will have, whether you will have a solution, whether you will not have a solution, if you have solution, how many solutions. Okay, so let me first call the matrix A as the coefficient matrix, because as I told you, A matrix just contains the coefficients of x, y, z. Okay, these are A11, A12s, etc., which are the coefficients of x, y, z. Clear? Okay, so matrix A is the coefficient matrix. Then we call A is to B as an augmented matrix. See, in general, what is the augmented matrix? Augmented matrix is a matrix, formed by combining two matrices within one. Like this much is A part, the column of B also included inside it, and this becomes a bigger matrix, which is known as the A is to B augmented matrix. Okay, augmented matrix. Okay, right. So now Cauchy's theorem. Cauchy's theorem says that the system is consistent. Consistent means will have some solution. System is solvable. Consistent also means solvable. Okay, will have some solution. The system is consistent. That means it will have some solution if rank of coefficient matrix equal to rank of augmented matrix. Okay, if the rank of A equal to rank of A is to B, it is solvable. It will have some solution. Some means either maybe one or more than one. Okay, so now let's come to this flow chart. This is actually more important. This flow chart actually will summarize everything, and let's learn with the problems more. Okay, so I have the linear system of equation Ax equal to B, where I told you n is the number of variables. The number of columns is number of variables. That is what we have kept till now. Now see, if both the ranks are equal, okay, if both the ranks are equal, rank of coefficient matrix, rank of augmented matrix, then I told you system is consistent, means solvable. Okay, so if R of A equal to R of A is to be, suppose equal to R, then the system is consistent. Okay, but if rank of A not equal to rank of A is to be, right, if rank of A not equal to rank of A is to be, then the system is inconsistent. Okay, inconsistent means not solvable, it will have no solution. Inconsistent means not solvable, and it will have no solution for sure. It will have no solution for sure. Clear? It will have no solution for sure. Okay, it is not solvable. Okay, contradiction. I'll show you with example. Okay, it is not solvable in that case. That is what we say. Okay. Now, if the system is consistent, how many solutions it will have? So a system is consistent if both the ranks are equal, suppose equal to R. So if both the ranks are equal and equal to number of variables, n is what? Number of variables. Right, number of variables, then the system will have unique solution. If both the ranks are equal but both are less than n, both are equal but less than the number of variables, then the system will have infinite solutions. Then the system will have infinite solutions, and then we'll work out with some questions to understand this. Before I take up a question, okay, inconsistent means contradiction. I'll explain you the meaning of this contradiction. Yes, Ricky and Sai Shiva, very recently, Hemant sir took EMF sessions, EMF marathon. That was the common syllabus for EC and EE. Okay, wherein, the vector calculus and all the other stuff, about electrostats and magnetostats was taken. And next, he is going to take EMTL for EC also. Very soon, in the next few days only, you are going to have the EMF session also for EC, exclusively for EC, EMTL, electromagnetics transmission line. Okay, so that session will also be there, also be coming up, okay, soon. Okay, for EC, stay tuned. Okay, stay tuned. Okay, now see here. Yeah, Yeshwar, don't worry. I'll repeat with example. Examples will only justify it. Okay, so Before I take an example, only thing is take this unique solution separately. What is the unique solution condition? Rank of A equal to rank of A is to B is n, and for m, ideally this is the size of A. I told you ideally A should be a n cross n matrix, and what you want, rank of A equal to rank of A is to be equal to n. That means eventually rank equal to n, rank of A equal to n, and A is a n cross n matrix. Okay, A is a n cross n matrix, assuming ideal case only. So dear, if A is a n cross n matrix, what can you say? Okay, A is a n cross n square matrix, and you want the rank equal to n. Okay, you want rank equal to n. That means full rank. What is the full rank condition, dear? Just now we have studied, na? For a square matrix to have full rank, it should have non-zero determinant. It must be non-singular. It should have non-zero determinant. Okay, so it will have full rank if determinant A not equal to 0. So if it is a unique solution, you can make it as a determinant question. Determinant not equal to 0, unique solution. Determinant equal to 0, then maybe infinite or no. Okay, then I don't say what is the result. Determinant not equal to 0 is unique. Determinant equal to 0, it may have infinite solution or no solution. Then there can be two conditions. Then there can be two conditions which we will confirm by the rank or some shortcuts that I will add on. Okay, so then the system is said to have unique solution. That unique solution is given by A inverse B. Okay, Ax equal to B giving you x equal to A inverse B. Okay, now come to a question. First question is only on unique solution. The first question is only and only on the unique solution. Have a look into it. For what values of K, the system of equations will have unique solution? For what values of K, the system of equation will have unique solution? Okay, so because it is on unique solution, you don't need any rank method, just confirm the determinant. Okay, if you want to have unique solution, what you want? Determinant A not equal to 0. Okay, so just put down these coefficients. A means the coefficient matrix. So coefficients of x, y, z, 1, 1, 2, 1, 2, 4, and then 1, 3, K. You just have to solve this determinant and this should be not equal to 0. That's it. This determinant not equal to 0. That is what you have to do. Okay, that is what you have to do. 1 into 2k minus 12 minus of 1 into k minus 4 plus of 2 into 3 minus 2 not equal to 0. That means 2k minus 12 minus k plus 4 and plus 2. This is not equal to 0. This is not equal to 0. Okay. So minus of 6, k not equal to 6, that means k minus 6 not equal to 0, so k not equal to 6. So it will have unique solution for all values of k except 6. Can I say like that? Option number C. K not equal to 6 will give you unique solution. Okay, all values of k except k equal to 6. Okay. Right, or they can also make it like a MSQ question. Okay, or they can make it as a MSQ question here. Okay, for what values of k the system of equation will have unique solution? Okay, will have unique solution. Okay, so option number A, okay, 2, option number B, minus 5, option number C, 6, option number D, 100. For what values of k it will have unique solution? Or any value of k not equal to 6, unique solution is confirmed. Any value of k not equal to 6. So in that case, what is the option you will mark? A answer, B answer, and D answer. Except 6, all the other options are okay. For any of the values that I have mentioned in the option, system will have unique solution except the C option. So then, from here they can make it as a MSQ question also. I hope that is clear. Okay. Now, this was a unique solution, so no rank discussion is required. Okay, clear? Next question. The following system of equation will have what? The following system of equation will have what type of solution? The following system of equation will have what type of solution? Unique, no, infinite, or 2. So now here they don't say unique solution. Okay, so we can't directly say determinant. Okay, we directly can't say determinant. We have to confirm what type of solution. Maybe unique, maybe no, maybe infinite. Let us see what type of solution. Let us see and check what type of solution it is actually having. Okay. Now see, I'll tell you the direct shortcut also, which works in again most of the problems. But before that, let's understand the official method, as I told you, the Cauchy's theorem. Okay, the Cauchy's theorem. And for Cauchy's theorem, I'll start taking the A is to B matrix. See, I will start with the A is to B matrix, the augmented matrix. Let me form that. Okay, so 1, 2, 1. First the A numbers, 1, 2, 1, the coefficient numbers. Then, where is that question gone? Sorry. Yeah, here 2 1 2. Next 1 1 1 is to the B matrix, which is having the element 6 6 5. Which is having the element 6 6 5. Clear? Now keep listening. These are having the element 6 6 5. Okay. So it's a non-square matrix. It's a non-square. Overall, A is to B is a 3 cross 4 matrix. Let me check. Again, the official method, conventional method, echelon form. Okay, is it in the echelon form? So number of starting zeros, M, nil, nil, nil. Okay, so let the first be nil only, but here I need to increase, here I need to increase more. Okay, so I'll start with the first column again. Let's make these two as 0 first of all. So what is the first transformation? 2 minus 2 into 1 to be applied on the entire row. We know that row transformations are applicable, or column transformation. So R2 minus 2 R1. What about R3? Directly 1 minus 1. So R3 can be replaced by R3 minus R1. Okay, so let's do it. And then what is the resultant you get? 1, 2, 1, 6. Okay, 2, 1, 2, 6. Sorry, R2 I am changing. Na? Okay, so 2 minus 2 into 1, 0. 1 minus 2 into 2, minus 3. 2 minus 2 into 1, again 0. 6 minus 2 into 6, minus 6. Okay. R3 minus R1, 1 minus 1, 0. 1 minus 2, minus 1. 1 minus 1, 0. 5 minus 6, minus 1. Now if I keep counting the number of starting zeros and just wait for the shortcut, okay? Okay. 1, 1. Starting zeros is again 1, 1. That is still same. That is still same. Okay, that is still same. So not in echelon form. Okay, previously I had all same, but now we got at least one increasing, but these two are same. So this also has to increase. So one more 0 to be added here, to be increased here. So how will I add this one more 0? Keep listening here. Okay, this is minus 1 and this is 3. So what I will do, I will divide it by 3. Let's divide this by 3. Okay, and when you divide by 3, this becomes minus 1 and then you can subtract them. Okay, then you can subtract them. So what is the transformation I'm going to apply? See here. Now R3 will be R3 minus R2 by 3. One, 2, 1, 6. Okay, 0, minus 3, 0, minus 6. Okay, now 0 minus 0, that is okay. This becomes 0. Again 0 minus 0. Now minus 6 by 3, minus 2. So minus 1 minus of minus 2 will become total plus 1. Okay, now see why I have taken the A is to B matrix, because any row transformation, listen, any row transformation you apply on the A is to B automatically gets applied to A also. A is hidden inside A is to B. So that is why you don't have to take the two matrices separately. Okay, now the starting zeros. Nil, 1, 3. Yes, now I have a increasing pattern. I have an increasing pattern. Now I have echelon form. Okay, now listen to me. What is the rank of A? Please listen to me. What is the rank of A first of all? A means only this much of the part. Whenever any matrix is in row echelon form, then the rank is what? Then the rank is number of non-zero rows, isn't it? Then the rank is number of non-zero rows. Okay, so for the A matrix, how many non-zero rows? 1 and 2. The third row for A is a row of 0. Clear? So for the A matrix, 2 non-zero rows. For A is to B. Now look into the complete bigger matrix. Non-zero row. This is also non-zero, and even if one element non-zero, entire row is non-zero. So for A is to B matrix, after converting to echelon form, still all the three rows are non-zero. All the three rows are non-zero. They are not equal. Rank of A not equal to rank of A is to B. That the system is inconsistent. It is not solvable. No solution. It will have no solution. This is the official method. Okay, now let's solve it even more quickly. That quicker method applies to most of the problem. Where it doesn't apply, you should know the background. Okay, okay, where it doesn't apply. But now let's come into it. First, okay, have a look into these numbers and the alternate method. The alternate method of solving it. Okay, alternate method of solving. Now please see here. just an arrangement of equations. What I'm going to do, dear, let's say these equations are named as respectively 1, 2 and 3, and I'm going to add the equation 1 and 2. I'll just add the equation 1 and 2. What will I get? Okay, x plus 2x, 3x, 2y plus y, 3y, z plus 2z, 3z is equal to 6 plus 6, 12. So cancel by 3. Cancel by 3. X plus y plus z, 12 by 3 will be 4. Okay, so if I add 1 and 2, the information is the sum of three numbers x, y, z should be 4. Equation number 3 says that x plus y plus z, same information is given by equation 3, but equation 3 says that, oh my god, equation 3 says that the sum of the numbers is 5. Whom should I trust? If I trust first and second person, they are telling, they have got some research and they told us x plus y plus z is 4. Third has done some other research and he is telling that x plus y plus z is 5. Whom should I trust? They don't agree to each other. That is what I meant by contradiction. This is what I meant by contradiction. Okay, when for the same information you have two arguments. Okay, so they are like arguing each other. No, somebody says 4, somebody says 5. So can they agree? They are not agreeing to each other. So tell me what are the values of x, y, z which have x plus y plus z 4 also and 5 also. Can anybody tell me? I'll give you a gift. Can anybody tell me the set of x, y, z such that the sum is 4 also and 5 also? Because when I say solving a system of equation means getting the value of x, y, z which will satisfy all of them simultaneously, which should make all the three equations happy. So can anybody tell me any set of value of x, y, z so that the sum of x, y, z is 4 at the same time 5? Impossible. Contradiction. Okay, they don't agree to each other. They will not be solvable. They don't come. See, when you are just into an argument, that means you are not able to come to a decision. You can't say what x, y, z. Somebody says 5, according to him some different value. Somebody says 4, according to him some different value. So it's non-solvable equation. That is why no solution. That is why no solution. Okay. So that is what the simple way I'll put down here. That is what the simple way I'll put down here. So what are the shortcuts you are supposed to use? See, unique already I told you. If it is unique solution, okay, det A not equal to 0. No need to enter rank. For no solution, okay, you have contradictory equations. You have contradiction in equations. They don't agree to each other. Okay, hope that alternate is clear to you. Any doubts you are open to ask. And if I talk about infinite solutions, similarly, I'll show you with next example. Infinite solutions are related to dependency in equations. If there is some dependency in equations. If there is some dependency in the equation, clear? If there is some dependency in the equation. Okay, so let's work out another question here. Okay, the system of equations is given to you. The system of equations is given to you. X plus y plus z is 6, x plus 4y plus 6z is 20, x plus 4y plus lambda z is mu. Find the values of lambda and mu for which the system has this. Unique and infinite and no. Unique solution, infinite solution, no solution. Unique solution, infinite solution, no solution. Tell me. Unique, infinite and no. X plus y plus z is 6, x plus 4y plus 6z is 20, x plus 4y plus lambda z is mu. Okay, now see, when it is only about unique solution or infinite or no, individually I will solve it by the shortcuts only. Individually I will solve it by the shortcuts. Okay, so if I have to talk about, first let's talk about infinite and no solution. See, pick up these two equations actually. X plus 4y, this is clearly common. X plus 4y, this two is common in the equation 2 and 3. Okay, so dear, what will I say that? Suppose if lambda is equal to 6, if lambda is equal to 6, then equation number 3 looks like equation number 2. X plus 4y plus 6z, they will talk about the same information and this is equal to mu. Clear? First I am taking lambda 6. Okay, solving by intuition, solving by shortcut, not going for the ranks. You can go for rank. I've shown you echelon methods. I've shown you in the rank also. I've shown you with the previous question also. I hope you can do it. Okay. Now, x plus 4y plus 6z equal to mu. If lambda is 6. Okay. But now, dear, what if mu not equal to 20? Because x plus 4y plus 6z as per equation number 2 is 20. Okay, so x plus 4y plus 6z should have only one value, na? It should have only one value, na? X plus 4y plus 6z should be 20, na? So mu should be 20. Actually, if lambda is 6, then mu should be 20. But if I say mu not equal to 20, that means the equation number 3 now becomes x plus 4y, that part is same, x plus 4y plus 6z is equal to mu, but mu is not equal to 20. Whereas equation number 2 will say that x plus 4y plus 6z equal to 20. What is happening? Again, they are fighting. Somebody says 20, somebody says not equal to 20. They don't agree. Somebody says 20, somebody says not 20. They don't agree. Again, what is happening, dear? Okay, again, this is contradiction. Again, this is contradiction, and the system of solution will have the system of equation will have no solution. So what are the values of lambda and mu for the system to have no solution? My answer would be lambda equal to 6, okay, but mu not equal to 20. If I take lambda 6 but mu not equal to 20, if I take lambda 6 but mu not equal to 20, there is a contradiction, and that leads to no solution. That leads us nowhere. Clear? Now at the same time, okay, this lambda equal to 6, let this be fixed. Okay, let this be fixed. Okay, now if mu was equal to 20, okay, mu was equal to 20, how the equation number 3 will now look like? X plus 4y plus lambda z, lambda is already 6, x plus 4y plus 6z is equal to mu is equal to 20. Equation number 2 also says the same thing, x plus 4y plus 6z equal to 20. Okay, that means you now have dependency in equation. Equation number 3 is just replicating equation number 2. That is a dependency, either directly equal or twice of R2 or something like that. And as I told you, whenever there is dependency, the system of equations will have infinite solution. The system of equation will have infinite solution. You can confirm by Rouche's theorem, but not required. If you follow the shortcuts, you can save your time. So what is the condition for the system to have infinite solution? Now for the system to have infinite solution, lambda equal to 6 as well as mu equal to 20. Lambda equal to 6 as well as mu equal to 20. Only thing is, if I want to have unique solution discussion, so for unique also I told you, no rank required. That is simple, determinant. That is simple, a determinant calculation. So what is that determinant calculation? Let's do it. Okay, for unique solution, I'll just take determinant not equal to 0. That is what I am looking for. Okay, so what is the determinant? Determinant of the coefficient matrix. So the numbers are 1, 1, 1. Second is 1, 4 and 6. And third is 1, 4 and lambda. 1, 4, lambda. Okay, this should be not equal to 0. Okay, so 1, 4 lambda minus 24 minus 1 into lambda minus 6 plus 1 into 4 minus 4 not equal to 0. So 4 lambda minus 24 minus lambda plus 6 not equal to 0. So this tells you that 3 lambda not equal to 18. That means lambda not equal to 6. Reverse of the previous two cases. In the previous two cases, lambda was 6. Then whether mu 20 or not 20 gives you the infinite or no solution. But if lambda itself is not equal to 6, then the system of equation will have unique solution. So unique solution, lambda not equal to 6. That's it. What about mu? In the determinant of A, there is no mu. There is no role of the mu. That means what can I say? I can say that in that case, I can say that mu can take any real value. Mu belongs to R. Mu can take any real value. Mu belongs to R, set of real numbers. Mu belongs to set of real numbers. Mu can take any real value. Not required for unique solution. Mu is required for infinite and the no solution. It will be required for the infinite and the no solution. Clear, everybody? Clear, everybody? Now next case. Let us have a look into the next case and next question coming up here. Okay. Given the system of equations, x plus 2y plus 2z is b1, 5x plus y plus 3z is b2, which of the following is true regarding the solution? Now you see here. Firstly, what type of case is given to here? Okay, there are three variables still. x, y, z, but two equations, underdetermined system. As I told you, there are two more cases, underdetermined and overdetermined. If less equations, underdetermined, more equations, overdetermined. Less equation, underdetermined, more equations, overdetermined. Okay. In underdetermined, dear, in underdetermined, I will just show you unique solution, never possible. Unique solution, never possible, whatever the numbers are given. See why? Because you still go for the official method, no problem. Okay, I don't know dependency is there or not because B1, B2 is not known. Na? If the numbers are not known, so we can't decide the dependency. So what will I do here is, let me write down the A is to B matrix. Again, the full official method, like our first question. Okay, what is A is to B? 1, 2, 2. And then the second row will be 5, 1, 3. Here it will be B1 and B2. Here it is the B1 and B2, correct? B1 and B2. Correct? Okay. Now, to convert this to the echelon form, this is 5 because number of starting zeros are not there. So, I'll have it as this element 0 by 5 minus 5 into 1. So, R2 I am doing R2 minus 5R1. R2 minus 5R1. Okay. As per this calculation, the numbers that are going to be left is 1, 2, 2 is to B1. Now 5 minus 5 into 1, 0. 1 minus 5 into 2, minus 9. 3 minus 5 into 2, so minus 7. And then B2 minus 5B1. B2 minus 5B1. Okay. Now, clearly I have made one starting 0. So if I talk about M, which is equal to 0, if I talk about M here, which is equal to 1, it is echelon form. Okay, now increasing means echelon form. Increasing means echelon form. So what is the rank of A? Rank of A. This part is A. A also has two non-zero rows. Rank of A is to B. A is to B, whatever the value of B1, B2, dear, whatever is the B1, B2, but these are non-zero. Na? So second row of B also non-zero. That means B also has both non-zero rows. Okay, the number of non-zero rows, the rank of A is to be also equal to 2. So my conclusion looks like both the ranks are equal. Both the ranks are equal. Okay, but less than the number of variables because my number of variables are still 3, but both the ranks are equal to 2. Both the ranks are equal but less than the number of variables. In such a case, we have what type of solution? In such a case, we have infinite solution. For any value of B1, B2, anything, both the rows are non-zero because of these numbers. Okay, so the system has infinitely many solutions for any given B1 and B2. And now dear, let me also tell you that whenever it is underdetermined system cannot have unique solution. Why? Because there are three variables, understand like this. Unique solution can only come if determinant of A not equal to 0. Okay, but if you want to form A as a square matrix, what is the third row you will take? There is no third row, so you can assume it as 0, 0, 0. And if an entire row of A is 0, its determinant will always be 0. Okay, determinant of A is 0, unique solution never possible. Unique solution never possible. So whenever it is underdetermined, okay, let me put it as a point here. Unique solution for underdetermined never possible. Okay, so it may have infinite solutions or no solution. If contradiction happen, no solution can be there. But right now we got unique solution. System will have infinitely many solutions for any given B1 and B2. Clear? So whether it is underdetermined or overdetermined, our Rouche's theorem is general. Okay, it can be applied any value of M or N given. Any value of M or N given. Okay, so if this is clear, I will give you one homework right now. I'll give you one homework. Okay, now this is a homework problem for you. You have to try out and later on put your answers in the comment box. Still I have three variables x, y, z. Okay, but four equations. Okay, overdetermined system. I told you in the beginning such a system is overdetermined system. Okay, Overdetermined system. The number of solutions for this system is how much? NAT question. Yeah, you can check 2 cross 2 minor also, Nitin. That's okay. For the previous question, you can even check the 2 cross 2 minor. That also fine. This 2 cross 2 minor non-zero, rank of both of them is 0. That also is okay, Nitin. That also is okay. Okay. Done, dear. So system is overdetermined given here, number of solutions. But I'm telling you now, whether it is ideal system or underdetermined or overdetermined system, you can apply Cauchy's theorem anywhere. Okay, you can apply the Cauchy's theorem anywhere. Now next, homogeneous system of equation. See, AX equal to B, the type of system that we were learning right now is more commonly known as a non-homogeneous system of equation. We started with that non-homogeneous, but if all the right side coefficients are 0, the equation is like a11x plus a12y plus a13z equal to 0. Similarly, the next equation also converts to 0, third also converts to 0. That means entire B matrix will be 0. We call it as null matrix. Okay, the entire B matrix will be null matrix, and AX equal to null or AX equal to 0 is said to be a homogeneous system of equation. AX equal to null or AX equal to 0. Yeah, correct, P. Okay, either for AX equal to 0, this for the null matrix on the right side, we call it as a homogeneous system of equation. But one thing, first thing that is sure for any homogeneous system of equation, see, the first thing, you try x, y, z 0. Whatever be the coefficient, dear, whatever be the coefficient, 0, 0, 0, you will be 0. Again, 0 plus 0 plus 0 is 0. Again 0 plus 0 plus 0, because whatever coefficient you multiply by 0, the net result is 0. So again 0 plus 0 plus 0 will be 0. Okay, so satisfying all three. And if a set of values of x, y, z which satisfies all the three equations simultaneously is known as a homogeneous is known as a solution. So what is a solution? Blindly, without knowing the values of the coefficients also, blindly what I am able to say that x equal to y equal to z equal to 0 is always a solution. Is always a solution. X equal to y equal to z equal to 0 means, if I talk in terms of the vector x, y, z, if I talk in terms of the vector, that also is a null vector. Simple, na? Because the homogeneous system of equation is Ax equal to null, so Ax equal to null or Ax equal to 0, so A into 0 will also be 0. Simple. A into 0 will also be 0. Okay, A into 0 will also be 0. Right? We can say like that. Clear, everybody? A into 0 will also be 0. So 0, 0, 0 is always a solution. That means that this system is always solvable. This particular system is always solvable. There is nothing like, that system may have, no solution. Now, because it is always solvable, it may have one solution or more than one, unique or infinite. That we have to figure out. Okay. So see, 0, 0, 0 is always a solution. The same thing I told you. 0, 0, 0 is always a solution. Okay. That means the system of equation, okay, is always solvable, or it may have maybe one solution or more than one solution. Okay, so when I talk about the system of equation Ax equal to 0, okay, it can have only two cases: unique solution or infinite solution. There is no third case. There is no third case. Okay, unique solution will be here named as a trivial solution. Infinite will be named as non-trivial. I'll tell you the reason behind that. Okay, but first tell me what should be the condition for unique. Unique condition we already know, na? Unique condition we already know, that is determinant not equal to 0. So if determinant A not equal to 0, unique solution is guaranteed. Okay, but if determinant equal to 0, then infinite. See what I told you earlier. If determinant equal to 0, the system may have infinite or no. But in case of homogeneous system of equation, okay, no solution condition not possible. There is always a solution. At least one solution is always there. System is always consistent. No solution is gone. Okay, so then we can clearly come to the determinant method. No rank again can be taken here. Again, assuming A to be square. If A is not square, then the same condition I will put down. Okay, for unique, the rank of A, okay, should be equal to n. Okay, if A is n cross n, then this condition can be noted. If A is n cross n, then this condition can be noted. Okay, now, so one thing is no solution condition is eliminated here. Okay, now let's keep learning with some more example. We'll come to it. Now I call this unique solution as trivial. Okay, related to trivial. Now unique means only 0, 0, 0 is solution. Arey, what is great in the 0, 0, 0? What is so great in the 0, 0, 0? My homogeneous system of equation is Ax equal to 0. Okay, take any matrix of the world. Take any matrix of the world, multiply by 0, because x equal to what? X equal to 0. X equal to null. So take any matrix of the world, multiply by 0, it will give you 0. Take any number of the world, multiply by 0, it is 0. We know it from childhood. What is so great in that? So this is almost a meaningless talk. Isn't it a meaningless talk? We know it from childhood. Anything multiplied by 0 gets converted to 0. Okay, and hence this particular type of case we call it as trivial. Trivial means something which does not give any useful information. In a way, meaningless. In a way, meaningless. Okay. Okay, so if you only get unique solution, if you only get 0 solution, then it's a unique, meaningless case. Okay, whether there are some non-zero values of x, y, z that will fit or not. Okay, now see here for this case. See here for this case. Okay, first, so as I told you, only determinant would be required here. Only determinant would be required here. So first, let me check the determinant of the coefficients. Coefficient matrix 1, 2, minus 3, 1, minus 1 and 0, 2 and minus 4 and 2. So now here, please check the determinant and let me know what type of solution you are expecting, unique or infinite, trivial or non-trivial. Just allow me a minute and do it out quickly. Simple determinant calculation. Okay, fine. Let's continue. Let us continue. Okay. So what is the determinant if you have got it? What is the determinant? So let me quickly solve it. It is 1, then minus 2 minus 0, minus of 2 into minus 4 plus 2, and then again minus of 3 and minus 4 and plus 2. Okay, so minus 2, minus 22 minus 2 plus 4, and this turns out to be minus 2 minus plus 6. What I have done, minus 2, then minus of 2 into, oh sorry, this number went wrong, sorry. Just a second. Minus of 2 into 2 minus 0, then minus 3 into 4 plus 2, correct? So minus 2, okay, this is 2 to 4, minus 4, and have I put any number wrongly or what? Why I am not able to get the correct answer? Plus of minus 3, and this is, sorry, minus 4 plus 2, now correct. Minus 2 into minus 3 plus 6, yeah, it will be 0, sure, yeah, it will be 0. Determinant 0, got it everybody? Determinant 0. Now as I am telling you, determinant equal to 0 should correspond to infinite solution or non-trivial condition. Okay, should correspond to infinite solutions. Infinite or non-trivial. Okay, now what are those non-trivial solutions? Let us talk about the solutions here. Let us talk about the solutions here. See, then at the end I will summarize from homogeneous system of equation what type of questions are important for you. See, the first solution, of course, is 0, 0, 0. This is always a solution. Blindly I told you 0, 0, 0 is always a solution. Nothing to think. Okay, in homogeneous system of equation. But I am expecting infinite solution. I'll show you how. Try 1, 1, 1. 1 plus 2 minus 3 will be 0. 1 minus 1, 0. Again try 1, 1, 1 here also. So 2 minus 4 plus 2 is again 0. That means 1, 1, 1 is also a solution. Okay, 1, 1, 1 is also a solution. Got it? Na? Try 1, 1, 1. All the three equations satisfied, and hence it is a solution. Hence it is a solution. Now if 1, 1, 1 is a solution, okay, you can even try 2, 2, 2 as a solution. It will work. You can try 5, 5, 5 as a solution. You can try, anything. 18, 18, 18. You can try any such combination. Everything is going to work out. Everything is going to work out. Okay. So this one, to okay, null solution. Okay, but let's say if this is x, the rest solutions that will be obtained is like 2x, 5x, 18x, or any multiple of x, or any multiple of x. Clear everybody? Any multiple of x. These are so like this you can frame infinite solutions. Like this you can frame infinite solutions. Okay. So dear, these are infinite solutions, infinite meaningful solution. The null solution was anyways meaningless, trivial, I told you. There are infinite solutions, but out of the infinite, what I am able to see, dear, out of the infinite, okay, the solutions are more or less similar only. X, 2x, 5x, 100x, 200x, they are more or less similar. There are infinite cases, but actually only one solution which is independent, rest are dependent on the x only. Suppose I call it as x. This is 2x, 5x, 18x, etc. So you have infinite solutions, but only one independent solution. Only one independent solution. Now, how will you quickly tell how many independent solutions? How will you quickly tell how many independent solutions? So have a look into some important results. As I told you, if 0, 0, 0 is the only solution, then the system is said to have trivial solution. I already defined for you. So if there are some non-zero solutions, so if there are some non-zero values which satisfy the system of equation, then we say that the system has non-trivial solution. Okay. Now look into the flowchart. Ax equal to null, homogeneous system of equation. Okay. It will have unique solution. Okay. Determinant A not equal to 0, or let me put it like this, rank of A equal to n in general. Okay. So vice versa, if determinant of A equal to 0 or rank of A less than n, then we will have infinite solution. Unique means trivial, only one solution, 0, 0, 0. Okay. Infinite means non-trivial. That means like our case, we got some non-zero solutions like 1, 1, 1, 2, 2, 2, etc. If the system has infinite solutions, how many of them will be independent? Look into it, no derivation required, but there will be, okay, there will be n minus r independent solution, where n is the number of variables and r is the rank of the matrix A. R is the rank of the matrix A. So if I go to the previous case, dear, if I go to the previous case, have a look into it. What is the rank of this matrix? Okay, so we got, have a look into this discussion here. We got determinant equal to 0. That means the rank of A cannot be 3. Cannot be 3. Now I check a 2 cross 2 minor. Just applying the determinant method only. 2 cross 2 minor I am checking, and this is equal to minus 1, minus 2, not equal to 0. This is not equal to 0. That means determinant, the rank of A will be 2. It was not 3, so I check for 2, and I have a 2 cross 2 non-zero minor. The rank is 100% 2. So I'm telling you how many independent solution. There will be only one independent solution, because the number of independent solution is given by the formula n minus r of A. N minus r of A. N is the number of variables. How many variables? 3. Minus rank of A. Rank of A means 2 here. So 3 minus 2, 1. Okay, that is why we will have only one independent solution. Okay. N minus rank of A. N minus rank of A, where n is the number of variables. How many variables? See, n, as I told you earlier also, number of variables or number of columns. Okay, directly a matrix also may be given. So number of variables will always correspond to number of columns. Number of variables will correspond to the number of columns. R is the rank of the matrix, as I told you. There is always n minus r. This concept also to be used in the eigenvector discussions. Okay, eigenvector discussion. Clear everybody? Clear everybody? Okay, right. So now let's come to next concept. They can talk about is the null space of the matrix. They can talk about is the null space of the matrix. Now, what is the meaning of the null space? Let's go back to our previous question. Our previous question, we are trying to solve the homogeneous system of equation Ax equal to 0. In the previous case, we are solving homogeneous Ax equal to 0. Okay, what are the values of x? These can be the values of x. Okay, this is the meaningless, that is a null solution which will always be there. Okay, so if I take 1, 1, 1, what can be this x? Okay, it may be 1, 1, 1, it may be 2, 2, 2, or as I told you, it may be anything of the form k, k, k. It may be anything of the form k, k, k. So there is a set of vectors x. What is that, dear? There is a set of vectors x which multiplied by a, which when multiplied by a converts the matrix into a null matrix. converts the matrix into the null matrix. Okay. Such independent vectors, okay, such independent vectors, only the list of such independent vectors will come inside the null space. Null space, or you can also call it as null set. The set of independent vectors. Okay. Null space, what is a null space? Okay, the set of all non-zero, I told you 0, 1 is the trivial, meaningless one. The set of all non-zero and independent vector x, which converts the matrix into a null matrix, will constitute the null space of the matrix. And the dimension of the null space, dimension means how many such vectors are there, how many such independent vectors, is known as the nullity of the matrix. Is known as the nullity of the matrix. So as I told you, the nullity means how many such independent vectors. Same formula, n minus r. So nullity is n minus r. N minus r. In general, look into the general case. N is the number of columns or number of variables. R is the rank of the matrix A. R is the rank of the matrix A. Okay. So if you want to talk about the null space for this matrix, null space of the matrix A. Okay. So what is that null space? As I am telling you, null space. Space is like set of vectors only. Okay. It is set of which vectors? The set of vectors which converts, okay, which converts the set of only the independent vectors, like that, otherwise there will be infinite solution. So in our case, how many independent solution? Only one independent, suppose x, rest are all 2x, 5x or 100x or etc. Okay, the set of the independent vectors, independent and non-zero vectors, which converts the matrix A into null, will be inside the null space. So what I will keep inside the null space? 1, 1, 1. Let me call this one as independent, rest all are dependent. Okay, or your choice. Your choice. You can call this one as independent. Suppose you say this is your x. So this becomes x by 2. Okay, this becomes 2.5x. Point is only one independent solution. Which one independent? Your choice. That I cannot say. Somebody can say this is my x, so this becomes x by 2. That is your choice. But the point is only one independent solution. Rest are dependent. Okay, so inside the null space, how many independent vectors are coming? Only one. And what is the nullity? Nullity equal to 1. As I told you, nullity is given by n minus r of a formula. N is the number of columns of A, minus rank, as I have already shown you, is 1. Okay. So, there can be questions around this nullity or null space concept also. So, we have revised that also. Now, have a look into this question, dear. GATE 22 MSQ 2-mark question. GATE 2022 MSQ 2-mark question. Let's solve this, dear, quickly. GATE 2022 and a MSQ and a 2-mark question here. The system of linear equations in xy is given by, this is not equal to, this is multiplied, xy is multiplied, it is given this way, it is actually given this way, xy written in the row format, multiplied by 2 and 5 minus 2 alpha and alpha and 1 is equal to 0, 0. Involves a real parameter alpha and has infinitely many non-trivial solution. What they are telling? It has infinitely many non-trivial solution for some special values of alpha. See how the equation will look like, dear. Once again, if you open the first row and first column, 2x plus alpha y, right side 0. Then first row with the second column, so 5 minus 2 alpha multiplied by x plus of y equal to 0. So what you are given is right side 0, 0. You can understand this is a question on homogeneous, and it will have non-trivial solution. Okay, A is a 2 cross 2 matrix. Now it will have non-trivial solution. That means you want determinant of A equal to 0. It will have non-trivial solution for some special values of alpha. Okay, determinant of A equal to 0. What is the coefficient matrix? 2 and alpha. Okay, and 5 minus 2 alpha and 1. These are the coefficients. 2 and alpha, 5 minus 2 alpha and 1. This is equal to 0. Okay. Or even you can take the determinant of this also. This is like transpose, and A transpose will have the same determinant always. Okay. So when you check the determinant of this number, what are you going to get, dear, is 2 and then minus 5 alpha and plus 2 alpha square equal to 0. Okay. So what are the values of alpha? Okay, you have 2 alpha square minus 5 alpha plus 2 equal to 0. You solve it up. 2 plus 1 by 2, 2 by 2, 1. Correct. Dear, you can solve by the quadratic formula also. Let me give you the values of alpha actually, which will be 2 and 1 by 2 here. Okay, which by sum and product I have guessed it. You can solve it on your own. So the value of alpha, there are, I'm telling you the system will have non-trivial, infinitely non-trivial solution for some special values of alpha. What are that special value of alpha? 2 and 1 by 2. Now what they're telling, which one or more, MSQ question, one or more may be correct. Which one or more among the following options is or are non-trivial solutions of xy for such special values of alpha? For such special values of alpha. Let us solve it. For such special values of alpha. Okay, for such special values of alpha. So let me take the first case now, alpha equal to 2. If alpha is equal to 2, how your equations will look like? Okay, 2x plus 2y equal to 0. And second equation, alpha is 2, so 2 minus 4, 1, so x plus y. Okay, it is one and the same thing only, dear. This means one and the same thing. If x plus y is 0, automatically 2x plus y equal to 0. So x plus y equal to 0. So can there be any option which satisfies x plus y equal to 0? Understand the theme of the question. So yes, 2 and minus 2 0, 1 plus 1 not 0. This is also not 0. X plus y not 0. Yes. So at least option number A will satisfy. Okay. Option number A will satisfy. If I take alpha equal to 1 by 2. Okay. How the equations will look like? See the equation here, 2x plus alpha y, alpha is 1 by 2. So 2x plus y by 2 equal to 0. Second, 5 minus 2 alpha, alpha 1 by 2, so 5 minus 1, 4x plus y equal to 0. Now both of them are again similar only actually. Both of them are similar only. Okay, you multiply the first equation by 2, you get 4x plus y. Yeah. So let us take this, 4x plus y equal to 0. 4 times x plus y should be 0. Okay, so is there any solution here? Okay, 4 times x minus 4, then plus 4, 0, perfect. B option will satisfy. 4x plus y will be 5 here. 4x plus y here definitely not 0. So yes, B option will satisfy this. Okay, so there are two options, okay, correspondingly given for two values of alpha, and my correct answer to be chosen is option number A and option number B. Okay. Option number A and B. Yes, Manas, be correct answer. So a good way of framing a MSQ question. Okay, two solutions corresponding to two special values of alpha. How did I get the special values of alpha? They told that system has infinitely many non-trivial solutions for such special values of alpha, for some special values of alpha. Okay, so non-trivial solution means that A equal to 0, and we got a quadratic equation, the roots were 2 and 1 by 2. If they ask for what values of alpha will the system have non-trivial solution, then the answer stops at this, alpha is 2 and 1 by 2. Correct, dear? Next question. Again a GATE 22, 2 marks MSQ question. A GATE 22, 2 marks, another MSQ question. Okay. A is a 3 cross 5 non-square matrix. Okay. 3 cross 5 real matrix of rank 2. Okay. For the set of homogeneous equation, question is on homogeneous equation. Okay. Where 0 is a 0 vector and x is a unknown variables as always. Which of the following is or are true? Which of the following is or are true? Okay, again please note that this is a MSQ question. Okay, the given set of equations will have a unique solution. Is it true? Is it true? See, A is 3 cross 5. 3 cross 5. We call it as M cross N non-square matrix. Given that the rank of the matrix is also given. It is a 3 cross 5 real matrix of rank 2. Okay, so whether the rank of A is equal to N? No, it is not equal to N. This is N. N means the number of variables. N means the number of variables. So rank of A not equal to N. Okay, so it will not have unique solution. So it will have what type of solution? Infinite solutions. Okay, infinite or non-trivial solution. Okay, conceptual question it is. It will have infinite solution. Okay, so A option is wrong in that case. A is wrong, but C becomes correct. It will have infinitely many solutions. Correct. Okay. Now, let's talk about B. Before that, have a look into the D option. The given set of equations will have a many but finite number of solutions. Never possible. If it has many means infinite, whether it is homogeneous or non-homogeneous. Finite number of solutions, not possible at all. Either it will have one or more than one means infinite. Okay. So C correct. What about B? The given set of equations will be satisfied by a zero vector of appropriate size. See, homogeneous system of equation. Homogeneous system of equation. X equal to 0. Always a solution. Na? Okay. So yes, B option correct. It will be satisfied by a zero vector. It will be satisfied by a zero vector of appropriate size. Yes. So X equal to 0. Which appropriate size? Can you tell me? X contain number of unknowns. Now, how many unknowns? 5 unknowns. Okay. Which size? It will be a 5 cross 1. There will be 5 unknowns. There will be 5 unknowns. If they ask, it will be satisfied by a zero vector of which size? 5 cross 1. You should know everything. Okay. So, B option also correct. Right now, they are not concerned on size, but some zero vector will satisfy. Yes, homogeneous system of equation X equal to 0 is always a solution. X equal to 0 is always a solution. Okay. Right, a finite number of solutions. Okay, let me put it this way. This case, finite number of solution will never come. Either one or more than one means infinite. Okay, either one or infinite if there is a solution. Even in the non-homogeneous also. Clear everybody? Okay, the given set of equations will have a many but finite number of solutions. No dear. Okay, no dear. Right? Okay, next question. Okay, so next, let us revise the very important topic, eigenvalues and eigenvector. The very, very important topic of the eigenvalues as well as the eigenvectors. Okay, so have a look into this. Okay, the very, very important topic of eigenvalues and eigenvectors. Okay, so till now you talked about the linear system of equation. Okay, where AX equal to B or non-homogeneous system, that was a non-homogeneous or homogeneous system of equation at AX equal to 0. The A into X transformed to some other matrix B, A into X transformed to null, okay, was a homogeneous, okay, and then we defined the null space of the matrix, okay, the set of vectors which transforms the matrix into null, which transforms it into null is a null space, okay, that actually makes the null space, clear? But the set of those vectors, okay, but for the set of those vectors, okay, where AX turns out to be, the transformation is such that the output is a multiple of the input. Let's say X is my input vector of any size. Okay, I apply to it to a linear operator that is defined by the matrix A, and we are getting the output which is lambda into X. Okay, in a way, what I am getting, the output A into X turns out to be proportional to X. Whatever X you applied, you get the output as maybe 2X. Earlier you were getting the output as 0 or some other constant. Okay, but you get the output as maybe 2X or 5X or 100X. But when you apply X and you get the output as multiple of same X, okay, such X will be named as the eigenvector, and we introduce a constant of proportionality known as lambda, and the equation becomes AX equal to lambda X. Okay, when AX is proportional, okay, when AX comes out to be proportional to X, such a X is known as the eigenvector. Okay, and this proportionality constant, this multiplication factor will be defined as eigenvalue. Telling you in brief, not deriving, not showing you the geometry of it. Okay, let's take it as a proper revision case only. Now, that is what, Gajendra, that is what, no, and again understand, your point is correct. A is 3 cross 3, maximum rank is 3. Now, what is 3 cross me means M is less than N, underdetermined. Na? So, what I told you, it is like underdetermined, Gajendra. And for underdetermined, in unique solution, never possible. Trivial, never possible. So, for that system, non-trivial only will come, even if the rank of A is 3. That is why I have clearly told you, rank should not be the full rank. Rank of A should be equal to N. What I told you in the flowchart also, if it is a square matrix, you can go for determinant. Otherwise, rank of A equal to N, where N is the number of variables. N is the number of variables. Okay, so in our previous question, Gajendra, okay, in our previous question, because A is 3 cross 5, number of equations less than number of variables underdetermined. So underdetermined, I told you one conclusion, in unique solution, never possible. Okay, so it will be non-trivial only. Even if the rank is 3, then also it will not be having trivial solution. Clear? Chalo. But a valid doubt, you should have, such approach, such thought process open. Okay. So that is why every time rank should be equal to N. If it is non-square, it should be number of variables. Okay. All right. So, so let's define it quickly. The non-zero input vectors X, again non-zero. Because again, if you say, okay, I applied 0 input to the system, I obviously get 0 output. No input corresponds to no output. And then I say, okay, my output is multiple of input, proportional to input, but that is again meaningless. Na? That is again meaningless. Okay. So we'll only talk about the meaningful solution, that are the non-zero input vectors x, for which output is parallel to or proportional to the applied input vector. Okay, as I told you, the output is parallel or proportional to x itself. Okay, such vectors are known as eigenvectors. Any x satisfying it will be the eigenvector. And the proportionality constant, which I introduce as lambda, okay, will be the corresponding eigenvalue. Okay, will be the corresponding eigenvalue. Okay, so we have to start with the equation ax equal to lambda x. Okay, so very briefly I have defined it, and let's work again more on the questions model. And very, very important in eigenvalue, eigenvector is the set of properties of eigenvalue and eigenvector. Okay, so yeah, before I talk about any 2 cross 2 matrix, see, I am starting with the equation ax equal to lambda x. Okay, bring everything on the left side. So when you bring it on the left side, x will be constant. Okay, a minus lambda into I. X can also be written as I into x. So that with matrix, you always subtract or add a matrix only. Okay. So what type of system you have got? A minus lambda I into x equal to 0. Okay, just like bx, some matrix, suppose bx equal to 0, which is known as homogeneous. And what you want? You want non-zero solutions. Okay. You want non-zero. Non-zero means non-trivial solution. So for non-trivial solution, what is the condition? For non-zero solution, what is the condition we have learned right now? Assuming square case only, determinant of this matrix B equal to 0. That means determinant of which matrix? B means here A minus lambda I. Determinant A minus lambda I equal to the 0. Determinant A minus lambda I equal to 0. This is what is known as the characteristic equation. In short, I will keep calling it as CE. This is what is known as the characteristic equation of the matrix. This is what is known as the characteristic equation of the matrix A. Known as the characteristic equation of the matrix A. Clear? Modulus of A minus lambda I equal to 0 is known as the characteristic equation of the matrix A. Okay, and the roots of this characteristic equation will be the lambda, will be the eigenvalue. Okay, so that means to find lambda, you have to find the roots of the characteristic equation. Now, if it is, if you talk about a direct question, mostly 2 cross 2, 3 cross 3, questions are there on higher order matrix, but usually through some techniques of property. Okay, before I go to property, let me take a 2 cross 2 and 3 cross 3. But what I have seen, even for 2 cross 2 or 3 cross 3, many times students are just using the direct characteristic equation, modulus A minus lambda I. See, the general characteristic equation is always modulus of A minus lambda I equal to 0. That is very correct. Okay, the general characteristic equation is always the modulus of A minus lambda I equal to 0. Modulus of A minus lambda I equal to the 0. Now, for 2 cross 2, it turns out to be, write down the direct equation, lambda square minus trace into lambda plus determinant equal to 0. So you have to only calculate trace and determinant. Trace means sum of diagonal elements and determinant means the determinant of the matrix here. Okay. This is the direct equation. You can use it and it will be very helpful. Okay. Whenever any 2 cross 2 matrix eigenvalue calculation required directly or indirectly. Okay. If it is 3 cross 3, let's come first. Let me tell you both the formulas and then I'll take a question. If it is 3 cross 3. Okay. So again, the general characteristic equation, you will solve determinant A minus lambda I equal to 0. Solving, I've solved, I'm not deriving, I'm solved and giving to you. So what happens for 3 cross 3? Okay, the characteristic equation will turn out to be something in the form of lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0. Okay, where beta 1, okay, that is the first number, will again be the trace only, trace of the matrix A. Okay, trace of the matrix which we know the sum of the diagonal elements a11 plus a22 plus a33. Okay. Then what about beta 2? Let me first tell you beta 3. See, the first number is trace and the last, the constant term will again be the determinant only. Will be equal to determinant of A. Okay, the beta 3 is again simple, determinant of A. Okay, determinant of A. Now, beta 1 is sum of diagonal elements. Beta 2, just remember the language. Beta 2 is sum of the minors. Minors of what? Sum of the minors of the diagonal elements. I will show you in the question. Sum of the minors. Like this is one diagonal element. What is the minor? How do you calculate minor of any element? Delete the row and column. Okay. Then whatever is the value of this determinant is the first minor. Similarly, you have to calculate the minor of every diagonal element. Clear? Okay. Now let's come to both a 2 cross 2 and a 3 cross 3 question. Let's do it quickly. Dead sincere. Recently, I haven't taken any such session, but yeah, recently I took a MSQ practice. I have taken such session long back, marathon on state space analysis. But yeah, recently I took a session. Just a second. So what I was telling you is recently I have taken a MSQ practice session on control system where I have talked about the CCF and OCF forms specifically, and DCF also. Okay, how to write down the shortcuts. Okay, very quickly I have told you, but you can grasp it. Okay, the CCF, OCF, DCF. There. Okay. Chalo, yeah, let's come to the question. Hope you have solved it. Let us come to this. Okay, so what is the characteristic equation? For 2 cross 2, as I told you, lambda square minus trace into lambda plus determinant equal to 0. So lambda square minus trace. Trace is the sum of the diagonal numbers 1 plus 4. And determinant cross multiply 4 minus minus plus 2 equal to 0. So lambda square minus 5 lambda plus 6 equal to 0. Factorizable as lambda minus 2 and lambda minus 3 equal to 0. So what are the two eigenvalues? 2 and 3. Then eigenvectors, I will directly tell you, the question approach directly with the question, whether it is MSQ or MCQ or NET, what type of question approach to apply for eigenvector. Because solving eigenvector by conventional method is a very detailed process. So I'll tell you directly how to handle with the question. Okay. All right. Now let's try for 3 cross 3. Now let's try for a 3 cross 3 as well. Okay, let's try for a 3 cross 3. Oh, great to know, Rahul. Great to know. Congratulations for your GATE rank. Congratulations for your GATE rank, and hope you also succeed in, your MTech or PSU, whatever you have opted as of now. Yes, guys, just complete this calculation. Beta 1, beta 2, beta 3. Please calculate the values. See, Selvan, if you have studied them already, just revise it. Just revise the notes. No need to take any further problems. Or if you have not done, leave it right now. End moment means only, it was just last month of the exam, so at least only important things you focus, that is important. Okay, chalo, come here, dear. Okay, so what is the 3 cross 3 characteristic equation? I told you we'll have the beta 1, beta 2 and beta 3s. Okay, where beta 1, beta 2, beta 3 has been explained. So let me first start with the calculations. What is beta 1? Beta 1 is known as the trace of the matrix A. Okay, 1 plus 8 plus minus 3, that is equal to 6. Okay, what about beta 2? Beta 2 is known as sum of minors of the diagonal numbers. Sum of the minors of the diagonal elements, as I told you. Okay, so now keep looking here. The first diagonal element 1. Okay, delete the row and column. What is the minor you will get? 8, 3, 4, minus 3, and then I will solve it. Let me write down the minus structure. Next, so next diagonal element is 8, second row, second column deleted. So the numbers are 1, 6, 1, minus 3. And similarly next, okay, I take the third element here and third row, third column deleted. So I have 1 and 4 and I have 2 and 8. Okay, 1 and 4 and 2 and 8. Clear? Okay, so this is going to give you how much? Minus 24 minus of 12. So this is minus 36. Next one is minus 3, minus 6, minus 9, and next one is 8 and minus 8. So total minus 45. Total minus 45. What about beta 3? Beta 3, as I told you, is the determinant of the matrix A. So if I solve up for the determinant, R1 plus R3 is equal to R2. Determinant, you calculate, it will be 0. Okay, determinant will be equal to 0. Okay. Yeah, for EMF PDF has been provided by Hemant sir, Ramakrishna. Okay, provided by Hemant sir. Okay, beta 3 equal to determinant, which is equal to the 0. Okay, which is equal to the 0. Okay, so let's form the characteristic equation then. So dear, what is the characteristic equation? Lambda cube minus beta 1 lambda square. What is the beta 1 we have got is 6. So minus 6 lambda square plus beta 2 into lambda plus the beta 2 into lambda. So beta 2 is minus 45. Okay, and minus beta 3, which was the determinant, equal to 0. Okay, so lambda cube minus 6 lambda square minus 45 lambda equal to 0. Taking lambda common, lambda square minus 6 lambda minus 45 equal to 0. So the roots, one of them is lambda 0, other one 6. Minus b plus minus root over b square minus 4ac. So minus minus plus 4 times 45, 180 divided by 2a. Okay, so lambda is 0, and then solving this, under root 216, 6 cube, so 6 root 6. Cancel with 2, so 3 plus minus 3 root 6. So 3 plus 3 root 6, these are the 3 eigenvalues, 3 minus 3 root 6. Okay, these are the 3 eigenvalues, okay, obtained for this 3 cross 3 matrix. Obtained for this 3 cross 3 matrix. Obtained for this 3 cross 3 matrix. Clear? Now, first come to this question before I show you the properties. First come to this question. Okay, which of the following is or are the eigenvectors of the matrix? Which of the following is or are? Okay, so I'm not asking you to calculate the eigenvectors. Okay, I'm not asking you to calculate, but which of them, that's how, and normally guys, from eigenvectors, 2-3 times they have put up MSQ questions. Even in GATE 24, there was a MSQ question only from eigenvectors, because that's a quite, probable area for MSQ, and even in GATE 22 also. So 2 to 3 times I have seen MSQ from the eigenvectors only. And that is why I have brought up MSQ type question. This is not the GATE one, but if you get this, the similar questions are there, similar model. So rather than going for conventional method of eigenvector, whenever there is MSQ, MCQ, or any NAT, even I'll talk about NAT also, only one approach you have to use, the definition of eigenvector. What are the eigenvectors? Eigenvectors are the vectors, okay, such that AX is proportional to X. The A into X should be proportional to X. So you have to only satisfy, take A matrix, multiply by any given option, it should be lambda into X. If it is satisfied, then that is the correct eigenvector. Any lambda, AX comes out to be 5X, 500X, 5000X, it doesn't matter. But if it is proportional to X, a multiple of X, thumbs up. Okay, thumbs up. So let's try this one by one with different options. Okay, let's try it with option number A. I'll show you one by one. Let me first try it with the option number A. Option number A, Ax. What is the Ax for the option number 1? X. What is the X given here? Is 1, 2 and 5. What is the X given here? Is the 1, 2 and 5. Okay, so just multiply and just allow me a minute. Yeah. Okay, let's continue. So what about the value of Ax? What about the value of Ax? So let's do it out. Okay. So first row into first column, 0. Okay, plus 2 plus 5 is 7. Then 1 plus 0 plus 5 is 6. Then 1 plus 2 plus 0 is 3. It is 7, 6, 3. Now, can it be written as lambda x? Is it equal to lambda into 1, 2, 5? Now see, if this was equal, assume this was equal. Assume this was equal. Okay, so then lambda into 1 should be 7. That means lambda should be 7. Now dear, if lambda is 7, 2 lambda should be 14. It doesn't match. Because if left hand side equal to right hand side, if two vectors are equal, all the corresponding elements must be equal. All the corresponding elements must be equal. Okay, so this is not equal to lambda x, so it is not a correct eigenvector. So I will immediately go to the option number B and I will start checking Ax. For the option number B, what is my Ax? What is my x vector given? Have a look into it. 1, 1, 1. Okay, 1, 1, 1. Multiply. If you have got any answers, please do let me know in the comment box. Okay, so multiply here. So 0 plus 1 plus 1 is 2. 1 plus 0 plus 1 is again 2. 1 plus 1 plus 0 is 2. So this is 2 to 2. Taking 2 common. Taking 2 common, it is 1, 1, 1. Okay, 1, 1, 1 means the same vector. That means here you have been multiplying Ax and you have got it as 2x. This 2 means the lambda. Okay, when Ax turns out to be any multiple of x, yes, that is the correct eigenvector. That is the correct eigenvector. The B option is correct. But if it was MCQ, I can stop. But MSQ means I need to confirm all the 4 options. So next, I'll confirm option number C. 1, 2 and minus 3. Option number C, what is the Ax? What is the value of Ax? And x is 1, 2 and minus 3. 1 and 2 and minus 3. 1 and 2 and minus 3. Let's multiply 0, 2, minus 3, which is minus 1. 1, 0, minus 3, which is minus 2. 1 plus 2 plus 0, which is 3. Okay, clearly just take a minus outside. Clearly take this minus outside, so you are left with what is given. 1, 2 and minus 3. That is what was the vector given. So that means this time you have Ax equal to minus x. That is also proportional. That is also proportional. You can say lambda is minus 1. Okay, you can say lambda is minus 1. So equation satisfied. Ax equal to lambda x. So C also correct. C also correct. One last calculation. Let us check the D also. Then let us overall tick mark what are the options. So what is Ax for the D option? What is the x? Minus 2, 9 and minus 7. Minus 2, 9, minus 7. Okay, so 0, 9 and minus 7 is 2. Minus 2, 0 and minus 7. Okay, minus 9. Minus 2 plus 9 and 0, so that is 7. Okay dear, here also you take minus outside. Okay, so minus 2, 9 and minus 7. Minus 2, 9 and minus 7. So here also you are getting Ax equal to minus x with lambda equal to minus 1. So D answer is also correct. D answer is also correct. Sai Shiva, to check D also. Not only BC, in fact BCD. Okay, for a one particular eigenvalue, you can have multiple eigenvectors because eigenvectors are the solution of A minus lambda A into x equal to 0. They are the non-trivial solution, and non-trivial means infinite solutions will be there. Okay, so the correct answer is B, C, D. Again, I repeat, corresponding to one eigenvalue itself, you can have multiple eigenvectors. You can have multiple eigenvectors, okay? You can have multiple eigenvectors, clear? Okay. Like C and D are the eigenvectors corresponding to the same eigenvalue. Corresponding to the same eigenvalue. Okay, corresponding to the same eigenvalue. Actually, let me tell you one more point here. About a matrix. You should know that. Okay, not very frequent, but let me tell you. Then let's go to the property. That is the concept of AM and GM. Okay, dear, for this matrix, okay, if you solve for lambda, na, for this matrix, let me write down the same matrix. Let me write down the matrix. Okay, what will be the eigenvalues? Okay, how do you get the eigenvalues, dear? Same method. Characters 3 cross 3, same method. Beta 1, beta 2, beta 3 you will find, and you will find the eigenvalues. Okay, so we will do it again, but yeah, for this question you will solve and you will get the eigenvalues as -1 and +2. That is why in the options also, when I check the options, now see, one of the lambda was 2, one of the lambda is -1, you will get it as -1 and 2. Okay, that means if you talk about lambda equal to -1, okay, it is repeated twice. If an eigenvalue is repeated, we link it with the concept of AM. Okay, we link it with the concept of AM, known as what? Algebraic multiplicity, AM. Okay, if an eigenvalue is repeated m times, then its AM is said to be M. So for this lambda equal to -1, what is the AM? Is 2. For lambda equal to -2, next eigenvalue. Lambda equal to 2. How many times it occurs? Only once. So its algebraic multiplicity is 1. Okay, so hope you have got it. What is algebraic multiplicity? Okay, what is algebraic multiplicity? Okay, if eigenvalue repeated m times, then its algebraic multiplicity is m. Okay, how many times it is repeated? Then geometric multiplicity. If lambda, I told you, corresponding to every eigenvalue, there will be infinite solutions. Okay, because eigenvectors are the solution of what? See, eigenvectors, as I told you, they are the solutions of Ax equal to lambda x. Since the beginning I am telling you this. Okay, or when we shifted the terms on the left side, we got a minus lambda x equal to 0. Okay, and what we are looking for? We are looking for non-zero or non-trivial solutions. Okay, non-zero solutions of Ax equal to lambda x, and non-trivial also means infinite solutions. That means for a particular lambda also, for one particular lambda, there can be infinite eigenvectors. There can be many eigenvectors. Okay, but only how many independent eigenvectors? How many independent solutions of homogeneous system of equation? Okay, n minus rank of A. Here A is A minus lambda I, but only n minus rank of A minus lambda I independent solutions. So how many independent eigenvectors? If a lambda has p linearly independent eigenvectors, then the GM will be equal to p. If a lambda has p linearly independent eigenvectors, then the number of those independent eigenvectors is known as the GM, is known as the geometric multiplicity. The same formula I have written here. N minus rank of A minus lambda I. Okay, so for this question, lambda is -1, and 2. Okay, so AM and AM for both is written. What about the GM? Okay, what about the GM? Now, what about the GM for both of them? Keep listening here. Okay, so the first eigenvalue lambda equal to -1. Okay, so what is A minus lambda I? A minus lambda I becomes A plus I. Lambda is -1. Na? So dear, what is A plus I matrix? Okay, I means what type of matrix? Identity matrix. Only diagonal elements are 1. So when you add I here, okay, all the diagonal elements will be added by 1, so they will also become 1. Okay, so what is this matrix going to be? When you add I, all the diagonal elements will also become 1. Now, you have what type of matrix? Can you say the rank of this directly? I think you can. Can you say the rank of this directly? Because there is a matrix containing all rows same. Whenever all the rows are same or proportional. R1, R1, R1. Okay, R1, R1, R1. So rank is 1. We have studied this, na? Maybe 1 hour or 2 hours back only we studied this point. Okay, whenever all the rows are proportional, rank is equal to the 1 only. Rank is equal to 1. Clear? Okay, so rank will be 100%. Rank will be 1. Okay, so what is the GM corresponding to this eigenvalue? N minus, as I told you the formula N is 3, number of variables here were 3, minus rank of A minus lambda I, which is 1. So there will be 2. Okay, 2 independent eigenvectors. For any eigenvalue, the number of independent eigenvectors is known as its GM. Now, if I take lambda equal to, the other eigenvalue is 2. Okay, so I will be having A minus lambda I matrix, which is A minus 2I. Okay, now A minus 2I. Okay, that means from every diagonal element, you will subtract 2. Okay, so 0 minus 2, rest 1, 1. Again 1, 0 minus 2, and then 1, 1, 1, and again minus 2. Okay, this is what is A minus 2I. This is what is A minus 2I. Now, dear, what about the rank of this matrix? See, the determinant will be 0, you calculate, and if you take a 2 cross 2 minor, 4 minus 1, yes, non-zero, the rank will be 2. So what about the GM here? GM 3 minus 2, n minus rank of A minus lambda I 1. So GM corresponding to it is 1. Although rarely I have seen any question on GM and AM, but you should know it. You should be knowing it. Okay, I again repeat. The number of times an eigenvalue is repeated is known as the AM. If an eigenvalue has P linearly independent eigenvectors, then P is known as the GM. The GM will have the formula n minus rank of A minus lambda I. This is what we discussed in the homogeneous system of equations. Same thing has been copied here. Clear? Okay, and this example clearly tells you that these two are the eigenvectors corresponding to the same eigenvalue. I am telling you, corresponding to one eigenvalue, you can have infinite eigenvectors. Okay, but yeah, this question is important. AM, GM, hardly I have seen any question, but you should know it. So I have briefly told you. Okay, now what is more important is, okay, handling eigenvector based question. I will take NAT also in some time. And what is most important here is the properties of eigenvalue and eigenvector. There is a set of properties, very, very important. I'll brief you the properties and then we'll take miscellaneous questions. Okay, to cover up the most important area of linear algebra, I will say on the properties of eigenvalues and eigenvectors. Okay, so let's do it. Okay, let's start and let's do it. Sum of eigenvalues you can verify with any of the previous problems. Sum of eigenvalues is always equal to the trace of the matrix, sum of diagonal elements of the matrix. The product of eigenvalues is determinant of the matrix. The first two are the most useful one, I will say. Okay. Then A and A transpose, a matrix and its transpose will have same eigenvalues. Next one. Okay, rank of a matrix is equal to number of non-zero eigenvalues. The same matrix I have taken here, except triangular matrices. Okay, the rank. So there is the relation between rank and eigenvalues. Same matrix, and I told you the eigenvalues, na? -1, -1, and 2. Okay, -1, -1, and 2. So how many non-zero eigenvalues? All the three are non-zero, na? All the three are non-zero, na? Okay, so if you know the list of eigenvalues, you can directly say the rank. The rank is equal to number of non-zero eigenvalues, 3 non-zero eigenvalues. 3 non-zero eigenvalues. So rank equal to 3. Clear, everybody? The rank is number of non-zero eigenvalues. You can try. You know the rank method, na? We have studied today. You try the rank, you should also be getting 3 directly. Okay, but if you know the eigenvalues, rank can be said as the number of non-zero eigenvalues. Okay, next. For a triangular matrix, whether upper or lower, anything, whether it is upper triangular or lower triangular, okay, or even a diagonal matrix containing only diagonal elements, okay, the eigenvalues, no effort is required. Eigenvalues are just equal to the diagonal elements. Whatever the diagonal elements you say, one by one you copy, that is your answer. Okay, so if this is a 3 cross 3 matrix given, the eigenvalues will be A11, A22, A33. Simple, nothing to be done. If it is upper triangular, lower triangular, or diagonal, the diagonal elements are the eigenvalues. Simple. Okay. Directly, indirectly, very useful property. Next. Okay. Now next, I'll put it in a more better way, I think. Adding on list of results. So sixth, a matrix. I'll come back to it. I'll add some more results here. Better, let's go to the next property and then let's come back here. Okay. Let's come back here. So see, dear, if I take Just now I told you upper triangular matrix property, na? Suppose you take this example. Upper triangular. Okay, what are the eigenvalues? Is it upper triangular? Yes, na? So eigenvalues, you don't have to put any effort. No trace, no determinant. Just the eigenvalues are equal to diagonal numbers 1 and 3. Okay, 1 and 3. These are the two eigenvalues. Now, add the elements of every row. 1 plus 2. The sum of the row is 3. Add the elements of the next row also. 0 plus 3 is equal to 3. So, if the sum of the elements of every row or either column, property applicable to row or column both, I have solved row wise, sum of the elements of every row is same. Correct? You have the same sum. Then one of the eigenvalue is always equal to that sum. Okay, so see, one of the eigenvalue is always equal to that sum. What is the same sum? Which is 3, and hence 3 is one of the eigenvalues. Firstly, I told you the eigenvalues and then I have shown you this sum calculation. If sum of the elements of every row is same, then one of the eigenvalue is equal to that sum. Okay. Lahari. Okay, if time permits, I will take up about rank of A plus B for 3 cross 4 as well. Okay. No. Row transformation, cineholic. Row transformation, column transformation. You are transforming into upper or low means by row or column transformation, they are applicable for determinant. By any row or column transformation, determinant of the matrix doesn't change, but the matrix is transformed into a new matrix and hence it can have new eigenvalue. So don't try any transformation. Okay, don't try any transformation in an eigenvalue problem. Okay, in an eigenvalue problem. Don't try any transformation in an eigenvalue problem. Okay, next question, next property. Okay, for a real matrix, if alpha plus I beta is an eigenvalue, alpha minus I beta is an eigenvalue, that means, okay, alpha plus I minus plus minus I beta, complex eigenvalue, if any, will be occurring in the conjugate pair, if any. If this is eigenvalue, alpha minus I beta will also be an eigenvalue. Clear? Okay, if there is a complex eigenvalue, will be in conjugate pair. Real eigenvalues can be alone, but the property may not hold for a complex matrix. Okay, this is only for real matrix. What is real matrix? Real matrix means all elements of the matrix are real. All elements of the matrix are real. Even if one complex element, we call it as a complex matrix. Okay, next. Okay, now these points mostly are important for properties or conceptual based or factual based question. Okay, eigenvalues of a symmetric matrix, symmetric, Hermitian, skew Hermitian, have a look into it. Eigenvalues of a real symmetric matrix are always real, as well as the eigenvalues of a Hermitian matrix are always real. Okay, so eigenvalues of a real symmetric matrix are also real, eigenvalues of a Hermitian matrix are also real. Okay, eigenvalues of a real skew symmetric matrix, okay, are either 0 or pure imaginary. Similarly, eigenvalues of a skew Hermitian matrix are also either 0 or pure imaginary. Okay, next one, with respect to real symmetric only, eigenvectors corresponding to distinct eigenvalues. I will take up a question later on all these points. Eigenvectors corresponding to distinct eigenvalues of a real symmetric matrix. Again, for a real symmetric matrix only. Okay, the eigenvectors for distinct eigenvalues. Suppose, okay, lambda 1 has some eigenvector x1. Lambda 2 has some eigenvector x2. Okay, what the property is telling, eigenvector corresponding to distinct eigenvalues. Distinct means if these two eigenvalues are distinct, not equal to each other, if lambda 1 not equal to lambda 2, then their corresponding eigenvectors will be orthogonal. Orthogonal means perpendicular. The vector x1 and x2 will be perpendicular. That means x1 dot x2, if you take it in the vector notation, okay, x1 dot x2, or in the matrix notation, we call it as x1 transpose x2 equal to 0. The vectors are orthogonal, means the dot product is 0. Simple, na? Perpendicular vectors, the dot product has to be 0. Perpendicular vector means the dot product has to be 0. Okay, so the eigenvectors corresponding to distinct eigenvalues will be orthogonal. If lambda 1, lambda 2 are distinct, not equal to each other, then their x1, x2 will be perpendicular or orthogonal to each other. Okay, last two properties and then we go to the question. Eigenvalues of a unitary matrix or real orthogonal matrix. Okay, or real orthogonal matrix will satisfy mod lambda equal to 1. That means magnitude equal to 1, or we can say that will lie on unit circle. Okay, will lie on unit circle. Last one, the total number of linearly independent eigenvectors of a matrix total is equal to number of distinct eigenvalues. Okay, is equal to number of distinct eigenvalues. So we'll take up a question on that. Okay, now the sixth point, I told you I'll take it at the last. That is actually very, very important. Lot of questions actually are around the sixth point. Okay, so what is the sixth point? If A, okay, has an eigenvalue lambda, eigenvector x, A power n will have the eigenvalue lambda power n, okay, and eigenvector remains to be same. A plus I will have the eigenvalue lambda plus 1, eigenvector remains to be same. K into A will have the eigenvalue k into lambda, eigenvector remaining to be the same. Okay, or you know, by this, if I want to even include A inverse, if I want to include A inverse, n can be minus 1. So eigenvalue will be lambda inverse or 1 by lambda. Eigenvector remaining to be the same. Eigenvector remaining to be the same. Okay. If I take A transpose, clear, then the eigenvalues remain to be lambda. I told you the third property, A and A transpose have the same eigenvalue, but eigenvector will change. Okay. So what is that eigenvector? We don't have any property. If there is an eigenvector on A transpose, then we have to do it manually. Okay, so eigenvector cannot be x. Okay, but for A, the point is, the moral of the story is, dear, if A has the eigenvalue lambda, you take any function of A. See, if I take A power n, eigenvalue becomes lambda power n. If I add A plus I, so in number I means like number 1. K times A, so k times lambda. That means any operation you do on A, any function you take for A, the eigenvalue also becomes f of lambda. The eigenvalue also becomes f of lambda. Okay. Okay. If A has an eigenvalue lambda, what about the eigenvalue of? We will take more questions, but writing just an example. A square plus 2A, okay, plus 6I. So eigenvalue should be whatever function you have taken for A, whatever operation you apply to A, okay, it will be applied to the matrix. So A square, that is lambda square, plus 2 lambda, plus 6. Got it now? Only thing is identity will be replaced by number 1. Okay, so lambda square plus 2 lambda plus 6. Okay, if A has the eigenvalue lambda, that is already written, then eigenvalue of e power A, that also will become e power lambda. No need to derive it, but yeah, all these eigenvalues properties will be satisfied. Okay, yeah. Okay, even if it is A power 1000 also, eigenvalue will be lambda power 1000. Okay, rest we'll talk in terms of question. Okay, see, Joel, the type of doubt you're putting up, there are two types of question. Okay, whether they are asking the eigenvalue of A power 1000. Okay, whether they are asking the eigenvalue of A power 1000. Okay, that will become lambda power 1000. If they are asking the matrix A power 1000, asking to find A power 1000, then that becomes a Cayley-Hamilton theorem case. That I will take up. That becomes a Cayley-Hamilton theorem case actually. Okay, that will be a Cayley-Hamilton theorem. So now let's go to the questions here. Yeah, see, a simple question. Okay, got it, Joel? So these are two different cases, A power 1000 eigenvalues or A power 1000 matrix. That matrix is asked, that means mostly Cayley-Hamilton theorem. Okay. So now the minimum and maximum eigenvalues of a matrix are given to you, -2 and 6 respectively. What is the other eigenvalue? Okay. What is the other eigenvalue? Simple, na? This is a simple question because, okay, the sum of eigenvalues lambda 1 plus lambda 2 plus lambda 3 is equal to the trace. So minimum and maximum, that means two eigenvalues are given to me, -2 and 6. What is the other eigenvalue? This should be trace, that is 1 plus 5 plus 1. Okay, so what is the lambda 1? 7 and -4, 3. So it can be, you know, these are also expected 1 marker category question. Okay, so we'll talk about simple and good questions both. The correct answer is B here. Here the correct answer is option number B. Let's go to the next question. Two eigenvalues of a 3 cross 3 real matrix are 2 plus root minus 1 and 3. What is the determinant of P? Now what they are telling, it is the real matrix. Okay, real matrix. So I told you, na, complex conjugate property for real matrix, because one of the eigenvalue is 2 plus root minus 1. That is 2 plus I. Okay, so what can I say? 2 minus I is also an eigenvalue, right? Property number 8. 2 minus I is also an eigenvalue. Correct, dear? The 2 minus I also will be 100% an eigenvalue. 2 minus I also will be 100% an eigenvalue. Two minus I will be 100% an eigenvalue. Clear? Now, okay, so now we know all the three eigenvalues. So for this real matrix P, what are my eigenvalues? Okay, 2 plus I, 2 minus I, and 3. Okay, what is the determinant? Okay, determinant is equal to what? Determinant is product of eigenvalues, property number 2. I told you, first and second are the most commonly used properties. Lambda 1, lambda 2, lambda 3. Okay, so this is 2 plus I multiplied by 2 minus I whole multiplied by 3. So this is like 2 square minus I square. I square is minus 1. Okay, so 4 minus 1, 5 into 3, answer has to be 15. The answer has to be 15. Yes, we have some answers already coming up. Okay, yes, Sai Shiva, Amar, Selvan, Rohan, Manasvi, correct answer. And here is the next question for you. Okay, if K0 minus K whole transpose is an eigenvector of the following matrix, okay, then what is the corresponding eigenvalue? What is the corresponding eigenvalue? What is the corresponding eigenvalue? Now see, it is the eigenvector. Now what I told you, any eigenvector question, whether MCQ, MSQ, NAT, okay, you have to always take up the condition that is AX equal to lambda X. AX equal to lambda X. Okay, so I'll start with that calculation. 1 minus 1 0 A matrix, minus 1 2 and minus 1, and 0 minus 1 and 1 into X. Into X. What is the X? It is given by K0 and minus K. It is given by K0 and minus K, and this should be equal to lambda. What is the lambda? That I don't know right now. That is what I have to find, the corresponding eigenvalue. Okay, this should be some lambda into K0 minus K. Let's work out. First multiply. Okay, so what is the first row and first equation? K0 and 0. So it is K. Okay, then minus K plus 0 and minus plus K. So minus K plus K. Perfect. So that is 0 only. We want the central element 0. And then 0, 0 and minus K. Now this is right side, take lambda inside. So the first element is K lambda, second is 0, third is minus K lambda. So very clearly, on comparing, what is the corresponding lambda? On corresponding, K is K lambda, that means lambda is 1, which satisfies here also. Okay, so what is the corresponding eigen value? Is lambda equal to 1. Is lambda equal to 1. Clear, everybody? Yes, we have some answers in the comment box already coming up as 1. Yes, the correct eigenvalue is 1. The very correct eigenvalue is equal to the 1. Simple only. Okay. So, have a look into this question right now. Have a look into this question. Okay, given this matrix, okay, what are the eigenvalues of the given options? Eigenvalues of A also they are discussing. So, more about property number 6. Please try it out, guys. Please try it out. Please try out this question. Okay. So all correct, or some of you say BCD, but mostly you say ABCD. Let's check it out. Let's check that out here. Okay. So the simple way, A is upper triangular. There is no problem with the A. A to anyway is upper triangular. Okay, so what are the eigenvalues? Simple. So no beta 1, beta 2, beta required. It is mostly a property question. So for upper triangular matrix, eigenvalues are equal to sum of the, is just the diagonal numbers 1, 3 and 2. So option number B is correct. Option number B correct. And then rest is property number 6. Okay, so for 2a plus 5i, 2a plus 5i, the eigenvalue should be 2 lambda and plus of 5. 2 lambda plus 5. Okay, that means 1 by 1. 2 plus 5, 7. Okay, then 2 into 3, 6. Plus 5, 11. Then 2 into 2, 4 plus 5, 9. For every eigenvalue you will do it, na? Okay, for every eigenvalue you will do it. Okay, so C also right. Okay, D, eigenvalue of A cube. The eigenvalue of A cube will be lambda cube. Okay, so that is 1 and 27 and 4. Sorry, 2 cube 8. So D also correct. BCD the straightforward correct. Okay, so some of you still say BCD, some of you say ABCD. Okay, so next, option number A, eigenvalue of 2A inverse plus 6 adjoint A plus A square. Okay, what should be the eigenvalue? See, first of all, you can write down adjoint A as, what is the adjoint A? It comes in the inverse definition. A inverse is adjoint A upon mod A. Okay, so what is adjoint A? You can write it as mod A into A inverse. Now, what is the determinant of this matrix A? Product of eigenvalues. So let me solve for the determinant also. Determinant is product of eigenvalues and that becomes 6. That becomes 6. So adjoint A is 6A inverse here. Adjoint A here is 6A inverse. Clear? Okay, so now for this what should be the eigenvalue? 2A inverse means 2 by lambda plus 6 into adjoint A, that is 6 into 6 by lambda. For A inverse, eigenvalue 1 by lambda plus A square, that means plus lambda square. Okay, so what are the eigenvalues actually? 6, 36 plus 2, it should be 38 by lambda and plus lambda square. Okay, so 1 by 1 for the first, 38 by 1 plus 1, 39, correct. Next, so 38 by 3 plus 9, 38 by 3 plus 9. So how much it becomes? 27 and adding it, yes, correct, 65 by 3. Second also matches. And the third one for 2. So 38 by 2, 19. 19 plus 4, 23. Yes, so A is also correct here. A is also correct here. A is also correct. Done. All are correct. A, B, C, D. MSQ question. Easily framed. Okay, from such properties. The sixth property, very useful for exam. The sixth property, very useful for exam. All right. Let's go to the next question. The sixth property, very useful for the exam. This is ABCD, done. Next question now. Let's go to another question here. Yeah, come on with another MSQ. Lot of chances of MSQs from algebra and especially from eigenvalue, eigenvectors. And almost every year they are putting a MSQ from eigenvalue, eigenvector, different types. Okay, have a look into this question. For the matrix M, 4x, x9, if determinant is 0, which of the following statement is or are correct? Okay, determinant equal to 0. Okay, matrix cannot be invertible. B option is wrong. Okay, B option is wrong. But for any value of x, will it be symmetric? No. Determinant is 0. So, I have to calculate the determinant equal to 0. Let me do it here. Okay, so determinant 4x, x9 equal to 0, meaning that 4 cross multiply 36 and then minus x square is 0. Okay, so x square equal to 36, so x may be plus or minus 6. So actually x can take any value plus or minus 6. Okay, right, plus minus 6. But whatever is the value of x, see, these are the diagonal elements, and element above and below is same x. Maybe 6 or maybe 6, but both are x, na? Both are x, so this is symmetric. That is anyways true. Elements above and below the diagonal are equal. That is what is a symmetric matrix. So correct, A is correct. Is one of the eigenvalue 13? We will figure out. Its eigenvectors are orthogonal. We will figure out. So now I need the orthogonality also. Now, eigenvalues and eigenvectors being orthogonal or not. Okay, so now listen here. Okay, what is the characteristic equation? 2 cross 2 na? 2 cross 2. Let's recall lambda square minus trace into lambda plus determinant equal to 0. Okay, so lambda square minus trace is 4 plus 9, 13. Determinant is mentioned as 0. So I think x value was not required only. Forget that, this calculation is not required. Okay, lambda outside and lambda minus 13 equal to 0. Okay, so what is the value of lambda? 0 and 13. One of the eigenvalue is 13, yes. One of the eigenvalue is 13, yes. Okay, so this calculation, even if we have done, no problem, but I think not required. This x value, whatever the value of x, not required to check the option. Okay, so lambda is 0 and 13. One of the eigenvalue 13, so C also correct. Okay, now it is a symmetric matrix. It is a symmetric matrix. So two properties I told you for symmetric matrix. What are the two properties I told you? What are the two properties I told you? That if eigenvalues, okay, it is a symmetric matrix and we have obtained lambda 1 not equal to lambda 2, isn't it? Two eigenvalues which are distinct. Okay, which are distinct. Okay, so the eigenvectors, suppose x1 and x2, they will be orthogonal. Correct, or D also correct. D also correct. ACD. ACD. Okay. Only thing is it is not invertible. Yes, Joel. Invertible means a matrix whose inverse can be calculated. Then it is invertible. Okay. Chalo. Okay, AKP, just contact our support numbers that I have mentioned earlier, or you can find it from Google. Okay, you will be able to know about the details. Okay, chalo guys, next question. So MSQs, a lot of potential of MSQs from here. See, in fact, one question I would like to show you first. Okay, before taking the MSQ question, one question, have a look into it. Okay, now consider. See, look into this question. Look into this question. Consider a matrix whose eigenvectors corresponding to the eigenvalues lambda 1 and lambda 2 are x1 and x2 respectively. What is the value of x1 transpose x2? What is the value of the x1 transpose x2? What is the value of the x1 transpose x2? Let's work it out. What should be the value of x1 transpose into x2? See, the value of x1 transpose x2. How to figure it out? How to figure it out? The value of x1 transpose into x2. No, see, x1 transpose x2 also means x1 dot x2, dot product expression. See, now one way is method number 1. I will not solve and I'll help you. Okay, method number 1 and method number 2 is also simple. See, method number 1. Okay, it is a symmetric matrix. It is a symmetric matrix. Okay, see, elements above and below the diagonal are same. Okay, find lambda 1 and lambda 2. Now, eigenvectors for a symmetric matrix are not always orthogonal. They are not always orthogonal. See, it is the real symmetric matrix. They are not always orthogonal. Okay, they are orthogonal if you have distinct eigenvalues. So first confirm lambda 1 and lambda 2. Okay, find lambda 1 and lambda 2. What you are going to get for sure, lambda 1 not equal to lambda 2. Okay, you will get that. So x1 transpose x2 will be 0 because x1 will be perpendicular to x2. Okay, x1 will be perpendicular to x2. So you will get the eigenvalues which are not equal. Okay, the second way is, even if you don't click onto this property, even if you don't click onto this property, then also directly also it is simple because x1 x2 structure is given. Na? x1 x2 structure is given. Okay, what is this x1 transpose x2? The question is asking x1 transpose x2, GATE 2 mark, decent question. What is the x1 transpose x2? So see, x1 transpose, when you multiply, this will become rho, then corresponding element. So let me write down the value. First 70 into lambda 2 minus 80, 70 into lambda 2 minus 80, and then plus second element lambda 1 minus 50 to be multiplied by 70. Okay, so this, if you take 70 common from here, it will be lambda 1 plus lambda 2, okay, minus 80 minus 50. Okay, so this also is simple. See, for this you don't have to find lambda 1, lambda 2. For this you don't have to find lambda 1, lambda 2. Why? Why? Because lambda 1 plus lambda 2 is required, and lambda 1 plus lambda 2 is equal to the trace of the matrix, and the trace is directly 50 plus 80. Clear? 50 plus 80. So 50 plus 80 minus 50. Hence the answer is 0. So this is also a very simple way. This is also a very simple way. Just put down the values. Okay. Just put down the values. Okay. So that is what it is. Okay. But if you are applying the orthogonal property for real symmetric matrix, okay, not this question, it was this question. So if you are applying the orthogonal property, make sure that lambda 1 and lambda 2 are different. Okay, this was a real symmetric matrix. Okay, make sure that lambda 1 and lambda 2 are different. That's what I made sure, and then I told x1, x2 are orthogonal, so option number D was correct. Clear, everybody? Next question. Next question. This was MSQ, this was already done, but this was important. Okay, this was important. Have a look into this question. Have a look into this question. Yeah, come to this question. Consider the matrix A, GATE 23 MSQ 1 mark question. Okay. Okay, what is a positive definite matrix? I will tell you with this example. Okay, consider this matrix A, which of the following statement is or are true? Whether it has a unique solution, whether it does not have a unique solution, combination on linear system of equation and eigenvalue eigenvector. Okay, whether it has the linearly independent eigenvectors or whether it is a positive definite matrix. Okay. Even you are looking for maths and aptitude. No, you contact the numbers, you will get your answer. Yes, there is provision, you just contact first. Okay. You don't have the entire course of civil, but maths and aptitude you can get. Okay, fine. Now see dear, okay, to calculate the eigenvalues, what I need is lambda 1, beta 1, beta 2, beta 3. Because number of linearly independent eigenvectors, okay, the number of property number 16, the total number of linearly independent eigenvectors is equal to what? Is equal to number of distinct eigenvalues. Okay, so I need the eigenvalues. Okay, I need the eigenvalues. Okay. Now come here. Okay, now come here. What is the determinant for unique and not unique solution? What about the determinant of the matrix? If I just calculate the determinant, so let's write down the determinant directly. 1 into 2 minus 1, then minus of minus 1, next entry will be minus 1 minus 0, and last is anyway 0. So determinant is 2 minus 1, 1, and this is minus 1. So determinant is 0. Dear, if determinant is 0, okay, mod of A equal to 0, so unique solution not possible. It will not have unique solution. It is a combination, dear. It will not have unique solution. Okay, so it does not have unique solution. B correct, so A goes wrong. Then C and D, I need the actual lambda. So let me start calculating the lambda. Okay, so for the lambda, I need the characteristic equation. Okay, but before the characteristic equation, okay, what was the characteristic equation for 3 cross 3? Lambda cube minus beta 1 lambda square plus beta 2 lambda minus beta 3 equal to 0, where beta 1 is the trace. Okay, so what is that trace? Let me write down the numbers. Trace is 1, 2, 1. Okay, 1 plus 2 plus 1 is 4. What was beta 2? Beta 2 is sum of the minors of the diagonal element. So for the first one, what is the minor? 2 minus 1. Okay. For the second one, this is the second diagonal element, minor will be 1 minus 0. And for the third diagonal element, which is 1 here, the minor will be again 2 minus 1, which is 1. Okay, the 1, 1, 1, the beta 2 is 3, and beta 3 is known as the determinant of the matrix. Already calculated, the determinant in the previous slide was 0. Okay, so what my equation is now? Lambda cube minus 4 lambda square and plus beta 2, that is plus 3 lambda, beta 3 was 0. Lambda outside and rest you can factorize. Okay, 1 and 3, lambda minus 1, lambda minus 3 equal to 0. So what are the lambdas? Okay, what are the lambdas you are getting? The eigenvalues are 0, 1, 3. How many distinct eigenvalues? How many distinct eigenvalues? How many distinct eigenvalues? All three are distinct, not repeated. Okay, and as I told you, the total number of linearly independent eigenvectors is equal to number of distinct eigenvalues, which is 3. So option number C also correct. Option number C also correct. Nitin says B and C. Now, whether it is a positive definite matrix, let us revise. What is a positive definite matrix? Okay, this is a concept of real symmetric or skew, real symmetric or a Hermitian matrix is positive definite. Okay, positive definite if suppose if A is a real symmetric as given in the question or a Hermitian matrix it is said to be positive definite if all lambdas are positive. It is said to be positive semi-definite. Positive semi-definite if lambda greater than equal to 0. So if all the lambdas are strictly positive, then it is positive definite. If the eigenvalues are positive or 0, then it is semi-definite. It is said to be negative definite. Okay, if all the eigenvalues are negative. Okay, and it is said to be indefinite. It is said to be indefinite if some lambda are greater than equal to 0 and some are less than 0. Anything can happen. That is indefinite. So what is the condition in this question? Lambda is 0, 1, 3, either positive or 0. Lambda is greater than equal to 0. Okay, lambda greater than equal to 0. So the matrix is positive semi-definite here. The matrix here is positive semi-definite. So D option is wrong. D option will be wrong. It is positive semi-definite, not a positive definite matrix. So B and C, correct answer Nitin and Rohan Singh. B and C are the correct answers. B and C are the correct answer. Have a look into this question. GATE 17, 5 cross 5 question, but on a property. Okay, sometimes question may look big, how to handle a 5 cross 5 eigenvalue. They are not asking all the eigenvalues. See what is the theme of the question. Okay, yes, positive definite concept is only for real symmetric or a Hermitian matrix, only for these two cases, Sai Shiva. Okay, consider the 5 cross 5 matrix. Okay, and it is given that A has only one real eigenvalues. So it's a 5 cross 5 matrix. Total, it will have 5 eigenvalues. Okay, but only one real, as the question says, it has only one real eigenvalue. Okay, it has only one real eigenvalue. What is that real eigenvalue? What is that real eigenvalue? Why it is a simple question? Because see, the nature of the elements, if you see 1, 2, 3, 4, 5, 5, 1, 2, 3, 4, 4, 5, 1, 2, 3, that means all elements are same only, no? Only a circular rotation is applied. The elements of the row are just rotated 1, 2, 3, 4, 5, then I start with 5, 1, 2, 3, 4, then I start here 1, 2, 3, 4, 5, rotated that side. 1, 2, 3, 4, 5. Since all the elements are similar, only rotation occurred. That is why sum also will be same, na? Sum of property number 7 elements of every row is how much? 1 plus 2 plus 3 plus 4 plus 5 is 15, and that is same. Sum of elements of every row is same, and by chance it is the real value. So what I'm telling you, if sum of elements, okay, if sum of the elements of every row is same, so one of the eigenvalue is equal to that sum, is equal to the sum, which I told you is real. Okay, so what is that real eigenvalue? 15. What is that real eigenvalue? 15. Okay. So property number 7. Okay, property number 7. Clear? Next question. Cayley-Hamilton theorem. Okay, next concept. Okay, Cayley-Hamilton theorem which simply says that every square matrix will satisfy its own characteristic equation. Now, where and what type of questions you have to apply Cayley-Hamilton? Question will never use the language Cayley-Hamilton. Have a look into one question first. If A is a matrix given, then what is A power 9 or any higher power they can ask? Any higher power, A power 900 also. Okay. When a matrix given and question is on higher power of A. Okay. Question is on higher power of A or inverse of A. Okay. Usually you have to think about Cayley-Hamilton. Question itself will not use the word Cayley-Hamilton. How do you use Cayley-Hamilton? Every square matrix will satisfy its characteristic equation. So for 2 cross 2, I have told you the character. This we have seen earlier also. No? Let us just apply it. We already know what is the characteristic equation of 2 cross 2 matrix. Lambda square minus trace lambda plus determinant. Lambda square minus trace. Trace is 3 and minus 3. Okay, and determinant will be minus 9 minus 1 equal to 0. So what is the final characteristic equation? This part is 0. This is minus 10. So lambda square minus 10 equal to 0. Okay, so what is my Cayley-Hamilton theorem? As per Cayley-Hamilton theorem, you can replace lambda by A. Every square matrix will satisfy its characteristic equation. Okay, so A square. Okay. Every square matrix will satisfy its characteristic equation. That means you can place A in place of the lambda. So A square minus 10I. In the number you can write 10, but only precaution is in the matrix you have to take a matrix only. Identity matrix you can take. Okay, so here we can say that what is A square is 10I. The value of A square is 10I. The value of A square is 10I. So what is the value of A square is 10I? Okay, so what should be A power 9? What should be A power 9? A power 9. So A power 9 first I can break as A power 8 into A, and A power 8 can be further broken as A power 2 power 4. Okay. Okay, power will multiply. So what is A square is 10I power 4 into A. So 10 power 4, 10,000. I power 4 is I and I into A will be I. So 10,000 A, option number A is correct answer. The A power 9 can be expressed as 10,000 A. Correct dear. A answer is the very correct answer. A answer is the very correct answer. Next question. If A is given to you, what is A power 4? Now this is the 4 cross 4 matrix. Okay. Have I told you any direct characteristic equation for 4 cross 4? Not yet. So either you have to make the characteristic equation, or you just see the eigenvalues. Okay, because it is an upper triangular, I know the eigenvalues. Upper triangular matrix, na? See, it is an upper triangular matrix. So what are the eigenvalues? Lambda is 2 and minus 2. Then 2i and minus 2i. Correct? Okay. So if these are the eigenvalues are what? Eigenvalues are roots of characteristic equation. So we can form the characteristic equation this way. Okay. What should be the factors of the characteristic equation? One should be lambda minus 2. That is why lambda equal to 2 is the answer. Then you can have lambda plus 2. Lambda minus 2i. Lambda plus 2i is 0. Lambda minus 2, lambda plus 2, lambda minus 2i, lambda plus 2i is equal to the 0. Okay, so keep multiplying. So a minus b, a plus b, lambda square minus 4. Again a minus b, a plus b. So lambda square minus 4i square, but I square is minus 1. Okay, so again a minus b, a plus b. So a square, lambda power 4 minus 4 square, that is 16. This is the final characteristic equation. Clear? Now, because it is a characteristic equation obtained, now I will apply the Cayley-Hamilton theorem, which says that every square matrix, this is also square matrix, will satisfy the characteristic equation. So lambda will be replaced by a power 4 minus of 16i equal to 0. So what is a power 4 is 16i. What is the a power 4 is equal to the 16i. Okay, 16i is the answer. Option number C. Option number C. Yes, Rohan, Manaswi, Nishu Kumar, correct answer. 16i is the very correct answer. The 16i is the very, very correct answer. The 16i is the very correct. Next question, dear. Okay, next question. If 1 minus 1 and 2 eigenvalues of a 3 cross 3 matrix. So directly for a 3 cross 3 matrix, eigenvalues are given. Now write the equation. A inverse is equal to 1 by k, a square plus ba plus ci. What is the value of k into a plus b plus c plus d? Inverse. Okay, either higher power or inverse. In both the ways you can think about Cayley-Hamilton theorem. Now what is given to you? These are the eigenvalues given to you directly. 1 minus 1 and 2 are the eigenvalues, which are the roots of characteristic equation. So what should be the characteristic equation? Lambda minus 1. Then again lambda. Hello. Okay, dear. Yeah, that was a battery problem, but now it is okay. A plus b plus c plus d inverse. Okay. But I think not to repeat. I mean, it's self-understood. If you have any doubts, please ask me. I just checked it from what point we lost the audio, but yeah, it is a self-explanatory. What I have done is, by the given eigenvalues, I have on the characteristic equation now applying Cayley-Hamilton theorem and then multiplied A inverse, and this will give you an expression of A inverse. Okay, this will give you an expression of A inverse. What it is? First you will get 2A inverse. How much is 2A inverse? Send the other terms on the left side. So minus of A square, then plus of 2A, plus of 2A, plus of I, and then divide by 2. 1 by 2. Okay, 1 by k. So this is what is k. Okay, what is the value of A? Is minus 1. This becomes B, which is 2, plus Ci, and C equal to 1 and k equal to 2. The question is, okay, k into A plus B plus C. K is 2, A is minus 1, B is 2 and C is 1. So 2 2's are answer is 4. The answer has to be 4. Clear, everybody? Yes, Manasvi, Shai Shiva, correct answer. It is coming out to be 4. Now, this should not k is 1 by 2. K is 2. 1 upon k is already given. So, k is 2. Take care of that important point. Otherwise, the answer will vary. Okay. Okay, guys. All right. Let's continue and we will be going for lunch break after some more time. Let's continue for some more time. Okay, hope you have the energy. I'll give you a small lunch break, but after some time, let's continue. And before I continue, the big announcement is, okay, the first regular offline batch for GATE 26 for EE and EC okay, at our Hyderabad offline center, the first offline batch from February 24th. From February 24th. If you enroll till 30th of January, you get additional 4,000 of discount. The fee is currently priced 54,999 and additional discounts for IIT and government college students and the previous home students. Okay, dear, that's what it is. That is what it is. Let us move to the next concept and let us jump into differential calculus as well. Let us jump into the differential calculus as well. Okay, the first thing to be started with is the concept of continuity and differentiability. Okay, the continuity and differentiability concept to be taken up. Okay, so again, not deriving it since it's a revision session, but focusing on the problem models and understanding the concept of it. Okay, a function is said to be continuous at the point x equal to a. Okay, x equal to a if limit x tending to a minus fx or limit x tending to a plus fx is equal to fa. Okay, so this particular point is also known as the left hand limit. This is known as the right hand limit. Okay, limit x tending to a minus is the left hand limit, x tending to a plus when you approach x equal to a from the right side, that will be right hand limit. These two should be equal and should be equal to the actual value of the function at that point. They must be equal, and not only equal, they must be equal to the value of the function at that point. Okay, then the function is said to be continuous at that point, or we also say that these are the conditions for two things actually. Okay, if left hand limit equal to right hand limit equal to fa, we say that the function fx is continuous at the point x equal to a, and okay, and we also say that the limit x tending to a fx, the limit x tending to a fx will exist, because for a limit to be existent also the left hand side and right hand side limits must be equal and equal to the true value of the function at that point. Okay, now just 2 or 3 simple examples before I take the numeric. Okay, suppose I am sketching the floor function. Okay, y equal to floor x, we all know it as a floor function or the floor function, or also known as GIF function, greatest integer function, also simply known as the greatest integer function, or simply integral part of a value, or simply known as the integral part of x. Suppose if I take any value of x, if you see here, suppose I take 2.2. Okay, if x is 2.2 but floor will be 2, integral part is 2. If I take 2.1, 2.2, any value 2.99, what is the integral part? That will be 2. Similarly, if I take the value 3 or 3.1 or 3.3, 3.99, any value, the floor value will be, the integral part will be 2. Okay, the integral part will be 2. Okay, EC students, listen to me carefully. The topic of linears, the span and basis, okay, the vector space, the span, the basis, all these things is only a part of EC, and I will make a separate video for it. Okay, so that is why I have not covered, that is not in any other branches, only there it is for EC, and I will make a separate video for it. Okay, not very immediately, but I will make it. I will make it before the EC GATE examination. I have it in the mind. Okay, so don't worry. Right now, let's continue. Okay, Okay, so when you look into this function at any integral point, okay, suppose when you look into this function at any integral point, suppose if I take x equal to 1, okay, if I take x equal to 1, what is the value from the left hand side? Okay, what is the value for the left hand side? Limit x tending to 1 minus fx. Can you say, okay, when you are approaching x equal to 1 but slightly less than 1, you are at slightly less than 1, suppose 0.99, what is the integral part? 0.99999 also, integral part 0, that is what? Okay, so I am talking about this point x equal to 1. When you approach from the left side, you are at 0 level. Okay, but when you talk about right hand limit x tending to 1 plus fx, when you are approaching x equal to 1 but slightly from the right side, suppose 1.00001 also, but 1 point something, na? What is the integral part you will say? You will say 1. And that is why the function is discontinuous at this point. Left hand limit not equal to right hand limit, and you can say that discontinuity means any break in the function. Okay, the function was 0 and abruptly it becomes 1. Okay, abruptly it becomes 1. Okay, then it was 1, suddenly at a point it is going to become 2. Okay, so such discontinuities, whenever left hand limit not equal to right hand limit, you have a discontinuity which is also known as a jump discontinuity. You have a discontinuity which is clearly also known as a jump discontinuity. Clear? A jump discontinuity known as the jump discontinuity. Okay, let us keep discussing. Then next, that is known as the jump discontinuity. Okay, this is the left hand limit and this is the value from the right hand limit. So from right I stop at 1, from the left I stop at 0. So they don't match. Okay, they don't match. Okay, any broken point in the curve, it's a discontinuous curve. Next, have a look into this example. Okay, now I have taken the graph for y equal to modulus of 1 by x. Okay, modulus of 1 by x, and what do I see in this particular graph? Okay, in this graph, when I talk about limit x tending to 0, okay, when I talk about limit x tending to 0 minus, okay, 0 minus fx, or so when I approach from the left side, I'm talking about x equal to 0 right now, or whether I approach from the right side, it looks like my graph is going to a common point. Okay, limit x tending to 0 minus looks equal to the limit x tending to 0 plus fx. So here left hand limit equal to right hand limit, but there is still a problem. There is still a problem. See, left hand limit equal to the right hand limit. Okay, where they are going, what is the exact value? 1 upon 0. What is the exact value of the function? 1 upon 0. So what is f of 0? F of 0 modulus of 1 by 0, that is infinite. Okay, the problem is the f of 0 is infinite. Do you know the value of infinite? Suppose by chance, hypothetically imagine, suppose you knew the value of infinity, then how the graph will look like? If somebody knew the value of infinity, that means the value here is increasing, it goes to infinity and then it is decreasing. Okay, the graph is not broken here, the graph is connected. Okay, left hand limit, right hand limit are equal and both equal to some value, suppose this is x. If you know the value of infinity, both of them are equal and equal to x. Okay, but here both of them are equal, but actually both are approaching infinity. Actually both are approaching infinity. Okay, can you reach infinity? No, nobody can reach infinity. It's an undefined value, the largest value of universe. You can never reach there. Okay, so that means both the values are equal, but equal to a point which you cannot reach. So can you join the curve? No, it will still remain to be discontinuous. Na? Will it be continuous? Can you join it? No, it will be broken at x equal to 0. Okay, it will be broken at x equal to 0. So the point is, left hand limit equal to right hand limit, but the value of the function is undefined. Left hand limit equal to right hand limit. Okay, but the problem here is the value of the function at the concerned point, okay, is undefined. Okay, so that must be finite. The value of the function must be finite. Okay, not only it must be finite. Now the next example may make the story completely clear. Left hand limit, right hand limit, and it should be actually equal to fa. It should be actually equal to fa. Have a look into the next question where I have drawn the curve y equal to floor of sin x. Y equal to floor of sin x. Now see here, if you take any value of x from 0 to pi by 2, less than pi by 2, what about the sin x? Okay dear, what about the sin x curve? We know the sine curve, na? Okay, let's take sin x curve for one period only. What is the sin x curve for one period? If I draw only the sin x curve, if I only draw the sin x curve, at pi by 2, it reached to the peak value, that is 1. Okay, but when you are taking the value 0 to pi by 2, less than pi by 2, the sin x is between 0 to 1. Okay, the sin x is between 0 to 1. So what is the range of sin x? Is 0 to 1. 0 to 1, less than 1. Because exactly at pi by 2 it becomes 1. I have taken less than pi by 2. So what will be the y value? Y is the integral part of it. So any value between 0 to 1, integral part is 0. Integral part is 0. Clear? Now, if you take x equal to pi by 2, if you take x equal to pi by 2, this graphical understanding is also very important. That is why I am doing. So what is sine pi by 2? Sine 90 is 1. And then what is the integral part of 1 is 1. Okay, integral part of 1 is 1. But again, if you take x greater than pi by 2 up to pi, greater than pi by 2 and up to the pi. Okay, greater than pi by 2 up to the pi. What happened to the sin x? So in the pi by 2 to pi also, sin x again decreases 0 to 1. Okay, the sin x is again between 0 to 1. 0 less than equal to sin x, but less than 1. Okay, because I have crossed pi by 2, the value again decreased by 1. So what is the y value? Y means integral part of sin x. So you are between 0 to 1, integral part is 0. Okay, integral part is still 0. Clear everybody? The integral part is still 0. Now see here, what is my left hand limit? My left hand limit, when I am coming from x less than pi by 2, y will be 0 only. Graphically also you see. When you are coming from right side of pi by 2, the answer is still 0, but exactly at pi by 2. Okay, so what is the condition here? Left hand limit equal to right hand limit? Yes. Okay, f of a, f of pi by 2 is equal to how much? Is equal to 1, which is finite. So f of a is defined also, no infinity value, but still the function is broken here. And broken means discontinuous. Broken means discontinuous. Okay, the point is left hand limit equal to the right hand limit. Both of them are equal but not equal to the fa. So the function is broken at the point pi by 2. So the function is discontinuous at the point pi by 2. Is it clear everybody? The function is still discontinuous at the point pi by 2. Okay, in a simple way, suppose if you are drawing a curve like sin x, if I want to draw from 0 to pi by 2, listen here, sin x, if I want to draw 0 to pi by 2, I can draw it in a single go. I can draw it in a single go without taking my pen out of the board or pen out of the paper. Okay, but for this function, can I draw the function in a single go? I can draw this portion, then I have to take my pen out and place it on a different point and then again come back here. Okay, again come back here. So I required to take my pen out of the paper here. So it is discontinuous. Even if I show you previous example, can you draw it in a single go? You cannot draw in a single go because you don't know where is infinity. You will draw this portion and then you will start from here. So you have to, simple way of understanding. If you can draw the function in a single go without taking the pen out of the paper, it can be continuous, otherwise discontinuous. That is a rough way of understanding. So technically what I told you, this is the condition, left hand limit equal to right hand limit, and third example makes it clear that it should be actually equal to the FA also. It should be actually equal to the FA also. Clear everybody? Clear everybody? Right. Now, before I take the question, let us also summarize the condition for differentiability and then the combined question. Okay, what is the concept of differentiability? First of all, to calculate a derivative, we apply the first principle of differentiation. What is that first principle of differentiation? Okay, if y is a function of x, dy by dx or f dash x is the rate of change of fx with respect to x when the change in x is taken to be small. So change in the function f of x plus h minus fx. Okay, where x changed from x to x plus h, function changes from fx to f of x plus h. The change in the function compared to the change in x. Okay, rate of change of fx with respect to x. Okay, when the change in x, what is the change in x? H to be small. So limit h tending to 0. Limit h tending to 0. So we have the final, which is known as the first principle of differentiation. Okay, limit h tending to 0, f of x plus h minus fx upon h. Do I need to use this first principle? I'll show you with question. Mostly no. Okay, you can solve the differentiability question directly because you know the derivative formula. Suppose if you don't know what is the differentiation of x cube, the derivative of x cube has been found by this formula, but we know na derivative of x cube 3x square, derivative of sin x is cos x. All the basic formulas you know have come up mostly from this first principle only. Okay, so since you know the differentiation formula, you will not require this first principle in the questions, in the model of the question. Okay. Now, what is the condition for the function to be differentiable? Number one point, you are at a point, if you want to calculate derivative, you are using the value of the function at that point, which must be defined. That means the first important condition is function should be continuous at the point. It should be defined at particular point. There should be one single value of the function at that point. Left hand side, right hand side, only one value. The function should be continuous at the point x equal to a. And now, if the function is continuous, then we try the derivative by this formula. This formula also uses a limit. Okay, this formula also uses a limit. So left hand limit should be equal to right hand limit. Okay, that means the left hand derivative, we call it as left hand derivative, should be equal to the right hand derivative. Left hand derivative means h tending to 0 minus and right hand means h tending to 0 plus. The change in x, I told you the change in x should be small. It should be a small positive number or small negative number, any change. Okay. So left hand derivative should be equal to right hand derivative. Okay, again, as I told you, first principle you don't need in the question. So how to solve, I will directly show you with the question. Okay, some key points before I bring you the first question. Okay, the basic key points that you have to take here is the basic key points that you have to take here is the derivative of any function at a point also gives the slope of the tangent to the curve. Very, very basic point. In high school, you must have completed these points. Okay, the derivative of a function at any point on the curve gives the slope of the tangent. Okay, is equal to the value of the slope of the tangent to the curve at that point. Some particular important functions you must always know. Never you should take the continuity or differentiability for sinusoid, sin x, cos x, for exponential functions and for polynomial functions. Polynomial functions are the functions in the form of x power n, x, x square, x cube, etc. Okay, integral power of x, we call it as polynomial function. So, sinusoids, exponential, polynomial, they are always continuous and differentiable. Another important function, logarithm function, is also continuous and differentiable in its domain. Now, we know that log is only defined for positive value of x. So, if any positive value of x is taken, then log x is continuous and differentiable. Otherwise, the log is not defined only. Log of negative numbers in the real domain is not defined. Clear? If two functions are continuous and differentiable, then the following will also be continuous and differentiable. F plus minus g, the addition of them. Okay, f into g, okay, the product of them. Okay, and f by g, the division, but only one risk in the division. Only one risk in the division. Okay, this will be continuous and differentiable except at the point, okay, gx equal to 0. Because if gx is 0, again, the entire function becomes undefined. It cannot be continuous and hence automatically not differentiable also. Okay. So these are some basic points. Directly, indirectly, it will be required, especially when I go to the theorems also. Okay, the Lagrange's mean value theorem, the Rolle's theorem, and etc. Simple but an important case. Simple and an important case. Yes, guys. So, we are continuing from morning and we'll continue. We'll continue as long as your energy doesn't die. Okay, that's what I told you in the morning also. Okay, so let me see how your energy right now is. How is the Josh? How is the GATE 2025 temperament right now? So if you're attending and if you're enjoying, do not forget to press the like button. Put your attendance, and your attendance in YouTube is as simple as just a like button. Okay. So yes, show your energy right now. How energetic at this point you are right now. Almost 3.5 hours non-stop completed. Okay, fine. Chalo. Now, comment on the continuity and differentiability of the following function at x equal to 0. Okay, at x equal to 0. Okay, so modulus function. Okay, directly, indirectly, many places you are going to feel this discussion useful. That is why I start with the modulus function. See, so if fx equal to mod x, let me first start by sketching that modulus curve. Okay. Now, why fx equal to mod x, and how do you break the mod x function? So if x is already positive, okay, we take it as x only, like modulus of 6 will be 6 only, na? But if you have minus 6, modulus of minus 6 can be written as minus of minus 6 so that you get plus 6. Okay, so if x is negative, we write down modulus x minus x. Modulus x as minus x. Clear everybody? Clear everybody? For any negative number, place a minus in front. Again, the minus becomes plus. Okay. Okay, so now I would like to sketch this modulus curve. Modulus curve. Okay. For right side, y equal to x. Y equal to x, line with slope 1 passing through origin. It is a line with the slope equal to 1 passing through the origin. Okay, next case. Okay, y equal to minus x. Okay, minus x means a line with the negative slope but again passing through origin. But negative slope, that means a decreasing line it has to be. So these are the two parts wherein on the first part I can say that it is a line with slope 1. On the other part it is a line with the slope minus 1. And first let me tell you the graphical way again of understanding, and then I can show you the method also. So see dear, what is happening at the origin? What is happening at the origin? We call it a sharp point. What is a sharp point? Sharp point or edge point. What is a sharp point? Where the nature or the definition of the function abruptly changes. Where the nature or the definition of the function abruptly changes. Because before origin I have a line. Okay, slope minus 1 means this is the line y equal to minus x, and slope equal to 1, that is the line equal to y equal to x. So at origin the nature of the function abruptly changes. Now y equal to minus x suddenly changes to another line y equal to x. Okay, y equal to x, right guys? So at any sharp point, what will happen? Before I prove it, at any sharp point, function will be continuous. But what is going to happen? Left hand derivative not equal to right hand derivative. That means function is not differentiable. The function is not differentiable. Okay, it is continuous or not? You can see now. Can you draw the function in a single go? It is like a V shape. Okay, the simple way of understanding continuity after I explained you the three cases, I told you if you can draw the function in a single go without taking the pen out of the paper, it will be continuous. So it's just a V. You can draw V. Okay, in a single go. You can draw V in a single go. Clear everybody? Clear everybody? Okay, so the function at x equal to 0, the modulus curve at x equal to 0 will be continuous but not differentiable. Okay, now if you want the methods so that we can attempt the next question also. Okay, so if you want the method, analytic method details, fx is mod x, okay, which is x for x greater than equal to 0, which is minus x for x less than 0. So if you want to talk about the left hand limit, okay, if you want to talk about the left hand limit, what is the left hand limit? Limit x tending to 0 minus, we are checking at x equal to 0. Limit x tending to 0 minus fx. Now, x tending to 0 minus means how much? X tending to 0 minus means how much? Okay, x tending to 0 minus means you are approaching 0 but currently from the less than 0 side. You are slightly below 0. So when you are below 0, what is the definition of the function? When you are below 0, note down the definition of the function, which is minus x. But when you put down the eventual value of x, minus 0 is same as 0 only. And now right hand limit. And now if I have to write down right hand limit means limit of x tending to 0 plus of fx. Limit x tending to 0 plus fx. Limit x tending to 0 plus fx. Now you are approaching x0 but from the values greater than 0, right side. So when x greater than 0, what is the fx? I will have to substitute fx equal to x, but the limit, because it is 0, so whether plus 0 minus 0 same, and the actual value of the function also, what is f0? The fx is mod x function, so modulus of 0 is 0. So we have all the three conditions matching up. LHL is RHL equal to FA. So automatically from the graph also I told you the function is continuous. Okay, but now let me take the derivative of this function. So I told you for differentiability, you will not require the first principle of differentiation. I was telling you. Why you don't require the first principle of differentiation? The simple reason is you know the derivative formulas. So what is the derivative of x? The derivative of x is 1. The derivative of minus x is minus 1. So dear, okay, what is the left hand derivative? What is the left hand derivative? What is the meaning of the left hand derivative? The left hand derivative means the value of the derivative, okay, means the value of the derivative, left hand side, limit x tending to 0 minus of f dash x, okay, x tending to 0 minus. So what is the value of the f dash x? F dash x is known to us, but when you approach from x less than 0 side, the derivative is minus 1. Similarly, what is RHD? RHD means the value of the derivative. Since you have differentiated, you don't need any first principle. Okay, but what is the value of the derivative when you see from x tending to 0 plus? When you are approaching from x greater than 0, the derivative is constant value 1, not equal. LHD not equal to RHD. I told you, no? Same thing I told you. Whenever there is a sharp point, continuous, but LHD not equal to RHD. Okay, so modulus curve is not differentiable at x equal to 0. It is continuous everywhere although. Okay. Okay. So I told you about the sharp point also. Sharp point are also very commonly known as edge point. Okay, if a function is continuous at a point but LHD not equal to RHD, okay, then that point is known as sharp point. Okay, so what? Let me repeat it for a modulus function. Let me actually write it here only. So mod x, what we learned for mod x? Mod x is continuous, okay, but not differentiable at x equal to 0. Okay, so similarly, if I have to put down another function, suppose I give you modulus of some 5 minus 6x about this function, can you say at a point where it is continuous but not differentiable? So you can apply this concept to any modulus function, continuous but not differentiable at what value of x? At what value of x? At what value of x? I can write down at the condition, so that the argument of the modulus function, what is the argument? 5 minus 6x equal to 0 means x equal to 5 by 6. It is continuous but not differentiable for x equal to 5 by 6. So like that, questions can also be framed. And then I already told you about the sharp point. Okay. Okay. Next question. Here it is. Choose the correct option. Choose the correct option. Here. Okay. Choose the correct option. The function is continuous, or what is the condition here? Okay. The function is continuous at x equal to 2, differentiable at x equal to 2, continuous at x equal to 1, differentiable at x equal to 1. Now, this has been converted to MSQ question. See dear, at x equal to, the definition changes at x equal to 2. The definition is changing at x equal to 2. That is the only risk point. That is the only risk point. So what about x equal to 1? At x equal to 1, the function x equal to 1 means less than 2 condition. What is the function? Please see, the function for x equal to 1 should be, okay, should be x square minus 1. Should be x square minus 4, okay, which is a polynomial category. So should you check at x equal to 1? Tell me. You should not check, because for any value of x less than 2 given, the function is polynomial, or even any value of x greater than 2 given, x minus 2, this is also polynomial. Any x power n function is polynomial, and polynomials are always continuous and differentiable. Continuous and differentiable both, always C and D. That means option number C and D is to be tick marked. That is just blindly you can tick mark. At x equal to 1, it has to be continuous and differentiable. The risk point is where the definition of the function is changing. Okay, at x equal to 2, what happens? So what I'm going to do is, you can solve it by the method also. You can solve it by the method I told you, or better, you can even draw the graph where it is like a linear or quadratic function. Linear means straight line, quadratic means parabola. If it is a very common curve, draw the curve. If it is not a common curve, then do the analysis. Okay, both are okay in a sense, but here if I want to draw the curve, because it's a simple case I see, so if I want to draw the curve, okay, the fx is equal to x square minus 4 for x less than equal to 2. Okay, so x square minus 4, okay, parabola going down, it has to be parabola dipping down, not only x square. I'll redraw it once again, just a second. Y equal to x square is the parabolic opening up, but it is x square minus 4. Okay. So at x equal to 0, the y coordinate should be minus 4. The parabola dipping down, I mean opening up, but starting from down, I mean. Okay, but this is for up to x less than equal to 2. Okay, 2 square minus 4, okay, will be 0. Okay, so at x equal to 2, we can stop and the value is 0. Why do I stop here? Because at x equal to 2, definition is changing. For 2 to infinity, it should be given by x minus 2. Now, what is the line x minus 2? What is the line x minus 2? Okay, it is the line with slope 1. At x equal to 2, this also will have the value 0, 2 minus 2. That starts from this point, but line with slope 1. There is going to be a straight line with the slope equal to 1. So now there will be a straight line with slope equal to 1. Y-intercept not required, but yeah, what is the meaning of this y-intercept? That if you take it back, okay, the y-intercept should be minus 2. If you take it back, but the line starts from x equal to 2, that is why I have not shown the backside portion. If it was extended back, okay, so it is clearly continuous, but only thing is sharp point is coming up. What is this? Sharp point. The nature of the function changes. Okay. Is it broken? No. Can you draw it in a single go? Yes. Can you draw this curve? See here, like this. Do I need to take the pen out? See once again. Do I need to take the pen out? No. We can draw it in a single go. It is continuous 100%, but because of sharp point, it is not differentiable. You want to try by the previous method? Okay, you try it out, 100% answer will be same. So it is continuous but not differentiable. So option number A will go. Okay, but it is not differentiable at x equal to 2. Okay, so because of the sharp point at x equal to 2, we can say that it is C, okay, but not D. Okay, in short, I am writing it is C but not D. Clear? The correct answer is A, C, D for this MSQ question. The correct answer for this MSQ question is the A, C, D. Hope that is clear to you. A, C, D is the very correct answer. A, C, D is the very correct answer to this question. A, C, D is the very correct answer to this question. Next. A GATE 17 2 marks question. A function is given to you. A function fx has been given to you. Now you see, exponential curve we still know, e power x. Individually, I also know x means straight line, x square means parabola, logarithm curves also alone I know. But combination of them will make what curve? So if you want to sketch the curve, I think it will be more time taking here. If you want to sketch the curve here, it is going to be more time taking. Okay, so don't sketch, you can just try the method. It is the questions about differentiability. Or the question is about differentiability, but the first condition of differentiability is continuity. You cannot attempt it without checking the continuity. The first condition is continuity, of course. The first condition is of course continuity only. Clear? Okay, let's do it. A function fx is defined as fx equal to e power x for x less than 1, ln x plus ax square plus bx for x greater than equal to 1. Okay. Okay, fine. So the first condition is continuity. Okay. Don't forget this. So f of x e power x and ln x plus ax square plus bx. ln x plus ax square plus bx for x greater than equal to 1. And this is for the x less than 1. This is for the x less than 1, where x belongs to R. Which of the following statements is true? Which of the following statements is true? First, let me also calculate the derivative of this function. What is the f dash x? E power x derivative is e power x. Ln x 1 upon x. X square derivative is 2x. So here I get 2ax and x derivative is 1. Clear? Now, left hand limit and right hand limit. First, what is left hand limit? Now dear, don't exaggerate the theory every time. I've told you the methods, directly write down the value. See, what is left hand limit? Limit x tending to 1 minus, only at 1 we have to check now. 1 minus fx, then you will put down what is fx. So better left hand limit means you are coming from x less than 1. Okay, I know it. I don't have to write it every time. When I'm coming from x less than 1, what is the definition of the function? E power x. At what value I'm checking? At x equal to 1. So directly put e power 1. One single line, write down the left hand limit because I am checking at x equal to 1 only. Then right hand limit means when you are approaching the function from x greater than 1 side. From x greater than 1, what is the definition? Copy this definition and put down x equal to 1. So ln 1 plus a into 1 square plus b into 1. Log 1 is 0, so I am left with a plus b. I am left with a plus b. Okay, right. So for these two to be equal, okay, for these two to be equal, a plus b should be equal to e. A plus b, because for the function to be differentiable, it must be first continuous. And for continuity, one condition is LHL equal to RHL, a plus b equal to e. Okay, now come to the next side. Now next side, I will write down the left hand derivative. So I told you now what is left hand derivative. The left hand derivative means the value of the derivative. Left hand derivative means the value of the derivative. The value of the derivative, okay, for x less than 1. Okay, so when you are approaching for x less than 1, the derivative is e power x. So when you reach from left side x equal to 1, derivative e power 1. What about RHD? Right hand derivative. Okay, for x greater than 1, the derivative would be 1 by 1. Exactly at x equal to 1, if I now put, okay, that becomes 2a into 1 plus b. And hence, this is 1 plus 2a plus b. 1 plus 2a plus b. Okay, 1 plus 2a plus b, correct. Now, what is the meaning of left hand derivative equal to right hand derivative? For differentiability, we need LHD equal to RHD. So, what is the next condition coming up from here? Okay, 1 plus 2a plus b equal to e. So, for the function to be continuous, this is the required. But for the function to be differentiable, both of them are required. Okay, so when I take both of them together, a plus b equal to e and 1 plus 2a plus b is also equal to e. Perfect. Okay, so 1 plus 2a, I can break it as 1 plus a plus b equal to e, and a plus b again I replace it by e. So e cancelled, 1 plus a 0, a is minus 1. If a is minus 1, so b will become e plus 1. That means yes, function can be differentiable. Okay, but not everywhere, only for these two values of a and b. So let's read the option. Function is not differentiable at x equal to 1 for any value. Who told you? It can be differentiable. It is differentiable at x equal to 1 for some unique values of a and b. Yes. Okay, for what unique values of a and b? Where a is minus 1 and b is equal to e plus 1. Function is differentiable for all values of a and b such that a plus b equal to e. No. It is differentiable for these two combined conditions. It is differentiable for these two combined conditions. And when I combine both of them, I got a unique set of values of a and b. Only one solution of a and b. And fx is differentiable for all values, not at all. So option number B. So when I'm telling you, this is like a good analysis question. You don't have to draw the curve because drawing curve here will take more time. Previously, I told you it's a parabolic and a line case, so better to draw the curve. Okay, when random functions are given, better to do the left hand limit, right hand limit analysis and also LHD, RHD analysis. Okay, LHD, RHD analysis. Okay, for LHD, RHD, you don't have to use first principle of differentiation because you know the derivatives. You know the derivatives. What I'm using is, there is a derivative function, which is again some function like gx. Let's say this is gx. What I'm checking, left hand and right hand limit of gx. In a way, one more important point you can note down conceptually. Okay. One more important point you can note down conceptually is that if a function fx is differentiable at a point x equal to a, okay, then its derivative f dash x is said to be continuous at that point, or vice versa. If the derivative of a function is continuous at a point, then the function is differentiable at the point. Okay, then the function is differentiable at the point. Clear? Lagrange's mean value theorem. Some theorems around the concept of continuity and differentiability only. Okay, so suppose there is a real valued function. Okay, satisfying only two simple conditions. It is continuous in the closed interval AB. It is differentiable at least in the open interval AB. Okay. Continuous in the closed interval means including the endpoints. Differentiable means even if it is in between AB also enough. This is the minimum condition required. Then what happens? Very simple analysis. Now, we can take any 2 points where the function is continuous, not broken at a point, not discontinuous at a point, and it is differentiable. That means no sharp point. Okay. So this can be taken as an example. These are the 2 points, A and B. These are the 2 points A and B. Okay, where the function, okay, is clearly a smooth function, a continuous function. Can I draw it in a single go? Yes, I just drew it in a single go. There is no broken segment. And is there any sharp point? Visualize no sharp point. Nowhere the same function, just like a inverted parabola type of case I have taken. The function is continuous and differentiable at all the points, and derivative of a function at a point is also equal to slope of tangent to the curve at that point. Is also equal to the slope of the tangent to the curve at that particular point, isn't it? Slope of the tangent to the curve at that particular point. Okay. So what will happen? Because the function is differentiable at all the points, so there can be several tangents that you can draw to the function. There can be several tangents at any point. Maybe this is a tangent, at this point this is a tangent, several tangents you can draw. But there comes a point in between this AB. There comes a point C, where the tangent when you draw is parallel to the line joining AB. Okay, what is the important point about this particular tangent? Okay, this tangent, okay, at the C, the tangent that you draw is parallel to the line joining the endpoints. Okay, parallel to the line joining endpoints, and parallel lines have equal slope. What is the slope of tangent? What is the slope of tangent? Because it is parallel, so we can say that slopes are equal. And what is the condition for equal slope? Okay, slope of tangent f dash c. Slope of tangent at the point is f dash c. Okay, this is a tangent, and the tangent will have a slope which is given by derivative of the function at the given point, that is c, and that should be equal to slope of the line. Now, how do you calculate slope of the line joining two points? Let me write down the coordinates. B, the x coordinate is b and y coordinate becomes fb, the value of the function at this point, that is fb. The point A, x coordinate is a and the y coordinate is fa. The y coordinate is fa. So what is the value of f dash c? It is given by fb minus fa is divided by b minus a. fb minus fa is divided by b minus a. The f dash c is given by fb minus fa is divided by the b minus a. Is divided by b minus a. Is divided by b minus a. F dash c is equal to fb minus fa upon b minus a. Clear, everybody? So then there exists a point x equal to c in the interval a comma b such that f dash c equal to fb minus fa upon b minus a. We'll take questions on it. Now, dear, third condition, if I add here, that becomes Rolle's theorem. Okay, a function is continuous in the closed interval ab, differentiable in the open interval ab, and fb equal to fa. If these two values are equal, then when you subtract, the numerator will become 0, f dash c will be 0. F dash c will be 0. That becomes the Rolle's theorem. Same, it is continuous in the closed interval ab, differentiable in the open interval ab, and fb equal to fa. So the numerator is 0 and hence f dash c equal to 0. Here, if I want to draw the picture, okay, fb equal to fa, that means the height of the points a and b. The height of the points a and b. The height of the points a and b are equal, and that is why the tangent at c is parallel to ab, that means parallel to the x-axis. Okay, so this will have slope which is 0, and that is why, because it is parallel to x-axis, that is why graphically also we can say f dash c equal to 0. Now, Cauchy's mean value theorem, not very important, rarely any question. LMVT is still important. Rolle is also not that frequent. Okay, only Lagrange's here takes a more edge. Okay, fx and gx are two real valued functions such that they are both continuous in the closed interval ab, they are both differentiable in the open interval ab. Okay, then there will exist a point x equal to c belonging to the interval ab such that individually you can say f dash c is fb minus fa upon b minus a. G dash c is gb minus g upon b minus a. So when you take the ratio of them, b minus a got cancelled. This is the net result. This is the net result. Okay, the question. Find a c for the Rolle's theorem for the function. The question could be as straightforward as this also. The question can be as straightforward as this. Okay, find the c for the Rolle's theorem for the fx equal to e power x sin x in the interval 0 comma pi. In the interval 0 comma pi. Okay, so let's find it. Find the c for the Rolle's theorem for fx equal to e power x sin x. Okay, now e power x sin x. See whether it is continuous and differentiable. See dear, e power x exponential, I told you, always continuous and differentiable. Sin x is also sinusoidal category, always continuous and differentiable. Always means always. So that means if two functions are continuous and differentiable, I told you, their product will also be continuous and differentiable. Okay, so the function fx is also always continuous and differentiable, but I don't need always. Is it continuous and differentiable in this interval? Yes, it is continuous and differentiable in any interval. So what is the language I can frame here? What is the language I can frame here? Fx, okay, number one is continuous in the closed interval ab. It is continuous everywhere, so tick mark. Is it differentiable in the open interval ab? It is differentiable everywhere, so no problem. So this also satisfies. So it is continuous and differentiable both. It is continuous and differentiable both. Oh, what happened? Students suddenly tired or what? Let me know if you're tired, we can stop. Because I am going to go, but if you feel tired, we can stop also, no problem. I thought we'll go very, very long. Okay. So, yeah, it is continuous and differentiable. These two condition meets. Okay. But whether FB equal to FA. Whether FB equal to FA, right? So, whether F0 equal to F pi or not. Let us check this. Okay. So, what is the F0? F0, e power 0 sine 0. But sine 0 is 0, na? Okay. Similarly, what is F pi? E power pi sine pi and sine pi is 0. Okay, so both of them are 0. So F0 equal to F pi, yes. The Rolle's theorem conditions are met. Rolle is satisfied. Then, as per the Rolle's theorem condition, as per the Rolle's theorem conclusion, okay, there will exist, okay, x, okay, belonging to what interval? 0 comma pi, so that, okay, so that f dash c equal to 0. There will be x equal to c in the interval 0 comma pi, in the interval 0 comma pi, such that f dash equal to 0. What is f dash x? First of all, what is the derivative of the function? So e power x constant sin x derivative cos x and plus sin x constant e power x derivative 1. So what is the value of f dash c? F dash c is some e power c cos c plus sin c. This must be 0. This must be 0. So this can be satisfied for what value of c? Okay, this can be satisfied. You can cross check the options. Okay, you can just cross check the options. Minus of tan c. Okay, so we'll have to do some calculations here. Is this correct? Na? F dash c must be 0. F dash c is e power x into cos x and plus sin x. Plus sin x. Sorry, this I missed it actually. E power x constant, derivative of sin is cos. Okay, then sin x, if it is constant, e power x derivative is e power x. Na? Okay, so yeah, it's a simple equation only. Okay, so e power c sin c is 0. That means, so e power c constant, cos c plus sin c equal to 0. E power c cannot be 0 because that is only possible for c equal to minus infinity. Okay, so I will take the solution as sin c equal to minus cos c. That is only possible at tan c equal to minus 1, that is c equal to 3 pi by 4. You can convert to tangent also. So tan 3 pi by 4. The answer is B. Tan 3 by 4. Yes, Rohan, correct answer. Tan 3 pi by 4, option number B. Tan of 3 pi by 4, option number B it is. Tan of 3 pi by 4, option number B. Next question, dear. Next question, dear. Now find the C of the Lagrange's mean value theorem for the function fx equal to ln x in 1 comma pi. Fx equal to ln x in 1 comma pi. Okay, so as I told you, log function also I told you. What is the story about log function? The log function is continuous and differentiable for all values of x greater than 0, for positive in its domain. Yes, the range is positive only. 1 comma e means all positive range only. That means I can now say that fx is continuous in the interval 1 comma e. Yes. Is it differentiable in the open interval 1 comma e? Yes. For all positive value of x, it is differentiable and continuous both. That means Lagrange's, in short, LMVT is applicable. And as per LMVT, the conclusion is there will be a point such that, okay, f dash c equal to fb minus fa upon b minus a. Now, what is the derivative of log x? Log x derivative 1 by x, put down x equal to c. So, 1 by c. What is fb? So, fb means log of e. fx is log x, so b is a. fa means log 1 upon b minus a, upon e minus 1. Okay, so what is the calculation, dear? 1 upon c actually equal to log e is 1, log 0 is, log e is 1 and log 1 is 0 upon e minus 1. So just comparing the denominator, numerators are anyways common, c would be e minus 1. The value of c, e minus 1, option number B here again. Option number B. Correct, everybody? That is what is the option number B. That is what is the option number B. Next question. Next question to be taken here is, consider the fx modulus of 1 minus x. Okay, this is slightly a better question. Consider fx equal to modulus of 1 minus x, 1 less than equal to x less than equal to 2, and gx equal to fx plus b sin pi by 2x, 1 less than equal to x less than equal to 2. Okay. Now dear, first of all, let's talk about modulus function. Okay, what we knew about modulus, and then for which of the function LMVT applied, for which of the function Rolle is applicable, the options are around that. Okay, the options are around that. That means, dear, let me start with the fx function. Na? Let me start with the fx function. What is the fx function? Is modulus of 1 minus x. And what do we know about modulus? Modulus, it's continuous everywhere but not differentiable. At what point? At 1 minus x equal to 0. Argument, I told you that method. Argument equal to 0 means x equal to 1. Means the x equal to 1. Clear? But my point of interest, given fx, okay, only in the range 1 less than equal to x less than equal to 2. Okay, now let me talk about fx function. Fx is, tell me, is it continuous in the closed interval 1 comma 2? Yes. Is it differentiable? Differentiability is required in the open interval 1 comma 2. Is it differentiable for all values of x between 1 and 2? Is it differentiable for all values of x between 1 and 2? Yes. It is differentiable for all values of x between 1 and 2? Yes, it is. Yes, it is. It is continuous in the closed interval. It is differentiable in the open interval. It is not differentiable at x equal to 1, but I don't want the differentiability at boundary points. The minimum I want the differentiability between a comma b. Yes. Okay. Yes. Okay. But what about fa equal to fb? Is f1 equal to f2? Okay. Let us see. What is f1? Modulus of 1 minus 1. 0. What is f2? Modulus of 1 minus x. Modulus of 1 minus 2. Magnitude of minus 1 is 1. So no. No. F1 equal to F2? No. That means, okay, we'll give a break, no worries. Okay, that means what is satisfied is LMVT. Okay, LMVT is satisfied but not Rolle's, because for Rolle's we need FA equal to FB. So LMVT is satisfied but not Rolle's. For the function fx it is done. Now what about the gx function? Gx is fx plus b sin pi by 2x. What about gx? It is the function fx plus b sine of pi by 2x, and that means, okay, fx plus b sine pi by 2x, that means what? Okay, so fx already we know, sine we know that, always c and d. Always c and d. So what can I say, dear, about the gx function? Now keep telling. Gx, first point, is it continuous in the closed interval 1 comma 2? Okay, is fx continuous in 1 comma 2? Is fx continuous in 1 comma 2? Yes. Okay, is sine continuous? Is sine continuous? Sine is always continuous, so this is also continuous. Then differentiable. Okay, is the gx differentiable in the open interval 1 comma 2? Is the fx differentiable in the open interval? Yes. Is the sine? Sine is always differentiable. Yes. Now next point, my next question is GA equal to GB? Is GA equal to GB? G1 equal to G2? G1 equal to G2. So what is the G1? G1 should be F1 plus B sine pi by 2x, put x equal to 1. But what is the value of F1? F1 was calculated as 0. Okay, 0 plus B sine pi by 2 is 1. So this value is B. Okay, what about G2 value? G2 should be now similarly F2 plus B sine pi by 2x. Okay, so F2 we calculated as 1. Okay, but sine pi by 2 into 2, sine pi is 0. So this answer is 1. So we can say that, yes, G1 equal to G2. Yes, it can be equated, but not always. If you make B equal to 1, B is in your hand. Na? G1 is B, G2 is 1. B is in your hand. If you make B equal to 1, G1 equal to G2. Right? So LMVT to always, but it can satisfy Rolle's theorem if B equal to 1. If B equal to 1, okay, the third condition also meets. And now options. Rolle's is applicable for both f and g with b equal to 3 by 2. No. Rolle's is not applicable to f. For f, Rolle's is not at all applicable. So A option wrong. LMVT not applicable to f. This is wrong. For f, LMVT is applicable. See, LMVT applicable to f and Rolle is applicable to g with b equal to 1. Yes. LMVT applicable to f. Very correct. Rolle is applicable to g with b equal to 1. Very correct. We got b equal to 1 only. Rolle's is not applicable to both f and g for any value of b. No. It is not applicable to f, correct, but it is applicable to g with one particular value of b, and hence C is the suitable option. Matching all our cases, C is the most suitable option. C is the most suitable option. Hope that is clear. C is the most suitable option. Next question. Next, suppose that f r to r, that is a function whose the domain is set of all real numbers, range is also set of all real numbers. It is a continuous function in the interval -3, and a differentiable interval. See how the question is hinting you about LMVT or Rolle's. See, it is a continuous function in the closed interval a comma b. It is differentiable in the open interval a comma b, and these conditions are required in LMVT or Rolle's. But they don't say f -3 equal to f3. So at least LMVT is satisfied. Okay, such that for every x in the interval, f dash x less than equal to 2. So what is given to you? Fx. It is continuous in some closed interval AB. It is differentiable in some open interval AB. Okay, that's what is given. So that means what is sure is LMVT can be applied. LMVT can be applicable. Yes, Nishu, correct. LMVT is applicable here. Okay, now as per LMVT, what do we have? LMVT says that there is some point, okay, in between the given interval where the derivative f dash c or f dash x is given by fb minus fa divided by b minus a. B minus a. Correct? Now you see, one of the value f minus 3 is given, and they are telling you that this f dash x, okay, any point in the interval f dash x is less than equal to 2. Okay, f dash x at one point, f dash x can be written as f3 minus f minus 3 divided by 3 minus minus 3, but this will also be less than equal to 2. This will also be less than equal to 2. Correct? Okay, so that means f3 is not known, but f minus 3 they have given. Okay, minus 7. Okay, divided by 6 less than equal to 2. So 2 into 6, 12 plus 7. So f3 is less than equal to 19. Now the question is asking, what is f3 at most? f3 is less than equal to 19. That means it can be 19 or below it. So what is at most value? Maximum value of it is 19. It is at most 19. It is less than equal to 19. That means at most it is equal to 19. The maximum value of it is equal to the 19. Hope that is clear. The maximum value of it is equal to 19. Clear, everybody? Okay. Okay. Time for a break. Okay, as you know, students are demanding time for a break. Okay, time for a particular break. Okay, and after the break, immediately, at least one topic I'll tell you, and then rest depends. Okay, rest it depends on time to time. Okay, what topic I choose next, it keeps on, you know, I'll decide as per the timing. I'll decide as per the timings. Oh, just a second. So till now also a lot of concepts covered. Linear algebra, actually I took it in a very good, I mean, in a rank, linear system of equation, eigenvalue, eigenvector, I think even if you watched it for the fresh time, that should be sufficient. That should be sufficient for your GATE preparation. That's what I feel. Only rest you take up some PYQs. Okay. So yes guys, break time. So what's the time currently? Approx 20 minutes, I think we'll do. Break for roughly 20 minutes. Okay, let's not extend it more because more and more we can cover if we give more time today. Okay, the break for approx 20 minutes. Okay, the class resumes at it is roughly 2:18. Okay, so the class roughly resumes at 2:40 p.m. 2 minutes more. Okay, at 2:40 we are going to resume. You can go for the break right now. You can go for the break right now. It's, to be precise, 22 minutes from now. Okay, we will start. Okay, right. So joining you back around 2:40 once again. Continue. Okay, and at least the next topic I have told you, very, very important, maxima and minima. Very, 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 very important, maxima and minima to be discussed. Okay guys, so welcome back. Welcome back after the break. Let's continue. All right, let's keep continuing the discussion. Okay guys, so welcome back. Okay. Hi, very good afternoon everyone. Welcome back. Welcome back after the break. So yeah, now finally let's continue our discussions. Okay, hope you all had lunch and small refreshment. Okay, hope you didn't have much also, otherwise you might feel sleepy at the afternoon time. But yeah, as I told you, next I would be picking up after the break is the concept of maxima and minima. Okay, is the concept of maxima and minima. First starting with local maxima, local minima, and then of course also telling you how to calculate global maxima and global minima. Okay, so let's start taking up these questions. Let us start taking up these questions. So local maxima and local minima. Okay. First of all, look into the nature of the curve where the function is initially shown to be increasing. Again, no derivation right now. All these analysis are very simple derivation, but since it's a revision part, let's not spend time there. So, in the function with the beginning in which the function is shown to be increasing in the beginning, and if a function is increasing, the derivative of the function at any point where the function is increasing, okay, has to be positive. It reaches its maxima, local maxima value. It reaches its local maxima value where if you draw a tangent to the curve, at this local maxima point, this tangent will be clearly parallel to the x-axis, and because of it, the slope of the function at this point is definitely 0. The f dash x at this point will be 0. And then after reaching the highest point, the function value is again decreasing, and the derivative of the function at any point where the function is decreasing is negative. It decreases, reaches the minima, the local minima, the minima in this particular zone. And again, if you take the tangent to the curve at this point, if you again take the tangent to the curve at the point of local minima, so what happens to this tangent? Okay, this tangent is again parallel to the x-axis, meaning the again slope here will be 0, and then the function is again decreasing where the derivative of the function f dash x is of course positive. Okay, is of course positive. Clear? All right. Okay, Teja, all the best for your GATE paper. So at any point whether the function is increasing, okay, the derivative of the function is positive, and at a point where the derivative is negative, function will be decreasing at that particular point. Okay, and at the local maxima, local minima, both of the points, the derivative of the function would be 0. Okay, so if you have to hunt for local maxima, local minima, first you should be getting the candidates for local maxima, local minima, which is obtained by solving f dash x equal to 0, which in general are known as the stationary points. The solution of f dash x equal to 0 will give you stationary points. The solution of f dash x equal to 0 will give you what are known as stationary points. Now, When I talk about stationary points, they are not always maxima or minima. So there are three cases. The stationary point may be local maxima, the stationary point may be local minima, or the stationary point, okay, may be a POI. Okay, a stationary point, okay, which is neither local maxima nor local minima. Okay, a stationary point which is neither local maxima nor local minima will be the point of inflection, will be known as the point of inflection. Okay, now to classify which point is local maxima, local minima, or point of inflection, we have two types of analysis: first derivative test and the second derivative test. Okay, what is the first derivative test? In the first derivative test, whatever test you have to apply, the first step is getting the stationary points. The first step is getting the stationary points, and for the stationary points, you have to solve the equation f dash x equal to the 0. For the stationary points, you will be solving the equation f dash x equal to 0. Correct, f dash x equal to 0. Now, what happens around the stationary point? Okay, if you want to distinguish the maxima and minima, have a look into it. Around the if it was a local minima, the function was increasing, then reaches maxima and then decreasing. That means if you look into the first derivative sign, it changed from positive to negative. So we can say that there is a sign change of first derivative. Okay, from positive to negative, increasing to decreasing. Okay, increasing to decreasing. Okay, so if the first derivative changes in sign from positive to negative, then that stationary point is a point of local maxima, and vice versa. If the first derivative changes in sign from negative to positive, decreasing to increasing, negative to positive, then that is a local minima point. So if the first derivative changes in sign from negative to positive, reverse, then that stationary point is a point of local minima. Okay, that stationary point is a point of local minima. And if there is no sign change, we'll take up all the cases. If there is no sign change, okay, there is no sign change for the function f dash x, then it would represent POI. Okay, then that will represent the POI. We also have the second derivative test, but under which situations, what test will be helpful for you? I'm going to, talk with respect to questions. So what is the second derivative test? Okay. The earlier one, as I mentioned, is the first derivative test, which depends on the sign change of the first derivative around the stationary points. If I talk about second derivative test, okay, so what I'll tell you, suppose x equal to x naught, anyone x equal to x naught be a stationary point. Let x equal to x naught be some stationary point. How do you calculate stationary point? I've told you. Now, by f dash x equal to 0, by first derivative equal to 0. Clear? Now, if at the stationary point, the second derivative is positive, that will confirm a local minima. If second derivative negative, that will confirm a local maxima. But if the second derivative is 0, okay, you have to go further. Further means the higher derivative, next derivative, that is third. That is third derivative. Now, if third derivative turns out to be at the stationary point, if the third derivative is either positive or negative, anything, that means if the third derivative is non-zero, if the third derivative at the x naught is non-zero, then that point will be neither maxima nor minima, which I already told you as a point of inflection. Okay, POI. Okay, but if the third derivative also 0, we go for fourth derivative. Hardly you will go to this case, but yeah, the rule of fourth derivative will be same as second. Okay, if fourth is 0, go further. Further means fifth derivative rule, which will be same as third derivative rule, and etc. Now let's understand with respect to a problem here, first of all. Okay, MSQ question. Okay. Teja, always weightage analysis is done for a subject. We cannot do weightage analysis in any competitive exam for a particular topic. Okay, a function is defined by fx equal to 2x cube minus 3x square plus minus 12x plus 5. Which one of the following is true about this function? Which one of the following is true about the function? Hi, good evening, Ankit Mishra. Okay, which of the following is true about the function? Function is decreasing for this interval. It has a maxima at this point, minima at this point, decreasing for this interval. What of the options can be correct for this particular function? Okay, what are the options that can be correct for this particular function? Okay, so let's do it out. Okay, let's do it out. Okay, for that, at least stationary points are required. And what is the f dash x? The f dash x, 2 into 3, 6x square minus 3 to 6x, and minus 12 equal to the 0. Correct? Equal to the 0. Okay, f dash x equal to 0. So 6, if I take common, so x square minus x minus 2 is 0. This will give you, we can factorize it actually, x minus and 2, x plus of 1. Okay, so what are the roots you will be getting? X equal to 2 and minus 1. The roots that will be turning out is x equal to 2 and minus 1. These are the stationary points. Now, better what you can do is you can apply a method which I am going to tell it as a wavy curve method, because what you have to check, okay, for increasing, decreasing, okay, increasing means what? F dash x greater than 0. Decreasing means what? F dash x less than 0. What is the f dash x? Okay, f dash x is this function 6x square minus x minus 2. That means polynomial function. Okay, the f dash x, this is the f dash x, polynomial function. So for polynomial function, okay, you are getting greater than less than 0 means it is a polynomial inequality basically. Okay, greater than and less than 0 doesn't make an equation. This is an inequality. You have polynomial inequality, and for polynomial inequality, you can simply use, okay, the first derivative test along with the combination of wavy curve. Very, very simple. Okay, how do you draw the wavy curve? Now, how do you draw the wavy curve? Okay, how do you draw the wavy curve? Let's check it out. How do you draw the wavy curve? Okay, so wavy curve. Okay, Teja says all answer correct. Let's check it out one by one. Okay, wavy curve. First, draw the x-axis. Okay, draw this number line containing the x values. Okay, and write down. Okay, write down the roots of the f dash x. Okay, what are the roots of f dash x? Roots means where the f dash x equal to 0, and the roots are 2 and minus 1, which are basically your stationary points. Okay, which are basically your stationary points. Clear, everybody? So I'm going to take up these points 2 and minus 1, and I'll put it in the increasing order on this number line. This is minus 1 and this is 2. Minus 1 and 2. Now, wavy curve is a wave which will start from the right of largest root. You have to start from the right of largest root with a plus sign. What is the largest root here? 2. Start from the further right of it with a plus sign, and at every root keep changing the sign. So if I start with plus at this root, I will change sign to minus, and at the next root again I will change the sign to plus. At every root, at every non-repeated root, keep changing the sign. At every non-repeated root, keep changing the sign. Okay, so these are the sign changes that are done. Okay, these are the sign changes that are done. Okay, now after this, okay, this is what? This is the wavy curve as I told you. This I have drawn as the wavy curve for which function? For f dash x function. Now, where is f dash x positive? That is increasing zone. Okay, where is f dash x positive? Positive means increasing zone. And wherever is the f dash x negative, that means the decreasing zone. Okay, now when you're doing the analysis, drawing the wavy curve, we have to draw reverse. That is a technique of drawing the curve, starting from the right of largest root with the plus sign. But when you do any functional analysis, increasing or decreasing, we always do the analysis of the function for increasing value of x. Now, what happens at x equal to minus 1? The first derivative changes in sign from plus to minus. Plus to minus means this is a point of local maxima. Correct. First derivative changing in sign from negative to positive, decreasing to increasing. That means that is a point of local minima. Okay, local minima. Okay. So function has a local minima at x equal to 2, local maxima at x equal to minus 1. It is decreasing from minus 1 to 2, and it is increasing for x greater than 2 and x less than minus 1. Now, one by one options. It is decreasing from minus 2 to minus 1. No, minus 2 to minus 1 will be here. It is increasing. So A option is wrong. Okay. It has a maxima for x equal to minus 1. Yes, correct. It has the minima for x equal to 2. Yes, correct. Option number D, so B correct, C correct. D, it is decreasing from minus 1 to 2. Minus 1 to 2 decreasing, perfect. So 3 options are correct here, and that is respectively B, C and D. Okay, the 3 options are correct here, that is B, C and D respectively. That is the B, C and D respectively. Clear? That is the B, C and D respectively. Tell me if you have any doubts. Okay, so this way you can simply No, you can simply comment on the local maxima, local minima, or the increasing decreasing zone by this wavy curve. Okay, by this wavy curve. Now dear, so no need to apply the second derivative test here. Before we take up more better problems, let me again go to a fundamental problem here. We'll come back to it later. Let me go to a fundamental problem first of all. Have a look into this problem. X cube, the cubic curve. Okay, at a point x equal to 0, the function fx equal to x cube has what? The function fx equal to x cube has what? Okay, now see, if you talk about the stationary points, first is f dash x equal to 0. F dash x, so what is the derivative of this? 3x square. Okay, so 3x square equal to 0, that means x square 0 means x equal to 0, 0. X equal to 0, 0. You have a repeated stationary point. You have a stationary point, but that is repeated. At the same location, there are two values. Now, what is the significance of this? You have a repeated stationary point. Now, if you want to go for the second derivative test or first derivative test, both I can say. Okay, if I want to go by the second derivative test, see. For second derivative test, you need to calculate f double dash x. So, what is the first derivative? 3x square. Again, you differentiate 6x. But what I need the second derivative at the stationary point. What is my stationary point? 0. Okay, so f double dash 0 is 0. And I told you whenever second derivative is 0, you go for the third derivative. You go for the third derivative. Now, f triple dash x. Okay, third derivative, 6x derivative 6. So, what is the value of f triple dash 0? The value of the third derivative at 0. Okay, it is just constant. Okay, so even at the stationary point, it is 6. That means the value of the third derivative is 6, which means non-zero. So as I've shown you, if second derivative 0, but third derivative non-zero, it is a point of inflection. It is a point of inflection. It is a point of inflection. Neither local maxima nor local minima. At the same point, both local maxima, local minima is impossible. At the same point, local maxima, local minima, both is impossible. Okay. So C option can never occur. Okay, now this is neither local maxima nor minima. Okay, or if you are solving by the first derivative test. The first derivative test needs what? For the first derivative, wavy curve is sufficient. Okay, what I will do, I will simply draw the wavy curve for f dash x. What I will do, I know, is only I will draw the wavy curve for f dash x. Okay, first derivative test where I will draw wavy curve, because again I have polynomial for f dash x. What are the roots of f dash x equal to 0? The roots is 0. But remember, it is a, let me highlight, it is a repeated root. Now what I told you about wavy curve? What I told you about wavy curve? Wavy curve is a curve that you will start from right of largest root. So this is the only largest root, and with a plus sign. We'll start from here with a plus sign, clear? Start from here, plus sign, okay? And then at every root. And at every root, remember, and at every root we keep changing sign. So do I change sign here? No. Why? Listen to me. Why I don't change sign here? I'm telling you, at every root you need to change sign. So at the same location, how many roots you have? At the same location, you have two different, at the same location, you have two roots, not different, repeated, but at the same location, you have two roots. So how many times sign change? Plus to minus, minus to plus. At the same location, two sign change, and two sign change means plus to minus back to plus. Plus to minus back to plus. Okay. So because it was repeated, actually, because it was repeated, so no sign change occurs. I mean, double sign change occurs, which is effectively no sign change. Okay, and because there is no sign change, okay, because there is no sign change, okay, and for that reason it becomes point of inflection. And for that reason it becomes point of inflection. So even first derivative also confirms the same. Okay, now it is a very simple curve I have taken, cubic curve. Let's have a look into the cubic curve. Okay, fx equal to x cube. This is what is a cubic curve actually. Okay, this is how a cubic curve actually looks like. Let me trace it actually. Let me change it with a different color. This is what is the y equal to fx, y equal to x cube cube. Now, if you take origin, if you take origin and draw the tangent to the curve, dear, at the origin, if you draw the tangent to the curve, so when you draw the tangent to the curve at the origin, how the tangent is going to appear? When you draw the tangent to the curve at origin, okay, this is the tangent which has been drawn from this point. Okay, tangent at x equal to 0. Okay, how much is the slope? Since it lies on the x-axis, slope means 0. Okay, slope means 0. That means f dash x is 0. Slope is also equal to the derivative of the function. So it is a stationary point. Okay, so this x equal to 0 is a stationary point. Okay, but is it a maxima or minima? Okay, the function was increasing. Okay, and it kept on increasing. For a moment, it looks like it halted. It was about to change the nature, but no, from increasing, it remained to be increasing. The function was increasing, remains to be increasing. Okay, that means this is the point of inflection. Okay, this is a point of inflection. This was a stationary point, but turns out to be neither maxima nor minima. Turns out to be neither maxima nor minima. So it is a POI. Clear, everybody? So it is known as point of inflection. So it is what is known as the point of inflection. Done? So it is what is known as the point of inflection. Correct, everybody? Okay. So this is about point of inflection. Now let me go to the next question. A function fx is defined to you 2x cube minus 3x square minus 12x plus 5. I think the same function I have taken with respect to the previous question. Yeah, 2x cube minus 3x square minus 12x plus 5. Now the question is different. For this particular function, we have done the local maxima, local minima analysis. Okay, local maxima at -1, local minima at x equal to 2. Now the function is asking what is the maximum and minimum values in a given interval. Okay, in a given interval. So when I only say maxima, minima in a given interval, okay, we are actually talking about, okay, maximum and minimum values of fx in a specified given interval a comma b is actually a global maxima or global minima in the specified interval a comma b. Okay, maxima or minima in a specific interval refers to global maxima, global minima at that interval. How it is? See, for the same function, we have done the basic analysis. Okay, what was the basic analysis? We are given the function f of x, that is 3x square minus 2x cube minus 3x square. We have 2 of x cube minus 3x square minus 12x plus 5. Minus 12x plus 5. Okay, I'll tell you the shortcut here, but first let's understand, and you are going to do the analysis in this of this function in the interval 0, 4, correct? In the interval 0, 4. In the interval 0, 4. Okay. Now, in the interval 0, 4, see what was the local maxima point? Local maxima point and local minima point. We have done the analysis. The same function I have copied. What is the local maxima point and what is the local minima point? Okay. So, what was the maxima point? -1 was the maxima point, 2 was the minima point. So, local maxima occurred at x equal to -1. Local minima occurred at x equal to 2. Clear? So, this -1 actually does not belong to my interval. So we can discard this point. I am only going to talk about interval 0, 4. Now that means in the interval 0, 4, there is no local maxima. So how can we find the maximum value? So that is why question is not telling local maximum value. Some maximum value in the interval 0, 4. Okay, x equal to 2 belongs to my interval. Now a rough graph will open up the complete story. We don't have to draw the graph for the question. Okay, just one time. Just one time. Okay, for that, let me just write down the values first of all. What are some of the values here? See, what is f of 0? My endpoint, my interval starts with 0. The f of 0, 0, 0, 0 and 5. Okay, then in between there is f of 2. in between f of 2, okay, and then last is f of 4. So what are these values? Actually, let me calculate and write down the values. Write down the values quickly. Okay, so what is f2? Okay, minus 3x square. Okay, minus 12x and plus 5. So this should be minus 15. And let me calculate the value of f4. Let me calculate the value of f4. That is 37. Okay, that is 37. Clear, everybody? That is 37. That is known as 37. Okay, so we have these two values. Now understand here. Okay, now further understand here. So the value at origin is 5. Okay, then the value at 2 is minus 15. Okay, the value at 2 is some value minus 15, and then the value at 4. So we have also shown that up to the value 2 it was a decreasing function. Between minus 1 to 2 it was decreasing. That is why it goes below this value. This was 5. It is going to reach some value which may be minus 15. Okay, at x equal to 2. Okay, and then it increases to some value at x equal to 4. That value I have obtained as 37. This is at x equal to 4. Here it was decreasing. You can again see our previous wavy curve. It was decreasing up to 2 and then it started increasing. Okay. So what is the maximum value in this given interval? Okay. In the interval given 0, 4. Okay, what is the max value of the function? The maximum seen is 37, and what is the minimum value? Is minus 15. Okay, the maximum value, okay, is at the end point, minimum is at the local minima point. Okay, so what are the possible, sometimes minima value will be at the end points. Anything can happen based on the function given. So what I am generalizing for you is, you don't have to draw this graph. You don't have to draw this graph. Okay, what you are supposed to do, okay, suppose you have a function fx in the interval a comma b. Okay, in the interval a comma b, and suppose x equal to x1 and x2. Okay, these are some stationary points. Okay, these are the stationary points. See, when the question is with interval, you also consider the stationary points within the interval. Only consider the stationary points within the interval. Like I have one more stationary point, that was minus 1, but that is out of, okay, that is out of the given interval. So that is, I did not write, even that did not consider in the graph, I did not write down the value also f minus 1. Clear? Okay, so suppose x1, x2 are some stationary points belonging to the interval a comma b. In the interval a comma b, what you are required to do, dear? You are required to do only this calculation. F of a, the end point, then f of x1, f of x2, the value at stationary points, but only those stationary points which are in the interval a comma b, and then fb. So that is what I have done. fa, fb, and only one stationary point was between a to b, so that value I have written. Calculate the value of the function at these points. Okay, no need to draw any graph. Okay, just look and decide. Just observe these numbers, and everybody can observe and see which is the higher number, which is the smaller number. Okay, observe and decide maxima and minima. You don't have to go for wavy curve also. What you only need is stationary points. I am not even asking you to classify the stationary point as local maxima, local minima, not at all required. That means have a look into this question. Okay, so for the previous questions I have written the answer now. Yeah, f max 37, f min minus 15. Both of the values were asked and they are done. Okay, now have a look into this next question, dear. Okay, there is a function 3x square plus 3x plus 1. What is the maximum and minimum value of y for x belonging to the interval minus 2 comma 0? Okay, so first of all, stationary point. Okay, first of all, what is required is stationary point. Okay, what is required is my stationary point. What is the stationary point? dy by dx equal to 0. That is 6x plus 3 equal to 0. Giving you x equal to minus 1 by 2. Giving you the value x equal to minus 1 by 2. Okay, that is only one stationary point. Now I am not asking you to decide whether it is a maxima, local minima. No, I am just asking you to do, okay, is it belonging to the given interval? Yes, it is between minus 2 comma 0. Okay, so I am just asking you to do this calculation. What is f of 0? F of minus 2, the first boundary point minus 2, then f of minus 1 by 2, and then f of 0. And such type of questions are commonly 2 marks question. Okay, commonly 2 marks question. So what is f minus 2? So if I put minus 2, 3 into minus 2 square, 3, 4, 12, then minus 6, 6 plus 1, 7. Okay, then 3 by 4 minus 3 by 2. So that is minus 3 by 4 plus 1. So 1 by 4 and f0, so 0, 0, 1. Okay, and what I told you at the end, observe and decide maxima and minima. So the maximum value in front of me is 7. The minimum value in front of me is 1 by 4. So 7 and 1 by 4, option number A, finish. 7 and 1 by 4, option number A. That's what you are required to do, nothing more. Yes, cell 1, correct. Again, I repeat, you don't have to classify the stationary point as local maxima, local minima. Clear? So no wavy curve, no second derivative, no first derivative test, nothing. Only stationary points required. End points are given in the problem. Okay, and the value of the function at the end points and the stationary points which are included in this interval. That's it. And for that, calculators are there. Just a calculation. You can even use calculators and just observe the numbers and decide maxima, minima. And again, I repeat, these are commonly 2 marker questions. Different values can change, but commonly 2 marker question. Okay. So let's come up here. Next, already we discussed this point of inflection case. I have done it by first and second derivative both. The cubic example. The cubic example was done. Now, if e power y is equal to x power 1 by x. If e power of y is equal to x power 1 by x, then x has what? Maximum at e, minimum at e, maximum at e inverse, minimum at e inverse. What is the correct condition? What is the correct condition for this particular function? See, first of all, e power y is x raised to the power 1 by x. So, better write down y function. Okay, there is a relation between x and y given, but better write down y as a function of x. So, to get y, take the log on both the sides. So, y can be written as ln x power 1 by x, or power will come outside 1 by x log x, and it is a non-polynomial function. Wavy curve, okay, is not for non-polynomial. Only that thing you have to remember. So, wavy curve you cannot use, but either first or second derivative, any test you can use. But wavy curve you cannot use. Okay. So, what is y? Okay. So, now I have y as a function of x is ln x divided by x. Ln x is divided by x. Okay, so let's go for the derivative first of all. What is the derivative of it? Dy by dx. Okay, stationary points will be solved by dy by dx equal to 0. Okay, the denominator square, numerator by denominator differentiation. Then denominator x constant, differentiation of log x 1 by x minus log x constant, and differentiation of x will be equal to 1. This is equal to 0. Now, this is equal to 0 means numerator, which becomes 1 minus log x, or let me write it completely. What is dy by dx, or what is f dash x, is 1 minus log x upon x square. Okay, 1 minus log x upon x square. Okay, the first stationary points will be required. Okay, the first stationary point will be required, and for stationary point, if you equate this to 0, that means 1 minus log x equal to 0. Okay, so what about the value of x? Log x is 1, so x equal to e power 1. So stationary point is e power 1, but whether that is maxima or minima, that also you have to confirm. Stationary point is e power 1, but whether that is maxima or minima. So let's do it out. Okay, let's do it out. Nana Sai Shiva, only one option correct, it is MCQ, and only one stationary point I have got. There is no E inverse coming up also. Okay, now maxima or minima. So what I will do, dear? Okay, now see. If x equal to E, understand the logic. Log of x, that means log of E is 1. Clear na? Log of E1, that is how we got the root. But if you take x less than E, okay, what happens to the log x? If x less than e, log x will be less than 1. Log x will be less than 1 because log is an increasing function. This is how a log curve is. Okay, this is how a log x curve is. Okay, so when you take x less than e, log x will be less than 1. And for x greater than e, log x will be greater than log e. That means log x greater than 1. Now, why I am writing this calculation? Because if log x is less than 1, see what happens to dy by dx. Okay, if x less than e, log x less than 1, this is less than 1, so dy by dx will be positive. Okay, and then if x is greater than e, log x also becomes greater than 1. If the second quantity is greater, so the subtraction will be negative. So dy by dx will be negative. So what is the sign change in dy by dx? Okay, because again going to second derivative rest means again some differentiation will be required, but that is not actually required. What can I do? I am able to say dy by dx changes from positive to negative. First derivative changing in positive to negative. That means increasing to decreasing. Increasing to decreasing. So that is a point of maxima. Okay, so this is the local maxima condition. Okay, so that is the local maxima. At which point? At the stationary point x equal to e. So there is a maxima at the stationary point x equal to e. There is a maxima at x equal to e. Correct? Option number A is correct. Yes, I Shiva. Option number A is correct. Now, question did not say local maxima. Here, local maxima is actually global maxima only. Why? Because, listen to now next important concept. Whenever a function has only one stationary point, okay, and that is a point of maxima, no more stationary point. So, how approximately can you try to draw the graph? See, how approximately can you try to draw this particular graph? Okay, so there is only one stationary point. Okay, that is x equal to e, and at x equal to e, we have a local maxima. Okay, so what happens around local maxima? We know function was increasing, it reaches local maxima and then it starts decreasing. But there is only one stationary point. For any other minima or maxima, there has to be another stationary point. No more stationary point means function here is decreasing, will keep on decreasing. Function here was increasing, will keep on increasing and then only it reaches maxima. There is no other stationary point where the nature will change from increasing to decreasing or decreasing to increasing. Okay, so that means this particular point, which is a local maxima, here is also the global maxima. Because if there was any other maxima, then the function would be decreasing. Maybe it decreases to some value and then increasing to another value, but not possible. Na? For this to happen, there should be one more stationary point which is not obtained. Okay, which is not obtained. So this local maxima is also the global maxima here. Sometimes factual questions are important from this area. That is why I am telling you this point. That means what can I say is, let me write down the point here. Okay. If there is only one stationary point, okay, right, and it is a point of local maxima, there is only one stationary point and suppose that is a point of local maxima, then it is also a global maxima by default. Okay, if there is only one stationary point which is a point of local maxima, then it is also global maxima, or if it is local minima, then it will be a point of global minima also. Same thing applies for minima also. Clear, everybody? Can you have two consecutive local maxima or two consecutive local minima? Can you have two consecutive local maxima or two consecutive local minima? Not possible, na? Okay, see, this is a local maxima, and if there are more stationary points, so next will definitely be local minima. Okay, then only local maxima can be obtained, because for local maxima you need increasing. So increasing you went to decreasing because you again need increasing. So in between minima has to come. So you cannot have two consecutive local maximas or two consecutive local minimas. Okay, you can have a maxima and minima. That is the pattern. Okay. So all this is important. That's why I'm writing. You cannot have two consecutive local maxima or two consecutive local minima. Right? Two consecutive local minima and two consecutive local minima. Okay. You will have only possibility is if there is a maxima, then there will be minima, then only there can be maxima, then next will be minima if there are more stationary points. That has to be the pattern. Consecutive maxima not possible, consecutive minima no. Between every two maxima there has to be a minima, and between every two minima there has to be a maxima. Okay. Next, a geometrical application problem on maxima. This is also common. So what they say now, for a right angle triangle, if the sum of the lengths of the hypotenuse and the side is kept constant, then in order to have the maximum area of the triangle, the angle between hypotenuse and side should be how much? The angle between the hypotenuse and the side should be how much? For a right angle triangle, if the sum of the lengths of the hypotenuse and the side is kept constant. So what is the condition given? Okay, what is that condition given to me? For a right angle triangle. Okay, a right angle triangle is given to me. Okay, and sum of the length of the hypotenuse and a particular side. Okay, let us say this is the side they are referring to. Let us say this is some side which is x, and let us say this is the hypotenuse they are referring to, and suppose hypotenuse is h, and the other side is suppose y. In order to have maximum area, what is the angle between the hypotenuse and the side? Okay, so this y is not important right now. What is important? There is a right angle triangle, and the sum of the lengths, okay, of the hypotenuse, that is h, and the side, that is x, is kept constant. Okay, suppose some constant, it is kept as some constant, suppose c. Now in order to have the maximum area, okay, so the question is on maxima, maximizing what? Maximizing area. Okay, what is the angle between the hypotenuse and the side? Okay, what is the angle? So this is the angle I am talking about. Angle between the hypotenuse and the side is theta. Question is, what is the theta for maximum area? For maximum area. Okay, for maximum area. Okay, for maximum area, what is the value of theta? Yes, easily, Gautam, easily. If you have good command, then definitely. With slight error, some error also done, but you will be so safe. Okay, so if less time is there, that is what you can target. Okay, so let us continue. I hope you have done it. So Ankit says the answer is D. Okay, so what is the theta for the maximum area? Let's try to figure it out. Now, first of all, what is the area? Right angle triangle. Area is half into base into the height. Okay, this is one way of writing the area. So what is the height? Okay, so this you can talk about the, if you talk about the height, the height will be equal to under root of hypotenuse square minus the side square. Okay, this can be taken as the height. Okay, so hence area, suppose A is half into base, which is x, and height is under root of h square minus x square. Okay. Now, what is the theta? Okay, for the maximum area. Okay, for the maximum area. Now, it looks like a two variable case, x and h. There are two parameters. We also have a maxima minima for two variable function that we will see separately. Okay, but this can be reduced to single variable. Why? Because x plus h is constant. Okay, since x plus h is constant, so you can replace h as c minus x, and then the area becomes half x under root of h square minus x square. H square, so h I am replacing, h is c minus x, so c minus x whole square minus x square. Simplifying it, you will be getting half x, and under root of x square will get cancelled. C square minus 2ab minus 2cx will be left. Okay, now, okay, for maxima or minima, anything, the first thing required is, okay, dA by dx. A is a function. This is like area being a function of x, and for maxima or minima, anything, first step is stationary point. So what is the dA by dx? Okay, what is the dA by dx? Let's do it first of all. So dA by dx, differentiating, product rule will come. X constant, derivative of root x is 1 by 2 root x first of all. So 1 upon 2 root over c square minus 2cx, and by chain rule, when you differentiate the inner term, it should be minus 2c plus under root of c square minus 2cx constant, derivative of x will be just 1, and this has to be equated to 0. Okay, that means this can be simplified, 1 by 2, 2 cancelled, minus xc, multiply this on the other side also, so minus x into c plus c square minus 2cx upon root over of c square minus 2cx. Okay, this should be equal to 0. So overall numerator is looking like c square minus 2 and 1. So that is 3cx equal to 0. Okay, and then the value of x can be written as c by 3. Solving it, x is c by 3. If x is c by 3, we know that what is h? H is c minus x. So 1 minus 1 by 3, that is 2 by 3x. Okay, and now what is the maximum area condition? Okay, what is the theta? Now next step is you can prove the second derivative negative. That will automatically turn out to be. Okay, but what is the cos theta? Okay, I can start with cos theta because I know the base and hypotenuse. So the cos theta is c divided by the base, base which is x divided by hypotenuse, and base x is equal to c by 3. Hypotenuse is 2c by 3. So c is not required actually. So c and 1 by 3 cancelled, 1 by 2. Okay, so if cos theta is equal to 1 by 2, what should be the theta? 60 degree. Cos 60 is half. Cos 60 is half. Okay, so 60 degrees C will be obtained. Correct, Ankit Mishra. The C option will be obtained actually. The C option is what is going to be obtained. Okay, that is 60 degree. Okay. The next option, the next question. Okay, so now let me also brief you the steps for the maxima and minima for the function of two variables. Okay, where definitely because it is a function of two variables, the partial derivatives would be required. Okay, so see, partial derivatives would be required, partial and total derivative directly, you don't get much question, but indirectly, whether you go to vector calculus or differential equations or complex area, okay, you'll be able to, get it. You'll be able to get it. Yes, you can try that, Sai Shiva. You can try that. Okay. So when I want to first, for a moment, Okay, when I want to talk about any partial or total derivative, okay, so partial derivative, okay, if I talk about partial derivative, so say if u is any function of x and y, it's a two variable function, or it can be more than two variable function also, multivariable function we talk about here, okay, then the partial derivative del u by del x, okay, that is the partial derivative with x keeping y constant. What is the simple thing you have to remember? Okay, partial del u by del x is the partial derivative with x keeping y constant. That means you have to follow the same differentiation formula and treat y as a constant, and you know how to deal with the constant in the differentiation process. Okay, so this is the first principle written, but you again don't need the first principle. See, what does this first principle say? Okay, if the initial value of the function is fxy, I change it to f of x plus h comma y. So very clearly you see y is unchanged. But when x changes to x plus h, what is the change in function divided by change in x? When the change in x is taken to be small, that is limit x tending to 0. Same first principle which I told you in the dy by dx also. Okay, this is del u by del x, also represented as ux, also represented as letter p. Okay, del u by del y, okay, the rate of change of u, the derivative of u with respect to y partially, that means keeping x constant. Okay, and if you keep x constant, see x is same here, y changes to y plus k. Okay, the change in y is k, and the limit k should be 0 because change in y to be taken as small. We call it as uy, or in also common notations we call it as by the letter q. Okay, then there can be second derivatives. Okay, then what are the second order partial derivatives? Let us actually go to an example here. Okay, suppose there is a function x cube plus y cube minus 3xy. What are the first and second order partial derivatives? Okay, what are the first and second order partial derivatives? What are the first and second order partial derivatives? Suppose u is equal to x cube plus y cube minus 3xy. So what are the first order partial derivatives? Okay, the first order derivatives, del u by del x, del u by del x, okay, del u by del x. So derivative with x keeping y constant. So what I'm telling you, you know how to treat a constant in differentiation. So what is x cube derivative? Same formula, 3x square, nothing changes, but y cube will be constant to derivative 0. Then 3xy, so 3y is constant, like kx, 3y is constant and x derivative is 1. Okay, then next, del u by del y. So since it's a function of two variables, so two first derivatives are used here. Two first derivatives have been used here, del u by del y. What is the del u by del y? Okay, so x will be constant now, so x cube derivation 0, y cube derivative 3y square, then x constant to 3x constant, y derivative will be 1. So that constant 3x left and y derivative 1. Clear everybody? Okay. Now, these are the first order derivatives. Then we go to the second order derivatives. Second order derivative means what? Derivative of first derivative. Wait, what are second order derivatives? Derivatives of derivatives. Derivatives of derivatives. So since the del u by del x is again a two variable case. Okay, so again you have two more partial derivatives. Okay, you have again two more partial derivatives. One will be del by del x and one will be del by del y of this function. Clear? Okay, what is del by del x of del u by del x? Del by del x of del u by del x is commonly represented as what? Del 2u. Del by del x of del u by del x. So this is del 2u upon del x square. Del x into del x, so del x square. And how much is this equal to? Calculate the value, no? Again you differentiate with x, so y constant now, so 3x square derivative 6x, that's it. Now next, del by del y of what? Of del u by del x. Okay, the del by del y of del u by del x, so that becomes del 2u upon del y del x. Upon del y del x. Okay, so partial derivative with y when you do, it is minus 3. X is constant now. Clear? Done. Now again we have del u by del y, which is a two variable function. So again two more derivatives can be written. Okay, one is with respect to x, del by del x, and one with respect to y, del by del y. Okay, what is del by del x of? What is the function on the left? Del u by del y. So del by del x of del u by del y. See how the representation. Del 2u upon del x del y. Upon x del x del y. So differentiate with respect to x. Y is constant, minus 3x derivative minus 3. Del by del y of del u by del y. Del by del y of del u by del y. Okay, so what is del u by del y? When you differentiate with y, okay, first representation, sorry. Del by del y of del u by del y. So del 2u
upon del y is del y square. Del 2u by del y square, and this will be equal to how much? Okay, derivative with y, 6y. Derivative with y, 6y, that's it. Okay, x will be constant this time. Okay, you might have observed by this time that these two are same. They will always be same. What is always same? Okay, what is always same? Okay, the derivative, see, what is this derivative? Del 2u by del y del x. First derivative with x and then with y. This is del 2u by del x del y. First derivative with y, then with x. So it is the double derivative, once with x, once with y. Whether first x or first y, that will never matter. Answer will be the same. So always del 2u by del x del y or del 2u by del y del x. Del 2u by del y del x will be the same. Okay, del 2u by del x del y or del 2u by del y del x, it is always and always going to be the same. Clear? It is always and ever going to be same. Okay, it is always and ever going to be the same. Del 2u by del x del y equal to del 2u by del y del x. Perfect. Perfect. Okay, now next. Okay, let's move ahead. Okay, so that means if I talk about second derivatives, there are three second derivatives: double derivative with x, twice with x, twice with y, and once with x, once with y, where the order with x or y will not matter. Okay, so we count three second order derivatives. Okay, then similarly we have the total derivatives. Okay, we have the total derivative. This is about the partial derivatives. Okay, this is about the partial derivatives, and let's come to the total derivatives. Okay, the total derivative, suppose u is a function of x and y, the total derivative of it, du, okay, is represented by as du or df, anything is represented as del u by del x into dx plus del u by del y into dy. It is more or less a chain rule application, which I am not deriving right now and not required also. You just have to note down that du, and if it is a function of three variable, it will become del f by del x into dx plus del f by del y into dy plus del f by del z into the dz. Okay. So du is equal to del u by del x into dx plus del u by del y into dy. Okay. Chain rule and product rule can also complete it. So that is why, see, directly question point of view, it may not be important. Why? Direct question point of view, it may not be important. If I just have to tell you, see, now, you know, since I have du expression, you can differentiate with any variable. Suppose u depends on x and y, and further x and y are a function of time. Okay, are a function of time. Then du by dt, what can be done here? Du by dt will become del u by del x into dx by dt. This is del only. Del u by del x into dx by dt. The same. One expression, you know, enough. If you want du by dt, so here dx by dt and dy by dt will come. Okay. So, suppose if I give you an example, understand here. Okay. Suppose if I write down an example here. Okay, suppose u is some function, okay, e raised to the power x square into sine of 2y. Suppose something like this, e power x square sine of 2y. Okay, e power x square sine of 2y. Okay, where x is further dependent on t as x equal to, you know, t square, and y is given by something like 2t cube. Okay. Question is find du by dt. Find du by dt. Okay. So you can solve it two ways. Okay. You can solve it two ways. So what is du by dt if you apply the total derivative concept? Total derivative concept. Du by dt. What will be du by dt? As I told you, the formula is del u by del x first into dx by dt. Okay, partial derivative with x and then by chain rule dx by dt, then partial derivative only with y and by the chain rule dy by dt. Okay, so now what is del u by del x? When you are differentiating with x, any term of y will be constant. E power x square derivative will be e power x square into 2x. Okay, and then sine 2y constant. Sine 2y as it is. Sine 2y as it is. And dx by dt. What is dx by dt? 2t. Dx by dt will be 2t, correct? Plus, this is one part. Okay, the next part, del u by del y, partial derivative with y, so e power x square as it is into sine 2y derivative 2 cos 2y into dy by dt. So 2t cube derivative 2 into 3 6 t square. Okay, or what is the value of du by dt? What is the du by dt at some value t equal to 1? Suppose let me give you any value t equal to 1. Okay, at any value t equal to 1. So if I give you a value t equal to 1, then what is the result? Okay, so dear, if t equal to 1, at t equal to 1, what will be x? X will be 1, but y will be 2. Okay. Okay, so if you have to put down the result at t equal to 1, the answer will be e power x square, x is 1, so e power 1 into 2x, that is 1, into sine of 2y, y equal to 2, so sine of 4, into 2t, t is further 1, and plus of again e power x square, x is 1, so x square is 1, into 2 cos of 2y, y is 2, the cos of 4, into 6t square, t is 1. Right? So see how the total answer will be. Okay, what can be taken constant? 2 2s are 4. Okay, and here also 4 can be taken outside. 4e I take outside. Okay, then my answer is sine 4, and then 2 2 4 outside, 3 cos 4. Correct. We have got some answer. Okay, we have got some answer. Now, other way of doing it. What is the other way? This is the total derivative concept. Okay, what you can do is alternate, immediately substitute 2t inside the function. U is equal to e power x square. If x is t square, x square becomes t power 4. Correct. Into sine of 2y. Okay, so 2y becomes 4t cube. Okay, and then you can do it directly also. Okay, now what is du by dt? So I'm telling you, product rule and chain rule again. Okay, so e power t power 4 derivative. Okay, that will become 4 e power t power 4. Sorry, t power 4 derivative 4t cube e raised to the power t power 4 into further 4 sine into sine of 4t cube. This was constant. And then next time e power t power 4 constant, and then the derivative of sine will be cos of 4t cube, and by the chain rule 4 3s are 12, t square outside. Again, if you want to put t equal to 1, okay, so see what will be du by dt, put t equal to 1, 4 into 1 into e power 1 into sine of 4 plus e power 1 into 12. Okay, 12 t square 1 cos of 4. Again, you will take 4e, that can be common. What is left is sine 4. 4 was common, so 3 cos 4. Same answer. It has to be same only. Okay, it has to be same only. Clear? So that is why, total derivative, you can take it directly, or you can individually solve the function by substituting x and y as a function of t. What is more important is this expressions, okay, are more important and required once you go to, vector functions, complex functions, exact differential equation, all these places, these are more important actually. Okay, so these are what? These expressions, this concept of total derivative. Okay, this is important once you talk about vector calculus. The concept of gradient has some connection to do with this. It is important in, complex functions. Okay, in some types of questions based on Cauchy-Riemann equations. Okay, this is again important in exact differential equations, etc. There are some indirect places that you must know. Directly, it's a differentiation approach, whether you want to do it by total derivative or whether you want to do it by converting into a single variable function. Okay. Now, the next point is, okay, yeah, we were into the maxima minima, slightly some basic partial derivative introduction I have given, partial and total. Let me first complete the maxima minima before I come back here. Yeah, so maxima minima for the function of two variables, again not that important, but maxima minima that we were looking earlier for function of single variable, that is very heavily important. Okay, so maxima minima for two variables. Suppose z is a function of two variables x and y. Okay, z is a function of two variables. Okay, so what we first solve is del z by del x, or anything you can call del u by del x. Okay, so first derivative equal to 0, theme is the same. Okay, First derivative del z by del x 0, del z by del y 0, and solve for x and y, and these x and y will be known as their stationary points. These will be known as stationary points. As I told you, we call the first derivatives also as p and q. Okay, let this be p equal to 0, let this be q equal to 0. Okay, solve for stationary point and then substitute the stationary points in the second derivative. Okay, then find the value of RST at the stationary points. Okay, what is R? The double derivative with x. As I told you, three double derivatives are there. Double derivative with x, double derivative with y, and double derivative once with x and y. Del 2z by del x del y or del y del x, both are same. Okay, that also I told you. Okay, so let double derivative with x is R, double derivative with x and y is s, and double derivative both with y is equal to t. Okay, after calculating RST, you will do the calculation RT minus S square. We'll better go for a question to understand this. Okay, check RT minus S square, and by chance if RT minus S square itself is negative, then that point, okay, is neither maxima nor minima, also referred to as a saddle point. Just like point of inflection for the single variable case. Okay, the function at the point which has neither maxima nor minima will be known as a saddle point. Now, if RT minus S square positive, then you check the value of R. If R is negative, that is a maxima point. If R is positive, then that is a minima point. Okay. Okay, so I'm not deriving any of this, but yeah, let's better work out on the problem actually. Okay. So what is the problem? Given the function 4x square plus 6y square minus 8x minus 4y plus 6, what is the optimal value of f of x comma y? What is the optimal? Now, optimal means minima or maxima. Optimum is a generic word. You specify maxima or minima. So it could be maxima, minima, anything that you have to figure out whether it is a maxima or minima and what is that corresponding maximum or minimum value. Okay, so it's a two variable function clearly. Okay, what is the first thing you have to do? Stationary points. Okay, so what is the first? We need the function is f. So del f by del x equal to 0, and then we need q equal to del f by del y equal to 0. Okay, what is derivative with x? So 4x square derivative 8x, then 0, and then 8. Y is constant, the partial derivative with x. So 8x minus 8. Okay, this directly tells x equal to 1. Del f by del y, derivative with y, so 12y, x was constant, and then directly minus 4 equal to 0. So what is the value of y? 4 by 12 or 1 by 3. The value of y is 4 by 12 or 1 by 3. The value of y is 4 by 12 or 1 by 3, correct? Okay. So that is the x and y. So what is my stationary point? I have only one stationary point as of now. Sometimes there can be more also. Okay, so what is one and only stationary point here? The one and only stationary point is 1 comma 1 by 3. Okay, now I will go to the second derivative calculations. What is my step number 2? The second derivative calculation, that is RST. R is double derivative with x. Okay, so what is the double derivative with x? See, this is the first derivative, 8x minus 8. Again differentiate with x, only 8. Okay, then s, del 2f by del x del y. Double derivative once with x, once with y. Once with x is done, and now you differentiate this with y. There is no y term. That means purely constant with y, and the derivative with y will now further be 0. And t was known as the double derivative with y, del 2f by del y square. Del 2f by del y square. What is the double derivative with y? So this is the first derivative with y. Again you differentiate 12y with y, answer will be 12. Okay, and then what I need is the RT minus S square. What is RT minus S square? 8 into 12 and minus 0, that is 96, which is positive. If RT minus S square is positive, then only we have the hope of maxima minima. If RT minus S square negative, then that is a saddle point, neither maxima nor minima. So here RT minus S square positive. So now we check R. What is R? R is equal to 8, which is positive. So positive means local minima condition. Okay, local minima. Okay, so this stationary point is a point of local minima. If they ask point of local minima, what can I say? My point 1 comma 1 by 3 is a point of local minima. Okay, and then what is the minimum value of the function? What is the minimum? They are asking the minimum value. So it's going to be minima. Okay, but what is the value? So let's substitute. F is 4x square plus 8y square. Okay, 4x square. Keep putting the value of this x and y. Okay, 4x square plus how much? 6y square. 6 into y square. Then minus 8x minus 4y. Minus 8x minus 4y. And lastly plus 8, I think. Right. Okay, so this is 4 and 6 by 9. That can be written as 2 by 3 minus 8 minus 4 by 3 and plus 8. Minus 8 plus 8 cancelled. So net answer 4 and then minus 2 by 3. So that is 12 minus 2, 10 by 3. Okay, so the function value at the points is minima, and that is 10 by 3. That is 10 by 3. It is a minimum and that is 10 by 3. Clear? It is a minimum and equal to the 10 by 3. It is actually a minimum and that is equal to what? That is equal to the 10 by 3. Okay. Minimum and equal to 10 by 3. Option number A, very correct. It is a minimum and minimum equal to 10 by 3. Okay, next question. Okay, next question. Okay, and then I briefed you about partial derivative, the basic calculations and the total derivative. Okay, which is again more important, as I told you, in vector calculus, complex functions, whenever we talk about functions of 2 or more variables. Okay, now I have a small homework for you, dear. Okay, I don't think homogeneous functions and Euler theorem are very important, but still, since it is there in my PDF, you just go through it. Just go through it. I'm not discussing it right now. Let us go to the more important areas. Okay, so one homework I'm giving. Okay, the homogeneous functions. Okay, and Euler's theorem. Because again, we don't directly see any question in the PYQ. Hardly any questions in PYQ. Okay, so you have to go through it. Just have to go through it. Okay, it's included in the PDF. So when I share the PDF in the Telegram, when I share the PDF in the Telegram, these slides will be there. This homogeneous function, then what is the Euler's theorem? Okay. What is that Euler's theorem? What are the two results of Euler's theorem? Okay, just 1 or 2 questions you try out of it. Okay, so that is what will be included in the PDF also. Okay. So what I will do is, before I forget, dear, I will share you the Telegram link where you are going to find the PDF. Okay, the PDF link will be available here. The PDF will be available in this Telegram group. Okay, so if you are not connected with this Telegram, you can be connected now, or else if you are connected, better, fine, no problem. Okay. Okay, so what I will do is, so link of Telegram is there. What I will do is, once, right now only, so this is the homework that I have given to you. Hope you can read it and hope you can manage it. Okay, let me know your comments also. So what I will do is, now it is the time to once say the password. I'll tell one more time also, no problem. Okay, but yeah, at least I will once say the password right now. The password will be Maxima. The password, just now we were doing some important Maxima Minima discussion. The password of the PDF will be in the Telegram group that I have shared to you, and the password is going to be Maxima, M-I-M-A-X-I-M-A. Everything in small, M-A-X-I-M-A, Maxima, but everything in small letters. Clear, everybody? Everything in the small letters. Okay, and Euler's theorem, you just go through. It is included in the PDF. It is included in the PDF. And before I take the next topic, again, an important reminder. Okay, before I am taking the next topic, the reminder is that yes, okay, coming 8th February, the big announcement is the first online live batch for GATE 2026 and 2027. For GATE 26 and 27, the first online course starts from 8th February. The fee for 1 year, that is GATE 26, is currently 19,999, and for 2 years it is 28,999. And also there is a 25% early bird discount for students who register before 30th of January. Okay, that is 30th of this month. Okay, so you can, just have to use the coupon code OMGATE26, and you can pass this information to any of your friends or juniors who are looking for the GATE 26 or 27 live courses by the OM Institute. The first batch is from 8th of February. The first batch is from the 8th of February. Okay, dear, fine. Let's move ahead to the next. Area. Okay, now coming to integral calculus, dear, the important areas within the integral calculus. See, you don't directly expect indefinite integral, but again, for the sake of completion of your notes, what I have done is all important indefinite integral formula, because otherwise I know students will discard it. So that is why I've got it at, as this notes for you within the PDF. All important indefinite integral formula which you must know, not only for maths I'm telling, which are useful, okay, for GATE or ESE, which are useful for engineering, I would say. Okay, directly you don't get any indefinite, what is the integration of this function? Never they are going to ask you this way. Even directly, definite integral questions are also rare, but you should know the formulas of indefinite integrals and properties of definite integral, and then I'll show you what is expected, what type of models you get from here. Okay, so what are the most commonly used indefinite integral formula? I've got it ready for you. Okay, normally, students, they don't put the effort. If they've forgotten, they discard the formula. Okay, so that is why you should not miss out that integral x power n, very basic, x power n plus 1 upon n plus 1. Integral cos x is sin x. Integral of sin will be minus cos. Okay, integral e power x is e power x. Integral a power x is a power x upon log a. Integral 1 upon x is log x, or to be more specific, log of modulus x. Integral tan x is log of sec x. Integral cot x is log of sin x. Integral sec is log of sec x plus tan x. Integral cosec is log of cosec minus cot. Okay, integral sec square theta is tan theta. Integral of cosec square theta is minus cot theta. Okay, integral sec into tan is sec x. Integral cosec into cot is minus of cosec x. Integral 1 upon x square plus a square, 1 upon a tan inverse x by a. Integral 1 upon root a square minus x square is for sin inverse x by a. Integral 1 upon x root x square minus 1 is for sec inverse of x. So some inverse trigonometric cases also we have put up here. Okay, and then integration by parts. Okay, so that is only the list I have gone through, and then integration by parts and definite integral property. Integration by parts. Okay, integral for f into g. Or in a better way, let me put it this way. If you are trying to solve integral of f1 into f2, product of two functions, let me write it as f1, f2. Okay, let me write it as f1, f2. This is equal to first function constant into integral of second, integral f2 dx, minus integral of derivative of first function, okay, multiplied by integral of the second function, and then whole integral. D by dx of f1, derivative of first into the integral of second, and then whole integral. Okay, but if it is a differentiation of product of two functions like UV rule, you can take any function as first and any as second, nothing matters there. But in integration, if you don't properly decide the first function, you will be in an endless loop. You will not be able to successfully complete the problem. So to decide the first function, what is the priority we use is these letters I late. You are all knowing about this, I hope. I late. Okay, where this is the priority, decreasing priority for first function. Okay, decreasing priority for first function. Okay, so I for inverse means inverse trigonometric, L is for logarithm function, A is for algebraic function like x square, the polynomial case, T is for trigonometric function, and E is for exponential function. Okay, that means suppose if there is a question, suppose if there is a case we are solving, x square into log x dx, what should be first and what should be second? Okay, what should be first, what should be second? What should be the first, what should be the second? Okay, what should be the first, what should be the second? So x square is what type of function? Algebraic. And this is logarithm, and my rule is I late. What comes first? I late, L comes first. So this should be first and this should be the second function. Clear? This should be the first and this should be the second function. Clear? Okay, so that is how you have to take. Okay, and then rest is integration process. Clear, everybody? So what is first and what is second function? You have to take care carefully. You have to take care carefully. Now, before I bring up, a few questions, okay, properties of definite integrals, and which of them are more important, I will specify them. Again, directly questions on definite integrals are also very rare. Indefinite too, you don't get question. Definite integral property question are also very rare, but these properties indirectly very useful. Okay, direct questions you don't get. If you talk about direct question, more about multiple integrals, double, triple integrals, okay, or area or volume question. That is actually more important. That is something that you can focus. Okay, that is something that you can focus. Clear? Okay, so properties of definite integral. The name of the variable inside the definite integral doesn't matter, whether it is integral fx dx or ft dt. Okay, as long as the limits and the function is same, the name whether x or t, that doesn't matter. Integral a to b fx dx is equal to negative of integral b to a fx dx. That means if you change the limits of integral, a minus sign will be introduced. If c is any point between a to b, then integral a to b fx dx, integral of a to b fx dx can be broken as integral a to c fx dx plus c to b fx dx. For what type of cases we need to break the limits, we'll talk about. Integral a to b fx dx is integral a to b f a plus b minus x dx. Integral 0 to a specific case of this, integral 0 to a fx dx is integral 0 to a f a minus x dx. Okay, so coming to the more important result now. Coming to the more important result here. Okay, so this one actually very important, not for direct question, but indirectly for many subjects you will be using this property. That is integral of even or odd functions. Okay, integral of even or odd functions. Integral minus a to a fx dx, okay, will be always 0 if fx is an odd function. If fx is an odd function, meaning f minus x equal to minus fx. This is what is an odd function. Integral minus a to a will become twice integral 0 to a. It will become twice integral 0 to a if fx is an even function. If fx is an even function. Okay, that means when f minus x is equal to fx. Okay, so integral minus a to a fx dx will be twice integral 0 to a fx dx. Twice integral 0 to a fx dx, correct? Then integral 0 to 2a fx dx, okay, will be twice integral 0 to a. Here the limit 0 to 2a can be written as twice 0 to a if f of 2a minus x equal to fx. Okay, and it will be 0 if f2a minus x is minus of fx. One more property on f2a minus x being equal to fx. If f2a minus x equal to fx, then integral x fx dx, which normally we think integration by parts, but if f2a minus x equal to fx, integral of x fx 0 to 2a will be a, okay, a outside integral 0 to 2a fx dx. Integral 0 to 2a, and then this can be further broken. This can be further equal to, okay, now already I am telling f2a minus x equal to fx. So integral 0 to 2a fx can also be written this way. So 2 can be written outside, 2a integral 0 to a fx dx. Okay, so if I take some specific example, forget, we'll come to it later. Suppose if I have to write down a question, suppose integral minus pi to pi, integral minus pi to pi sine cube x dx. You can directly say the answer. Minus pi to pi sine cube x dx. So whether it is an even function or odd function, okay, f minus x, okay, will be minus fx here. Okay, because sine of minus x whole cube, sine minus theta is first of all minus sine theta, and minus sine x whole cube, minus 1 cube is minus only. So is minus sine x cube, that is minus fx, correct? F of minus x, I am solving and getting minus fx. Okay, so under that case, integral minus a to a, any limit minus a to a, but it should be minus a to a, symmetric limit. Integral minus a to a fx dx should be necessarily 0, 100% 0. Don't integrate this, please. Don't integrate this. Okay, if it is given as, say for example, if it was given as integral 0 to pi, integral 0 to pi, okay, or first let me take it this way. If it is integral minus pi by 2 to pi by 2 cos square x dx, you can solve directly also, cos square x dx. Okay, how much will be the answer? Now see, cos square x, whether it will be even or odd, cos minus theta is cos theta. Okay, so even if you take square, it will be same. So this is even function category. So because it is even function, I can write down twice integral 0 to pi by 2. Okay, twice integral 0 to pi by 2 cos square x dx. Now this can be solved by a direct technique. I will tell you in some time. Okay, I'll tell you in some time. Very, very important direct technique, Wallis integral. Okay, this can be solved by Wallis integral, or right now if I have to solve, I can write it as twice cos square theta is 1 plus cos 2 theta divided by 2. Cos square theta can be written as 1 plus cos 2 theta divided by 2, limit 0 to pi by 2. Okay, so 2 and 2 got cancelled. Integral of 1 will be x and integral of cos 2x will be sin 2x but divided by 2. Okay, sin 2x divided by the coefficient of x, which is 2. Okay, limit 0 to pi by 2. Okay, so now see, upper limit pi by 2 plus sin pi. X is pi by 2, sin pi is 0. Lower limit x also 0, sin 0 also 0. The lower limit is 0. Final answer is pi by 2 only. For the question, the final answer is pi by 2 only. Clear? The final answer for the question is pi by 2. Okay. If I asked you the question, say, integral 0 to pi sin square x dx. Integral 0 to pi sin square x dx. Integral 0 to pi sin square x dx. But now once again sin square x. Okay, what is f minus x? Sin minus x whole square. Although sin minus theta is minus sin theta, but because overall square is there, na? If it is only sin x, odd function, but overall square is there, so minus 1 square will be 1 only and you get sin x, sin square x only, which is fx. F minus x is again fx, that means even function. That means even function. Okay, but do I need to check even and odd here? No. You don't have to check even and odd here. Why? Because the limits are not minus a to a. The limits you have to see. The limits, whenever it is 0 to pi, you can assume 0 to 2a. Okay, you can assume it as 0 to 2a. So what property here you have to think? What property here you have to think? So let's say this is some value 2a. Okay, so what is f of 2a minus x? F of 2a minus x means f of pi minus x. Okay, f of pi minus x means sin pi minus x, and that is sin square x. So sin pi minus x whole square. But sin 180 minus theta is sin theta. Sin 180 minus theta is sin theta. So the answer is sin x only. So sin x whole square or sin square x. That means fx. So dear, f2a minus x equal to fx. And whenever f2a minus x equal to fx, we can write down the integral 0 to 2a as twice integral 0 to a. Twice integral 0 to a. What will be a? Pi by 2. If 2a is pi, a will be pi by 2. Twice integral 0 to pi by 2 sin square x dx. Okay, so twice, again sin square theta, 1 minus cos 2 theta divided by 2, or again by the Wallis formula. Wallis formula I will discuss in some time. Okay, Wallis formula I will discuss in some time. Okay, 2 again cancelled, x one integral is x, and cos 2x integral sin 2x by 2, limit 0 to pi by 2. Same answer you will get, put down the limit pi by 2 and again sin pi 0. Okay, and lower limit both 0, 0. The answer will be pi by 2 only. I'll tell you, na, never stop learning. What is Wallis integral? I'll tell you in some time. We'll discuss that in some time. Okay, direct and very efficient technique of integrating, okay, sin power n, cos power n under the limit 0 to pi by 2, or a multiplication of sin and cos also. Okay. So, have a look into this next question. These were some basic demonstration of the property. Now, integral 0 to pi x sin x. Just now I explained f2a minus x. Assume this as 0 to 2a x into fx dx. Property number 8. Assume this as integral 0 to 2a x fx dx. Okay. What is fx function is sin x. And what is f2a minus x? F2a minus x. That means f of pi minus x. 2a here is pi. F pi minus x. Same, sine 180 minus theta. Sine 180 minus theta is sine theta. Okay. So dear, because again you have f of 2a minus x equal to fx. That means if you apply property number 8, integral x fx dx, integral 0 to 2a, as I told you, is a integral 0 to 2a fx dx. And further on to it, apply the property 7 also, that will become 2a. Okay, that will become 2a, or let me leave it like this because I have solved the earlier part now. Okay, I have solved the earlier part. So this is equal to how much a? What is the value of a? 2a is pi. So a means pi by 2. Integral 0 to 2a, integral 0 to pi sin x dx. Sin x dx. So now if you want, you can use property 7, or basic sin x integral is cos x minus cos x. It's a basic sin x integral minus cos x, and so minus pi by 2, upper limit cos pi minus 1, cos 0 is also 1. So minus 2 minus minus cancel. The final answer for the question will be pi. Otherwise, you have to solve it integration by parts. That will be little bit more time taking as compared to this one. Okay. Not very time consuming, but slightly more. Okay, so the alternate also I'll tell you that you will solve separately. Alternate is integration by parts. But just tell me, if you're solving integration by parts, what should be the first function and what should be the second function? Okay, this is algebraic and this is trigonometric, and in I late, a comes before t. So first function will be x and second function will be sine. Clear? A comes first. So first has to be the x function, second function has to be the sin x function. You can solve integration by parts also. Same answer, final value pi should be coming out. Okay dear, the same answer, that is the final value pi, should be coming out for sure. Okay. Next question. Okay. Integral 0 to 2 x minus 1 whole square sine of x minus 1 upon x minus 1 whole square plus cos of x minus 1. Looks like some random complicated function. Huh? Looks like some random complicated function. But. Yeah, of course it is some random complicated function. But the important point to be noted is every term is a function of x minus 1. There is no x or any other term, only x minus 1 is combined. So that gives me a hint of substitution. Some questions are always made easy by substitution. What is a substitution? Put x minus 1 equal to t. And if x minus 1 is t, dx will be dt. Okay. And then if x equal to 0, limits also will change. If x equal to 0, t will be minus 1, and upper limit if x equal to 2, t will be equal to plus 1. Okay. So how your integral will now look like? Integral x equal to 0 to 2, so t equal to minus 1 to 1. Okay, x minus 1 is t, so t square sine t upon t square plus cos t dt. T square sine t upon t square plus cos t dx is same as dt. And again I repeat, whenever any integral reads as minus a to a, for any value of a, whenever you are able to read the integral minus a to a, 100% think about even or odd property. The first thing you should think is even and odd property. Okay, so what is the ft here? What is the function inside the integral? T square sine t upon t square plus cos t. So if you try f minus t, see, minus t square sine minus t square cos minus t. Denominator you see minus t square is same as t square. Cos minus theta is same as cos theta. Minus t square is again t square. Numerator only sine minus theta will bring one minus. Only a sine minus theta will bring minus sine theta. That means f minus t is having 1 minus and then only ft. That is an odd function property. So integral minus 1 to 1 or any limit minus a to a. Integral minus a to a ft dt, question finished, is 0. Answer for the question is 0. Clear everybody? The answer for the question is 0. 100% 0. The answer for the question is 0. Okay, yes Chandu, yes I Shiva, correct, that is 0. Next question. Again think about substitution. I'm telling you sometimes substitutions are the things that is going to save you. That is going to help you and make you solve questions easily. Integral 1 upon pi to 2 upon pi cos of 1 upon x divided by x square. Integral 1 upon pi to 2 upon pi cos of 1 upon cos of 1 by x divided by x square. One upon pi to 2 upon pi cos of 1 by x divided by x square. One upon pi to 2 upon pi cos of 1 by x divided by x square. So what substitution? Let's see into it. Okay, so the simple substitution here is 1 upon x equal to t. Why? Because if 1 upon x is substituted, then already we know derivative of 1 upon x contains 1 upon x square. So this also will be substituted and then the analysis will become simple. Okay, so put 1 by x equal to t. And now when you differentiate, okay, so derivative of 1 by x minus 1 by x square dx will be dt. Okay, and limits also 1 upon x is t, that means reciprocal of x. So t also will become reciprocal. And now the integral should look like integral 1 upon pi will become pi, 2 upon pi will become pi by 2. Cos of 1 by x becomes t, and dx upon x square will be minus dt. Dx upon x square minus dt. You can use the minus to exchange the limits. Okay, you can use this minus to exchange the limits. Okay, so we can call it as integral increasing limit. Now pi by 2 to pi, I exchange the limit, so minus anyways will be now removed. Cos t dt, a simple cosine integral which is sine. Cos t integral is sine t, lower limit pi by 2, upper limit pi. Okay, so sine pi 0 and sine pi by 2 1, final answer minus 1 only. Simple. The final answer is minus 1. Correct, it is. The final answer is minus 1. Next question. What is the value of the following definite integral rounding off to 3 decimal places? Okay, so definite integral only, but integral x into log x. X into log x, where x is your algebraic function, L is your logarithmic function. So as per the Euler procedure, what comes first? Okay, L comes first, L comes before A, so you have to take the logarithm as the first function. So this has to be solved this way, integral 1 to E, okay, log x to be taken first function into x dx. Log x into x dx, integration by parts. Okay, it is a question of product of two function x into log x, so integration by parts I am applying here. Integration by parts, okay. So let's do it, integration by parts. What do we do in integration by parts? Okay, now this is first and this is second. The first function log x constant into integral of second function, integral of x, x square by 2, minus integral of differentiation of the first function, differentiation of log x 1 by x, integral of x, x square by 2 dx. Okay, so this is equal to x square log x by 2. Okay, minus x cancel, x integral again x square by 2, so 2 2s are 4. So x square log x by 2 minus x power 4 by 4, limits 1 to e. Only thing is you have to put down the limits. Okay, so if I put down the limits, upper limit e square log e will be 1, so e square into 1 by 2 minus e square by 4. Lower limit 1 into log 0, log 1 will be 0 and then minus 1 by 4. Okay, so total e square by 2 minus e square by 4. 1 by 2 minus 1 by 4 will be 1 by 2. Will be 1 by 4, sorry. 1 by 4, this also minus plus 1 by 4. So total e square plus 1 whole divide by 4. Approximately, because it is an NAT question. The final answer, e square minus plus 1, okay. E square plus 1, approximately 2.097, 3 decimal place. 2.097 is the answer. 2.097. .097. Okay, this is the value of the following definite integral. Okay, done. Next question. See the next question. Integral minus 1 to 2 modulus of x cube minus x dx. Now, modulus functions, okay, we change the definition at the argument equal to 0. We know that we have to break the definition. Okay, so how do we understood mod x function? Same way, let me write down modulus of x cube minus x first of all, so that you understand how do you deal with this question. Modulus of x cube minus x, keep understanding. What is modulus of x cube minus x? Okay, if x cube minus x is already positive, if x cube minus x is already positive, then you will write the answer as x cube minus x only. Na? What I told you, mod x, if x is positive, you write x. If x is negative, you write minus x. Correct, na? Okay, so if x cube minus x is negative, then the answer should be minus of x cube minus x. Minus of x cube minus x. Now my question is, when is the x cube minus x positive or negative? That makes it a polynomial inequality. X cube minus x greater than 0, x cube minus x less than 0. So what are the roots? If you take x cube minus x equal to 0, taking x common, x into x square minus 1 equal to 0. So the roots are x equal to 0 and plus minus 1. These are the roots. Okay, and for these roots, let me draw the wavy curve. Okay, because polynomial inequality, na, polynomial function greater than less than 0, and for polynomial inequality, wavy curve can be used. On the wavy curve, first I write down the roots in increasing order, minus 1, 0 and plus 1. Okay, wavy curve will start from the right of largest root with the plus sign, then change the sign, again change the sign, again change the sign, plus, minus, okay. So that means my function fx, now see here. Now, my function fx, which is modulus of x cube minus x, is equal to, okay, x cube minus x, where is it positive? Okay, the function will be x cube minus x, okay, for what value of x? When is x cube minus x positive? Okay, for x between -1 to 0, for x between -1 to 0, or x greater than 1. Okay, and it will be taken as minus of this, minus of x cube minus x, minus of x cube minus x when x is less than -1, when x is less than -1, or x is between 0 to 1. Clear? Now this is the complete definition of the function. This is the complete definition of the function where I have used the wavy curve method again. Okay, where I have used the wavy curve method again. I have drawn the wavy curve for which function? For the x cube minus x function, to know where is it positive, where is it negative. Clear? Okay, now my question is, let me now continue with the question. My question is integral. My question is integral -1 to 2 modulus of x cube minus x dx. Okay, but where do you have to break the limit? -1, see, it is directly given -1 to 2, but -1 to 0 something else. -1 to 0 something else. -1 to 0 something else. Then 0 to what? Next is 0 to 1 and then 1 to 2. Okay, the limit that is given to you is -1 to 2. So next you have to break 0 to 1. So this is what? Property number third I told you. Breaking the limits is required when the definition of function is changing. And the last part will be 1 to 2. Now, between -1 to 0, positive. Okay, positive means take x cube minus x. The integral x cube minus x to be taken. Next, 0 to 1. 0 to 1, okay, the sign is negative. Okay, 0 to 1 sign negative. So what is the fx? Minus of x cube minus x. Minus of x cube minus x dx. And last again same becomes positive. So x cube minus of x dx. Okay, fine. Now just basic integration is left. Now just basic integration is left. X cube integral x power 4 by 4, x integral x square by 2. Then I will put down the limit. Next, let me write the minus outside. X cube integral is same, x power 4 by 4 minus x integral x square by 2, 0 to 1. Last, x cube integral x power 4 by 4 minus x integral is x square by 2, limit 1 to 2. Limit is 1 to 2. Clear? So this is equal to 0 minus 0. Okay, then 1 by 4 minus 1 by 2. 1 by 4 minus 1 by 2. Minus, okay, 1 by 4 minus 1 by 2 minus again 0 minus 0, lower limit, and last 2 power 4, 16, 16 by 4, 4 minus 4 by 2 is 2, and then 1 by 4 minus 1 by 2. So let us see the final answer. Minus minus plus 1 by 4, minus 1 by 4, again minus minus plus 1 by 4, then 4 minus 2, 2, and that is also again minus minus plus 1 by 4. Okay, so 3 times 1 by 4, so 2.75. The final and NAT answer 2.75. Just recheck the calculation, Sai Shiva. Take the calculations easily and get the correct answer. 2.75. 2.75. Okay. $2.75 is the last answer. Okay. Next one. Let's take the next. Okay. So Leibniz rule. Some derivation is written here just for you. See it later. Okay. Okay. Now see here. What do we do in the Leibniz rule? See, I'll focus more on the results rather than any more discussion. In the Leibniz rule, we are talking about the derivative of a definite integral term. But we know that, let's learn it logically. We know that integral and differential are inverse of each other. Okay, so when I'm solving derivative of a integral term, integral ft dt, so this differential and integral will cancel. Okay, this differential and integral will cancel. Okay, so answer should be this function f, whatever is the function f. Okay, once you solve the integral, how I solve the integral here? On cancelling with differentiation. On cancelling with differentiation. Once you solve the answer should be f, then you put down the upper limit f of vx. Okay, upper limit f of what? F of vx, and then by chain rule differentiate the upper limit v dash minus f of ux, derivative f of ux, and then by the chain rule differentiate the lower limit. Differentiate the lower limit. Now see an example for better understanding. See an example here. If y is integral 1 to x square cos t dt, what is dy by dx? What is dy by dx? So see, you can even make it as a two-step procedure. You can integrate and differentiate, but that is not required. No, that's what I'm telling. See, if you think, okay, first I can integrate. What is the integral of cos? Also, I know integral of cos is sine. Integral of cos is sine. Integral 1 to x square. Okay, and then I have y is equal to upper limit sine of x square, then lower limit 1. This is the y function, and then I can solve dy by dx. Okay, same answer I will get, no problem. Okay, sine of x square will be, derivative will be cos of x square, and by chain rule 2x will come. Sin x is constant, so derivative will be 0. So 2x cos of x square. Okay, what I am telling you, if you do it by the Leibniz rule, directly, if you apply the Leibniz rule, what does Leibniz rule say is that you are differentiating d by dx of y, that is d by dx of 1 to x square cos t dt. Okay, and integral and differential are inverse of each other, so they should cancel, and answer should be a cosine function. Okay, answer should be what? Answer should be a cosine function. Okay, so answer is cosine, but after solving any definite integral, you put the limits, na? So answer is cosine. Now put the upper limit, x square. Okay, upper limit is x square, and then by the chain rule we differentiate the upper limit. Okay, and by the chain rule we differentiate the upper limit. Then lower limit, cosine of 1. Okay, but since the lower limit is constant, derivative of constant will be 0, and hence derivative of x square, same answer, 2x cos of x square minus 0. The derivative of this constant term will be 0. So 2x cos of x square, this is what Leibniz rule is. Whenever you are differentiating a definite integral term, whenever you are simply differentiating a definite integral term, okay, you can directly use the Leibniz rule. Again, I am telling you, mostly on these definite integrals, you are not getting direct question, but all of these points are useful. So some basic examples I am taking around them. Not going to a very detailed question practice here, but this is something you must know also. I am not skipping it. You must know at least what is Leibniz rule, or what are the important definite integral property, or what is Wallis integral. I mentioned some time back about Wallis integral. Okay, about Wallis integral. Before I talk about Wallis integral, let me mention a particular, because the simplest way, in this format, never you will find Wallis integral in the books or anywhere. Okay, you will find Wallis integral as a complicated formula. You know, if I write it as a complicated formula, it again becomes a burden. Let me write it simply, but to explain you the formula simply, I have a concept that I will write down here, known as double factorial or semi-factorial. Okay, see, what is n factorial? This is basic factorial. We know what is the meaning of any factorial. That is n, n minus 1, n minus 2, continuous product in the decreasing order, consecutive integral numbers are taken, n, n minus 1, n minus 2, etc. up to 1. All the integers from n to 1. All the integers are taken from n to 1. Okay. But if I talk about the concept known as double factorial, two names it has, or also known as semi-factorial. What is this double factorial or semi-factorial? What is this double factorial or semi-factorial? Why do we call it as double factorial? Because of the symbol. We put it this way, n double factorial. Okay. And why it is semi-factorial? Because it is calculation of almost half the terms. That is n, n minus 2, only alternate terms, n minus 4. Now up to 2 or 1, it depends. If you start with even, because you are taking alternate terms, if you start with even, you stop at 2. If you start with odd, you stop at 1. Say for example, if I am calculating 9 double factorial, so that is 9, and then only alternate terms, 9, 7, 5, 3, 1. I stop at 1, and whatever is the calculation we can write down. If I was calculating 8 double factorial, so 8, alternate 6, that means only even will come, then 4, and then we stop at 2. Whatever some answer we can write down. Okay. This is what is known as double factorial or semi-factorial. Now look into the Wallis integral formula. Sorry, let's come here. Look into the Wallis integral formula. Wallis integral formula will give you two types of formula here. integral 0 to pi by 2 sine power mx cos power nx. Okay, some sine power mx, some cos power nx, where m and n can be any integers, is given by m minus 1 double factorial, n minus 1 double factorial upon m plus n double factorial into k. Okay, where k will be pi by 2 if both are even, if both m and n are even, and k will be equal to 1 otherwise. K will be equal to 1 otherwise. Otherwise means if any one of them is odd at least, then k will be 1. Then we can also talk about 0 to pi by 2 sine power nx or cos power nx. Both of them will have the same answer always. Integral 0 to pi by 2 sine power nx or cos power nx will be given by n minus 1 double factorial upon n double factorial into k. K again will be pi by 2 for even power and it will be 1 otherwise. That is for the odd power. That is for the odd power. Clear? That is for the odd power. Okay. Now let's work out some questions to understand this nature. Okay, again these are important integrals even in your technical subjects. Okay, you require these calculations. Okay, so let's take a question here. First on the only sine or only cos. Okay, my first question, suppose integral 0 to pi by 2. Now what is important thing to be remembered in Wali? Limit is 0 to pi by 2. That you have to take care. Limit is 0 to pi by 2 and m and n bar both integers. M or n both are integers. Okay. So integral 0 to pi by 2, suppose if I give you directly sine power 4x dx, or this will be same as cos power 4x. Both these questions will have the same answer. Both these questions will have the same answer. So what is the answer I will write? N minus 1 double factorial, 4 minus 1 double factorial upon 4 double factorial into k, where k, now because it is even power, k will be pi by 2 because of even power, otherwise k will be 1. Okay, so my answer is 4 minus 1, that is 3. 3 double factorial is 3 into 1. 4 double factorial is 4 into 2. Only alternate numbers are taken into pi by 2. So the final answer is 3 pi is divided by 4 to 8 into 2, 16. 3 pi by 16 is the answer. That is how you have to solve this. Okay, 3 pi by 16. Clear? If my question is integral 0 to pi by 2 sine power 5x dx or integral 0 to pi by 2 cos power 5x dx equal to. Again, both of them will have the same answer. Okay, let's do this one. So what is the answer? Let me write down. Okay, so this time it is going to be 5 minus 1 double factorial divided by 5 double factorial into k, where k will be 1 because you have an odd power this time. So 5 minus 1, 4. 4 double factorial is 4 cross 2. 5 double factorial, 5, 3, 1. All odd numbers will come. So 8 by 15 is the answer. Simple. This is how you can solve it up. Otherwise, people will keep thinking about trigonometric identities and that will be very lengthy actually. Integral 0 to pi by 2, integral 0 to pi by 2 sine cube x cos power 6x dx. What is the value of integral sine cube x cos power 6x dx? Yes, dear. Everybody say the next answer now. Okay. Oh, so let's do it now. What should be the answer here? Okay, sine power mx cos power nx. So it should be given by m minus 1 double factorial into n minus 1 double factorial upon m plus n double factorial into k, where k will again be 1 because one power is odd. K is pi by 2 only when both power are even. The general Wallis formula, see, m minus 1 double factorial, n minus 1 double factorial upon m plus n double factorial into k. Okay, so only if both are even, then k pi by 2, otherwise 1. Okay, so what is the answer to be taken here is 1. Okay, the answer for k to be taken is 1. Okay, so now 3 minus 1, 2. 2 double factorial is 2. 5 double factorial, 5 into 3 into 1. Denominator 3 plus 6, 9. 9 double factorial is 9 into 7 into 5, 3, 1 part will get cancelled and k is 1. So 5, 3, 1 if you cancel, only 2 and divided by 63 should be the answer. 2 by 63. Got it? 2 by 63. Okay. Next important definite integral term that you should know. Again, not for direct question. Okay, but indirectly again important. Yes, L1 correct answer 2 by 63 is now. Next important thing is, okay, next important thing is, okay, in the gamma function, the gamma n. Okay, integral 0 to infinity e power minus x, x power n minus 1 dx, where n has to be any positive value. Okay, n can be any positive variable. So gamma n, integral of the form e power minus x, x power n minus 1 dx. Now what are the values? Okay, first of all, gamma will always have a recursive nature. Some important points to be noted down. Gamma 1, no need to prove it. It's, you know, when you keep trying for different n, you will get a recursion formula. Okay, every one value using the previous value. Okay, every one value using the previous value. That is what gamma n plus 1 will be n gamma n for any n value, for any value of n positive. And if it is specially a positive integer, then gamma n plus 1, okay, gamma n plus 1 will be factorial n. Okay, gamma n plus 1 will be factorial n. Gamma 1 will be 1, gamma half will be root pi. Okay, and forget, this is not required. Just discard it. It's actually not required. Forget. If there is any such question, we'll do it by substitution. We'll do it by substitution. Okay, so let it be written. There is no harm in looking into it, but don't remember it. Okay. Now, suppose if I want to give you a question. First, let me give you a question here. Okay. Integral 0 to infinity e power minus x, x power 5 dx. If you don't remember gamma function, you will have to solve it integration by parts, and multiple time integration by parts you are going to solve. Multiple times integration by part you will solve. Okay. Multiple times integration by parts you are going to solve it up, right? Okay. Yes, Shiva, easily some 20 to 20, 30 marks. Okay, sometimes it may be less also, but usually 20, 30 marks, 25 marks in the ESC prelims you expect. ESC prelims paper 1. Now, this is of what form? Integral 0 to infinity e power minus x, x power n minus 1. Okay, so n minus 1 is 5, so n is equal to 6. Okay, so the answer is gamma 6. And what is gamma 6? So for any integral value, I told you gamma n plus 1 is factorial n, 1 back. So gamma 6 is actually factorial 5. So answer is 120. Answer is 120. Integral 0 to infinity e raised to the power minus x, x power, 7 dx. Any such question can be there. Okay. So again, what is the value of n here? N minus 1 is 7. So n is equal to 8. So this is gamma 8. And gamma 8 means factorial 7, which will be 5040. Which will be 5040. Okay. Or if I give you something of this kind, now see here. E power minus x square x power 5 dx. See, a combination of exponential and algebraic function can make gamma, but for gamma function you specifically need e power minus x. e power minus x, whereas this is e power minus of x square, e power minus of x square. Okay, so this has to be first converted to e power minus x term or minus t term. Name could be anything, we know name doesn't matter. So make it as a replacement. Put x square equal to t. Put the value of x square equal to t. Okay, replace it. If you put x square equal to t, so 2x dx will be dt. 2x dx will be equal to dt. Okay, 2x dx will be dt. No, Sai Shiva, no hurry buddy, that's what I'm telling you again and again. It is not e power minus x, it is e power minus x square. So not directly gamma, but convertible to gamma. Okay, and so now I can write down my integral as integral 0 to infinity e power minus of x square, x power 5, let me write it as x power 4 and then x dx. Now I'll close the substitution. See, lower limits will also remain same here. If x is 0, t is also 0. X is infinity, t will be infinity. E power minus x square is t. X square is t. Okay, what will be x power 4? Okay, what will be x power 4? So x power 4 will be t square actually. So t square. What is x into dx? X into dx will be dt by 2. Okay, so this is like 1 upon 2 integral 0 to infinity e power minus t square dt. Okay, where this e power minus t power n minus 1 can be the gamma function. N minus 1 is 3. Okay, n minus 1 is 3. So this is n minus 1 is 2, I mean. So n equal to 3. So this is gamma 3 function. Gamma 3 is factorial 2. Factorial 2 is 2. So 2 by 2 answer will be 1. Answer is actually 1. Answer is 1. Selvan, just recheck the calculation. Answer is turning out to be 1. Okay. The answer is turning out to be 1. Yes, Sai Shiva, correct answer. The answer is equal to 1. The answer is equal to 1. Okay. Then we have the beta function also, although not important. Again, directly gamma function also you don't get the question. But you know, many places, you know, suppose you talk about, I can show you some questions, which is a question of continuous random variable, calculating the mean or variance. If you know gamma functions, your calculation becomes very, very simple. Otherwise, the problem becomes lengthy. Okay. Or, you know, there are some questions of antenna for EC students where knowledge of gamma function saves your time. Otherwise, you keep spending your time in calculation. In fact, there have been questions on antenna where Wallis integral have also saved our time if we know these techniques, and that is why I'm spending time there. Okay, that is why I'm spending time there. Now, beta function, a function of the kind integral 0 to 1 x power m minus 1, 1 minus x power n minus 1 dx for m and n both positive is the beta function. Okay, is the beta function. How do we, this is again convertible to gamma function. Okay, so you know beta, the calculation of beta mn is given by gamma n upon gamma m plus n. We can also solve the integral sine power p theta cos power q theta 0 to pi by 2 sine power p theta cos power q theta as half beta p plus 1 by 2 q plus 1 by 2. But again I suggest better work with the Wallis. This is alternate to Wallis, but Wallis is more simpler. Okay, so only thing you have to remember is what is the beta function? Integral of x power something and 1 minus x power something. Okay, limit 0 to 1, and beta mn is calculated as gamma n upon gamma m plus n. Okay, so suppose integral 0 to 1 x square 1 minus x power whole cube, 1 minus x whole cube, x power something, 1 minus x power something. So m minus 1 is 2. So what beta it is? M minus 1 is 2, so m is 3. M is 3. N minus 1 is 3, so n equal to 4. So this is beta 3 for, and as I have just told you, beta mn can be calculated as gamma m gamma n upon gamma of m plus n. Okay, so this is gamma 3, gamma 4 upon gamma 7. Now, how do you calculate gamma for integral value? Okay, 1 factorial back, so gamma 3 factorial 2, gamma 4 factorial 3, gamma 7 is factorial 6. 2 factorial 2, 3 factorial is 6, and 6 factorial is 720. Okay, so 2 into 6, 12, so 1, cancelled, 1 by 60 it is. 1 by 60. Okay. What is the final answer is 1 by 60. Okay, 1 by 60, the final answer. Next. Now, next concept you need to remember is length of the curves. Okay, length of the curve. See, the length of straight line you know. Okay, suppose there is any random curve given to you. Okay, suppose any random curve given to you and take this point A up to the point B. Okay, suppose you are traveling on the curve. See, there are two things. You can travel onto the curve. You can travel onto the curve through a straight line. The shortest distance between any 2 points is the straight line. If you travel along straight line AB, then you know how much distance you travel, how much meters you travel. The distance is given by root x2 minus x1 whole square plus root y2 minus y1 whole square when I am traveling on a straight line. Okay, but suppose any random curve is given to you and suppose I am traveling on this path. Because I'm traveling on a path, I will travel some distance, na? Maybe 5 meters, 10 meters, something I will travel. Na? How much meters I traveled? If I travel along a straight line, so we know distance formula. But if I travel along a curve given by y equal to fx, how much distance I traveled? Okay, all these discussions are written for derivation. We don't need any derivation right now, but what is the final length of curve? Okay, y equal to fx from point A to the point B is given by, forget this and come here. Okay, if y is a function of x, the length AB is given by integral from A to B under root of 1 plus dy by dx whole square into dx. Okay, or reverse if it is given, you can note down reverse formula if x is a function of y, if they make x as the dependent variable. Okay, so length AB is given by integral A to B root over 1 plus dy by dx whole square dx. I will show you the question, or okay, the form can be parametric form. Okay, y is a function of x, but x and y are further dependent on t. X and y are further dependent on t. Parametric form given. Then the length can be given by integral t1 to t2 under root dx by dt whole square plus dy by dt whole square. If it is 3 variable, dz by dt whole square will also come up. Now take this question. Determine the length of the curve. Determine the length of the curve. Okay, y equal to 2 by 3 x power 3 by 2 from x equal to 0 to x equal to 1. Okay, from x equal to 0 up to the x equal to 1, determine the length of this curve. Determine the length of this curve. Okay, so what is the length of the curve formula? The length of the curve is given by integral a to b under root of 1 plus dy by dx whole square dx. So what I need is dy by dx. Okay, what I need is going to be dy by dx, and that becomes 2 by 3 x power 3 by 2. Derivative becomes 3 by 2 x power 1 by 2. Okay, so what is finally dy by dx becomes 2 and 2, 3 and 3 cancel, x power half, or which is root x. So when you put this inside this integral, what is the length of the curve? It is integral a to b. What is the range of x given? 0 to 1. Under root of 1 plus dy by dx whole square. So root x whole square will only be x. Okay, so you know what is the integral of root x? Same we can apply for root 1 plus x. So 1 plus x power 3 by 2 divided by 3 by 2. Lower limit 0, upper limit 1. Okay, so 1 plus 1, 2, upper limit 2 power 3 by 2. Lower limit is 1 plus 0, which is 1, whole divided by 3 by 2. So whole divided by 3 by 2, I take above 2 by 3, 2 power 3 by 2, 2 root 2 minus 1, 2 root 2 minus of 1. Okay, the final answer 1.22 approximately. Final answer, the final length of the curve 1.22. The final length of the curve 1.22. Okay, the final length of the curve being equal to 1.22. Next question. A three-dimensional curve is defined as xt equal to cos t, yt equal to sin t, and zt equal to Okay, 2 by pi into t. For 0 less than equal to t less than equal to pi by 2, what is the length of the curve? What is the length of the curve? Xt equal to cos t, yt equal to sin t, zt equal to 2 by pi t. Okay, now it's a parametric form given, a 3D curve, x, y, z, all is a function of t, parametric form given. Okay, parametric form given, and what is the length in the parametric form? As I told you, it is integral from t1 to t2 under root of the dx by dt whole square plus dy by dt whole square plus dz by dt whole square dt. Okay, what is dx by dt? Okay, let's substitute here only directly. And what is the range of t given? Integral t1 to t2. The range of t in the question is integral clearly 0 to pi by 2. Dx by dt. Okay, x is cos t, so derivative of cos t is minus sin t. Then whole square plus dy by dt. Sin t derivative cos t, so cos t whole square plus dz by dt. Okay, so 2 by pi t derivative will be 2 by pi. Okay. Sin square theta plus cos square theta is simply 1. Sin square theta plus cos square theta will be 1. So the length will become integral 0 to pi by 2 under root of how much? Cos square plus sin square is 1. So, and this was also squared up. So under root of 1 plus 2 by pi whole square, 4 by pi square, which is actually a constant term. Okay, so this is a constant term. You can directly shift it outside. Okay, we can write it as integral of pi square plus 4 upon pi square, and then integral dt is left, which is t, limit 0 to pi by 2. This becomes integral of pi square plus 4 upon pi into upper minus lower limit only pi by 2. The final answer, pi cancelling, under root pi square plus 4 upon 2. Under root of pi square plus 4 upon 2. It's a NAT question, no options are given. So solving for the final values. (1.86). The final value is 1.86. Okay, 1.86, the final correct answer. Okay, fine. Let's solve it. Okay, length of the curve. Okay, now coming to an area which is actually important in integral calculus, that is the double and triple integral and questions around that. Okay. So till this time, definite integral, basic properties, gamma function, beta function, Wallis integral, length of curve. Okay, you don't get much questions from here. Sometimes you get, but indirectly important areas. So, you know, I have taken through it. Okay, but now this is something where questions are very much expected for you. That is a double and triple integral. Either directly or again, this part is pretty much useful when you go to the vector calculus also. Surface, volume integral. Okay, and in the theorems, all these double and triple integral calculations will matter. Okay. Now, what is the evaluation method? Okay, it all depends, okay, which variable you're integrating first, whether both the limits of x and y are constant numbers, or if the limits of y are dependent on x, or if the limit of x are dependent on y. Okay, any of the case you can be having. First, let me take a question to explain this. Okay, now look into this. Integral y equal to 0 to 1, x equal to 0 to 2. Okay, 2x square plus xy square dx dy. Okay, or I should write it as dy dx since limit of y written first, dy dx. Okay, but the point is, dear, the point is the limit of y is 0 to 1, constant limits. X 0 to 2, both are constant numbers. when limit of x and y are both constant, that is the first point. When limit of x and y are both constant, okay, like x equal to a to b, y equal to c to d, then integrate with any variable first of your choice. Okay, then I can't compel you anything. Integrate with any variable first, your choice, your mood, whether you do it with x, whether you do it with y. Okay, so double integral fxy can be first integral y equal to c to d. When you're integrating with y, x will be constant. If you're integrating with x first, y will be constant. So integrating with y first, x will be constant. Put down the upper minus lower limit and then integrate with x. Or you can also choose integration with x. First integrate with x, that time y will be constant. Put down the limits of x and then finally integrate with y. That is the procedure. Okay, but if the limit of y dependent on x, I'll give you that question also. If the limit of y depends on x, then compulsorily you have to integrate with y first. Okay, so then integral y equal to f1x to x f2x. That is how the limit of y depends on x. Maybe not both, maybe both limits, maybe only lower limit, maybe only upper limit. Any limit of y depends on x, maybe lower, maybe upper, or maybe both of them. Any limit of y depends on x. Integral y equal to f1 to f2. First you have to solve and then put down the upper minus lower limit and then integrate with x. Vice versa, if limit of x depends on y, then integrate with respect to x first. Okay, if limit of x are dependent on y. Okay, so that is how the order of integration is determined. Then you also have the questions here, changing the order of integral. Changing the order of integral, which I will explain you. But first have a look here. Integral 0 to 1, integral 0 to 2, 2x square plus xy square dy dx. Okay, both the limits are constant. Okay, integrate with any variable. Both limits are constant. Integrate with respect to any variable first. Okay, any variable first. So suppose if I complete with y, first dy dx is written. Okay, so you can choose any variable. So first, if I integrate with y, so x is constant. So 2x square, then y plus x. X constant, y square integral will be done. Y cube by 3, limit 0 up to 1. This is y limit. First, I will put down the limit of y, then I will start the integration with x under the limit 0 to 2. Okay, under the limit 0 to 2. So this is equal to how much? This is equal to how much? Integral. Now putting down the limit of y. Okay, so 2x square plus x by 3, y equal to 1, and if lower limit of y, 0 and 0, both the terms will be vanished. So only upper limit was important, and now I will start integrating with x. Okay, so 2x square integral here, x cube by 3, plus x integral, x square by 2, so 2 3s, a denominator will be 6, limit 0 to 2, limit 0 to 2, 2 to 2 by 3, 8, plus 2 square, that is 4 by 6. That is 2 by 3 actually. So 16 plus 2, 18 by 3. Answer for the question is 6. Answer for the question of 6. See, first I am telling you direct question of double integral. Techniques. Okay, first evaluation method and then we'll go to the other variety of questions including their applications as well. Okay, now another way you see here. Okay, alternate is, see, you are solving double integral 2x square. Integration, whether single, double, any integration is always a linear operator. And because of linearity, okay, integration is a linear operator. And because of linearity, let me first break the integral as 2x square dy dx plus integral xy square dy dx. Dear, when both the limits are constant, only when both the limits are constant, you don't have a choice of integration. You can integrate with any variable first. You have a choice of integral. I mean, you can integrate with x also, you can integrate with y also. Okay. By the time you are integrating with y, x was constant. So what I will do is, let's make it as a single step process. Okay. 2x square, you have to integrate with x now. In the first integral, see, you have the 2x square with dx. In the second, you take x with dx and take y square with di and solve it in a single go only. That means 2x square dx, x square integral x cube by 3. Only dy left, only dy integral y plus, I'll put down the limits here. Then I'll put down the limits here. And then plus next term, x with dx. When you take x with dx, x square by 2, y square dy, y cube by 3, y cube by 3. And now put down the limits. Okay, now put down the individual limits. Okay, so yeah, this is how I'm solving, and now I'll put down with the answer with the limit. Okay, so 2 x square integral. So what I have done, x square with dx. So x square dx, x cube by 3. Keep writing the limit. X limit is 0 to 2. dy is y. dy integral y is 0 to 1. Plus x into dx, x square by 2. Limit 0 to 2. Y square with dy, y cube by 3. Limit is 0 to 1. Limit is 0 to 1. Solve it out here. 110%, answer will be 6. You solve it out, same answer will come up, that is equal to 6. That is equal to 6. Okay. What the point here is, dear, what the point here is, whenever you are able to separate x term with the dx, y term with the dy, whether y or y square or any function of y, whether y or y square or any function of y, understand this point. Understand this point, which is important. Okay, if you have f of x comma y, which can be broken into two functions, one is only x function, one is only y function, g of x, h of y. Okay, then integral of fxy, okay, dy dx, okay, under the limit y equal to c to d, constant limit x equal to a to b, can be broken as how much? Just write down the expression and allow me a minute. Yeah, so what I was telling you is, okay, if f of x comma y is gx into hy, variable separable, if variables can be separated, if you have a function, okay, which is in the variable separable format, so what can I do is, we can integrate, what is the function of x? Gx. Integrate gx dx separately, integral hy dy separately in a single step. Okay, normally what I told you, first integrate with y, then with x, or vice versa. Okay, rather than making it as two step, you can solve it in single step if variables are separable easily. Okay, under the limit x equal to a to b and y equal to c to d. Okay, that is what I told you. But this is only for constant limit case. Okay, constant limit case. Next example. What is the value of the integral 0 to 2, 0 to x, e power x plus y dy dx? Now, dy dx, that means this should be limit of y, and of course limit of y can depend on x, na? X is x, x cannot depend on x, y depends on x, so this is the limit of y depends on x. This is like y equal to 0 to x, e power x plus y dy, okay, and then integral x equal to 0 to 2 dx. Because limit of y depends on x, you have to compulsorily integrate with respect to y first. That is, you have to integrate with y only here. Got it? You have to integrate compulsorily with y only. You have to integrate compulsorily with y only. Okay. Let's do it. Okay. Let's do it. Integrating with respect to y first. Integrating with respect to y first. Okay. So yeah, how the answer will be. Okay, integrating with y. First of all, I think integrating with y, x should be constant. So you can make this integral also as simpler only. Okay, you can write down this e power x plus y. You can write down this e power x plus y as e power x e power y, so that you only integrate e power y. E power x will be constant. Okay, so the integral will look like, okay, once you are integrating with y, so e power x is constant. Integral e power y is e power y, and then the limit of y. What is the limit of y? 0 to x. And then we will integrate from x equal to 0 to 2. Okay. So now this is equal to e power x, upper limit minus lower limit, e power x minus e power 0, which should be 1. That's it. Dx. Now this becomes integral e power x, x e power 2x and minus e power x. This is the integral left. E power 2x minus e power x, limit x is 0 to 2. Okay, so keep on completing the integral. This becomes e raised to the power 2x divided by 2 minus of e power x, which is e power x, limit 0 to 2. Okay, upper limit e power 2 to e power 4 by 2, then minus e power 2. Lower limit, you put e power 0, so 1 by 2 minus 1. Okay, so the answer is e power 4 by 2 minus e square and minus plus 1 by 2. We can take the whole denominator 2, and then it is e power 4 minus 2e square plus 1. So, a minus b, e square minus 1 whole square divided by 2. E square minus 1 whole square divided by 2. Okay. Okay. E square minus 1 whole square divided by 2. Done. Right? Yes, this is common portion. It is there in everybody's branch. Okay. This. Okay, now next question. See the next question now coming up. Let me first take you towards. Now, let me go towards the indirect question actually. Now, what I am doing right now, I am giving you the limits. Double integral under the given limits. Now, what is more important and more common? What is more important and more common? Given a region, what is the value of the double integral? Okay, how do you find out the limits? How do you find out the limits? Think about this. How do you find out the limits? Okay, dear. So basically now the portions, a lot of important questions when the region is given, how do you decode the limits and then solve the integral? Okay, so this limits and then the order of integration I'll explain you. Okay, and variety of cases to be taken under this region based cases. So we'll take it in continuity. So I think we'll stop here for a 10 minutes break or so. A quick 10 minutes break, so that again we pick up the energy and keep solving it. Okay, hope you want to learn more. I'm not stopping, it is evening, but I hope you want to learn more. Okay, if you don't want, let me know, we'll stop it, but I think let's better go for a break and keep continuing, keep continuing, keep continuing. Okay. Okay. So we'll do it after the break, dear. Okay. So roughly 10 to 15 minutes break, or let's take it 15 only. Let's regain good energy and then keep continuing. Okay. So the class resumes at 5:40 p.m. The class will resume at 5:40 p.m. Okay, everybody. The class is going to resume at 5:40 p.m. with the discussions on the same question. Okay, dear. See you soon. Okay. Okay, students, so time to continue our discussions. Okay, hope you are done with some refreshments. Okay, some answers are also there, A or D. These are the two options. Okay, so let us see what is the correct answer for this question. Okay, so for the shaded triangular region R, shown in the figure, okay, what is the double integral xy dx dy? Okay, now to calculate the limits of it. Now let's understand. I need to calculate the limits. Okay, now if you blindly say that, if you PDF can only be shared once the session is over, na Ajay? Okay. If you blindly say that limit x equal to 0 to 2 and y equal to 0 to 1 will go wrong. That is why, I'm picking up this question, because many students, they just see what is the x initial to final and y initial to final. If you write down the limits, okay, that limits y equal to 0 to 1, x equal to 0 to 2, this goes wrong. Why? What does this constant limit will mean? What does this constant limit will mean? This constant limit means that for any value of x between 0 to 2, y is always between 0 to 1. This constant limit means something else. For any value of x which is between 0 to 2. If x is between 0 to 2, take any value. Suppose x is 0, so y is 0 to 1. Suppose x is 0.1, then also y is 0 to 1. Suppose x is 0.5, then also y is 0 to 2. Everywhere, for every value of x you choose, y has a constant limit. That is what is the interpretation of constant limits. Okay, interpretation of constant limits. The first case I told you, under constant limit you can integrate with any variable of your choice. Okay, but what is the interpretation of this constant limit? That for any value of x between 0 to 2, y will be 0 to 1, and that actually forms a rectangular portion then. That actually makes a rectangular region. Okay, constant limit will always define a rectangular region. But of course, it's not a rectangle, it's a triangle. To understand the limits here, okay, you can divide the region, okay, first by taking a vertical strip or a horizontal strip, both are okay. Okay, if I start by a vertical strip method, if I start by taking the vertical strip, now see, what do I mean by vertical strip? Okay, let me take a strip here. Okay, a very, very thin strip. Okay, a very, very thin strip. Okay, the dimensions, the width is negligible, very, very thin. Okay, and because I've taken vertical, that means it is along the y-axis. So what is the lower limit of the strip? Okay, y is 0. But upper point of the strip will lie on the straight line. What is the equation of this straight line? Okay, what is the equation of this straight line? Okay, what is the equation of this straight line? Equation of this straight line is, you can take the intercept form also, x by 2, x by a plus y by b equal to 1. X intercept is 2, y intercept is 1, or basically x by 2 plus y equal to 1. So what is y? Okay, for this line, what is the value of y? Let's come here. For this point, what is the value of y? Okay, what is the value of y? So y is how much? Okay, x by 2 plus y is 1, so y will be 1 minus x by 2. Okay, so first, if you are taking vertical strip, take the limits of the vertical strip. Lower point is on the x-axis, but upper point lies on the line. And now slide this vertical strip horizontally. For what values of x? X equal to 0 to 2. Okay, so the integral can be now expressed as integral y equal to 0 to 1 minus x by 2, y equal to 0 to 1 minus x by 2, and then integral x equal to 0 to 1, 0 to 2. This strip will be slided horizontally. Now it makes sense. Because if you take x0, y will be 1. But if you keep increasing x, okay, the y will keep decreasing because you're subtracting x. So if x you're increasing, the value of the subtraction will keep decreasing. Then it will follow the triangular path. Okay, otherwise if you blindly take constant, you make up a rectangular region. Okay, clear now? Okay, now what is the function given? Xy dy dx. Now you have to integrate, because the limit of y depends on x, so integrate with y first. Okay, integrate with y first. So now integral x, x constant, and then you are integrating with y, and y integral will be y square by 2. Limit 0 to 1 minus x by 2. Okay, dx. Okay, first put down the upper minus lower limit, and then we start integrating with x. 1 by 2 can be pushed outside, so 1 by 2 outside, integral x and 1 minus x by 2 whole square. Upper limit 1 minus x by 2, but then whole square. Lower limit 0 square is 0. So this integral is 1 by 2 integral, now x, a minus b whole square. First is 1 square is 1, okay, x into 1, then plus x square by 2, okay, plus x square by 4, so x into x square becomes x cube. The next term will be x square by 4, and next is minus 2ab, so minus x and then into x, so minus x square, and now integrate with x under the limit 0 to 2. Under the limit 0 to 2, so 1 by 2 x integral x square by 2, x cube integral x power 4 by 4, and 4 4s are 16, and minus x square integral will be x cube by 3. Limit of x 0 to 2. So only upper limit would be required here. 2 square by 2 will be 2. 2 power 4 16, 16 by 16 1, and 2 cube, that is 8 by 3. Lower limit 0 0 0, so not required. So this becomes how much? 3 3 9, 9 minus 8 1. 1 by 6 into 1 by 3 into 1 by 2, 1 by 6. Answer is 1 by 6. Clear everybody? The final answer is 1 by 6, and that is equal to option number A. That is equal to option number A. 1 by 6. The final answer is 1 by 6, and answer is option number A. The answer is option number A. Final answer 1 by 6. Now look into the next area. Okay. Why only a vertical strip? We can also take a horizontal strip. The second way is you can also define a horizontal strip here. You can also define up a horizontal strip here. You can also define up a horizontal strip. Okay, so if you take the horizontal strip, okay, that means the limit first you get is in the x limit. The horizontal strip means in the x direction. Okay, the left point lies on the y-axis, and on the y-axis x will be 0. What about this x? So this is the equation. What is the equation of the line? Remember, x by 2 plus y equal to 1. So x can be written as twice of 1 minus y. 1 minus y into 2, correct. Okay, so how your integral will now be written as first limit of x, what horizontal strip. Okay, that has the limit 0 to twice of 1 minus y, and then I will slide the horizontal strip vertically. Okay, from bottom to the top. So that is integral for y equal to 0 to 1 will be taken. Okay, xy, and now the order of integral will be dx dy. Limit of x dependent. Clear na? Limit of x is dependent. So first you have to integrate with x. Limit of x is dependent, so you have to first integrate with respect to the x. Okay, first with respect to x. So dear, you can solve it out now. Solve, okay, and you get same answer. 100% sure you'll get the same answer. You solve, answer will be same, because you have considered a triangular region. Either you break it into vertical strips or you break it into horizontal strips. You have covered the same triangular region with the same function. Answer has to be same. Okay, answer has to be same. So this leads to a concept that you can solve. You can find out the strips, you can find out the limits of any region by either a vertical strip or horizontal strip. That means my two different integrals. Okay, that was, what was my first integral? My first integral was integral y equal to 0 to 1 minus x by 2. Okay, and because the limit of y was dependent, I told you to first solve with y and then with x under the limit x equal to 0 to 2. This is equivalent to what integral? Okay, now next I took horizontal strip, so limit of x 0 to twice of 1 minus y, and because the limit of x depends on y, so you have to first solve with x and then with y under the limit y equal to 0 to 1. Okay. Okay. The region only we have taken, Ajay Kumar. So please specify your doubts. We have covered the entire triangular region only. See now, this x equal to 0 to this means all the points on this line, And when you slide this strip, when you slide this line, all the points of the region are covered, na Ajay? Okay, different values of I means different strips. There will be a strip here. Basically, we have broken it into multiple strips like that, multiple horizontal strip. I show you only one strip, and that is why I say y equal to 0 to 1 means multiple such strips will be taken out. Okay, so that you cover up all the points of the region. Okay, what is the difference in the two approaches is first is dy dx, that is integrating with y first and then x. Next is dx dy where you integrate with x first and then with y, and this is what is known as the concept of change of order of integral. Change of the order of integration. Clear? This is what is known as the change of the order of the integration. The change of the order of integration. Clear? Now, have a look into this next question. Okay, sometimes you can directly get a question only on changing the order of integral. Okay, given an integral x equal to 0 to 1, y equal to 0 to x square, xy square dy dx. They are not asking to solve this integral. They don't want the value of the integral. They are telling this integral may also be expressed in what form. Now see the options. All the options are dx dy. The given integral is dy dx. Okay, that means the first y then x, and then they want to change it to dx dy. So what they are changing? Order of integral. Okay, what they are changing is order of integral. Now first they have given dy dx. That means limit of y depends on x. Previous question region was given. I have shown you both the cases. This time direct integral expression given. So you have to draw the region. You have to draw the region to see. Okay, what type of region would be given? Because vertical limit is given y0 to x square. That means what the region has been taken according to vertical strip. The region has been taken according to vertical strip. According to what? Vertical strip. Okay, according to what? Vertical strip. Let me draw the region. Let me draw the region here. As per the given limits. As per the given limits. Okay, y equal to 0. Now what is y equal to 0? Means x-axis, and y equal to x square is a parabola. Y equal to x square is a parabola. Okay, this is y equal to x square, and y equal to 0 means x-axis. Y equal to 0 means x-axis. Then x only from 0 to 1. So x only from 0 to 1. Say this is 1, this is 0. X only from 0 to 1. Okay. So actually this is what is the region given. Actually this is what is the region given to be specific. Okay. This is the region given. Okay, and the limits are limits of y depend on x. That means they have given according to the vertical strip. They have given according to the vertical strip. Can you solve it according to horizontal strip now? Okay, can you solve it according to horizontal strip? Okay, so let me take a horizontal strip here. Okay, let me take a horizontal strip here. Okay, now for the horizontal strip, that means limit of x is required. So what is this? This is a line. This is a line parallel to y-axis. This is a line parallel to y-axis. So line parallel to y-axis, x is constant. How much is the x value? 1. What about this point? Okay, what about this point? This is a line on the parabola. Y is x square. So how much is x? Horizontal means you need x. If y is x square, x is equal to root y. So as per horizontal strip, okay, you have to convert vertical to horizontal strip. You have to convert from the vertical strip to horizontal strip, and then horizontal strip means limit of x. X is how much? Under root y up to x equal to 1. And then y equal to how much to how much. So this horizontal strip now, this horizontal strip will be slided vertically. Okay, from y equal to 0 up to this point. What is this point equal to? What is this point equal to? X is 1, so y is also 1. So this is 1 comma 1 because this lies on the parabola, na, y equal to x square. So the horizontal strip will now be slided vertically from y equal to 0 up to the y equal to 1. Y equal to 0 to 1, x equal to root y to 1. Okay, no change in the function. Okay. No change in the function. Function is xy square. Okay, x into y square. So this function, you will not change the function, only the limits are being changed vertical to horizontal, and limits are being changed so that the overall region is covered the same. So 100% you will not change the function. That is wrong. So xy square. And what is my correct answer? X equal to root y to 1 and y equal to 0 to 1. C. Correct, cell 1. Correct answer C. This is the important case. These are all important cases under multiple integrals. Whether solving a multiple integrals, whether solving under direct limit given, or whether solving with the region given, or changing the order of integration also. Okay, now next. Okay, next question. I'll come back to it. Just wait and okay, this is a GATE 22 2 marks question. You decide, what type of strip you can take. I will give you this question as homework. You can later on comment the answer in the comment box. This will be homework. GATE 22 2 marks question. Okay, you can again take it as a vertical strip or horizontal strip. Okay, or you can try to solve by symmetry also. You can see if there is some symmetry. Okay. This is up to you. This is up to you. Okay. But what I suggest, even if you don't think about symmetry, if you don't think about symmetry also, then also think about vertical strip here. Because if you take horizontal, okay, here horizontal strip means some limit different here, right limit is same. If you take the horizontal strip here, this limit is different than the above limit because this is a separate line, this is a separate line. Okay, so if you take horizontal strip, you have to divide the integral into two parts. Okay, so in this case, that is why I will suggest to take a vertical strip. I will suggest to take a vertical strip because vertical strip means, okay, the lower point is always on this line, the fixed lower limit, and the upper point is always on this line, the fixed upper limit. You don't have to change it, the vertical strip from one to another. Okay. Just a second. I think there is some problem, but I'll suggest think about some symmetry also. Okay. So this is one homework for you. Think how you can approach this. And now I'll come to another question. GATE 23 2 marks. This is also a good question. What is the value of the integral xy dx dy over the region R given in the figure? Again, a region is given, and whenever a region is given, it is your choice whether what type of strip you want to take, vertical strip or horizontal strip, anything you would like to take. Okay, anything. Here, even if I take vertical strip, I will have to divide into two parts. If I take vertical strip, okay, on the left side, vertical strip will go from minus x to x plus 2. On the right side, x to minus x plus 2. So limits are different on both the sides. So two different integrals you have to solve. One with this vertical strip, one with this strip, and then you have to add. Even if you take horizontal strip, you have to divide the horizontal strip into two cases. Okay. Up to this midpoint, okay, minus x to x, and then another horizontal strip will come. Because here, the horizontal strip in the above portion, what is happening? Okay, left limit x plus 2, right limit minus x plus 2. Okay, here left limit minus x, right limit plus x. So again, horizontal strip also means two horizontal strip. Vertical strip also means two different vertical strips, but I will go by horizontal strip. Think why. I will go with horizontal strip. Think why. If y is minus x to y equal to x, what about x? X is minus y to x equal to y. Minus a to a always can be simplified, or at least there is a hope. If there is a limit minus a to a, that's what I told you in the definite integral. If there is minus a to a, there is a hope that the problem may be simplified. So have a look into it. First of all, okay, this is the central line. So two different horizontal strips will come. Okay, one is this one. Okay, and horizontal strip means you have to write down x. So y is x, so x is y. Left limit, y is minus x, so x is minus y. So I told you, symmetry will help you here. Minus a to a. Okay, now talk about the upper one. If you talk about upper one, please remember you are writing a horizontal strip. And horizontal strip means you have to write down x value. Okay, so what is y is x plus 2? So how much is x is y minus 2? Okay, how much is x here? So y is minus x plus 2. So x becomes 2 minus y. 2 minus y, y minus 2. 2 minus y, y minus 2. Just opposite, sign difference only. So this y minus 2, na? This y minus 2 I can write taking minus outside. This is also minus of 2 minus y. So minus of 2 minus y to 2 minus y. Both are of the format minus a to a. Clear? Both are in the format of minus a to a. So now my integral. So now you can see how my integral will go. My integral will be of what format? My integral will be in the format integral xy dx dy. Okay, integral xy dx dy over the region R. I will break it into two parts. The first case, x is equal to minus y to plus y. Okay, and then for the first horizontal strip, tell me what is the limit of y. This horizontal strip has to be slided from origin to y equal to 1 height. Y equal to 0 to 1. Okay, now because it is a horizontal strip case, you have to integrate with x first compulsorily. Okay, so dx only will come first, correct? Dx dy. Okay, plus upper one, x equal to how much? Minus of 2 minus y up to plus of 2 minus y. Okay, x, y, dx, dy. And then for this, what should be the vertical limit? This horizontal strip will start from y equal to 1 and go up to the y equal to 2. Clear? But in both the cases, you are going to integrate with x first. In both the cases, you are going to integrate with x first. Okay, so it is like x dx. It is like integral x into dx. Okay, first it is integral x dx minus a to a or minus 2 minus y to 2 minus y. Both are minus a to a format. And x, okay, because when you are integrating with x, y is constant. Y is constant and x is an odd function. X is an odd function. So integral minus a to a x dx, 0. And hence both the integral first part is 0. So final step will also be 0. So the final answer, both of them convert to 0 using the symmetry, a smart method to complete the integral. On the same hand, if you take vertical strip, you will come up with the final answer as 0, but you will spend little bit more time. Actually, much more time as compared to it. Answer for the question is 0. Clear everybody? The answer is 0. The answer is 0. Okay. So next question. Let's see the next question then. What is the next question? Where is that? Yeah, let me go back. This was a homework to you. Now, what is the value of this double integral? Next important point. What is the value of this double integral x square y square upon x square plus y square dx dy over the region R, where R is the region bounded by x square plus y square equal to 1 with y greater than equal to 0. Okay, where R is the region, okay, R is the region bounded by x square plus y square equal to 1, y greater than equal to 0. What type of region? What type of region? What type of region? See, region bounded by this x square plus y square equal to 1 is a circle, but y has to be positive, so not the full circle. Okay, not the full circle. Okay, y has to be positive, that means only upper part of the circle. Okay, I have x square plus y square equal to 1 with y greater than equal to 0. Okay, with y greater than equal to 0. That means this semicircular region will come. This semicircular region. Okay. This is x square plus y square equal to 1, but y equal to 0. Okay, this bottom line is y equal to 0. So y has to be greater than equal to 0. That is why only the upper part of the circle is taken. Clear? Only the upper part of the circle is taken. Now dear, important point is whenever you have circular regions and if you try to solve it in the regular Cartesian format, it will be lengthy. It will be lengthy. Okay. For circular regions in the 2D, please convert to, please convert to what? Okay, please refer, it's a circular region in 2D, you can please convert to the polar coordinates. Okay, please convert to the polar coordinates to simplify your problem. Okay, polar coordinates to simplify your problem. What are the polar coordinates? I'm not deriving it, but giving you the final results. Convert to polar coordinates. X will be r cos theta, y will be r sin theta. Okay, and dx dy, that is the small area, the small differential area, is converted to r dr d theta. R dr d theta. Now the point is what actually we are doing when it is a circular region. Like earlier questions, we were taking either a vertical strip or a horizontal strip. What was the idea of taking the strip, either vertical or horizontal? To cover up all the points in the region. Here we actually take a circular strip. Here we neither take a vertical strip nor we take a horizontal strip. Both of them will give you lengthy results. We actually here take something known as a thin circular strip. Okay, a thin circular strip, okay, of some radius r. Okay, and if you take any point on the circle, okay, the angle subtended by this radial line with respect to x-axis is the theta. With respect to x-axis is the theta. Okay, so what we take here, dear, is a circular strip. Simplifying the calculations for the circular strip, we get the coordinates that I have written there. Okay. So what we get is circular strip. Now, as per this picture, what should be the range of this radius? Minimum you can start from origin, maximum you can touch this outer circle which is having the radius 1. Okay, so here, what is the range of the radius? The circular strip can be taken here, multiple strips you can take, na? Like multiple vertical strips are taken. Similarly, multiple such strips can be taken, but up to what maximum radius? Up to maximum radius 1. So this range of the radius is 0 to 1. Here 0 to 1. What about theta? Now when you take any particular strip, you can start from this point where theta will be 0. Okay, and you can go up to this point, okay, where theta will be 180 degree. And for this point, theta will be 0. Okay, so what is the range of theta? In the radian standard format, theta is 0 to pi. Theta will be 0 to pi. If you take a full circle, then theta becomes 0 to 2 pi. If the full circle was mentioned, then the theta will be 0 to 2 pi. Okay. So let's convert this integral. What is my integral given here? My integral is required as integral over a region R, x square y square upon x square plus y square dx dy. Converting it to the polar coordinates will give you integral r square cos square theta, then y square r square sin square theta divided by r square cos square theta plus r square sin square theta dx dy r dr d theta. Simplifying the calculations, r square or r power 5 divided by r square, r cube is left and denominator will be cancelled. Cos square theta plus sin square theta is simply 1. What is only left is cos square theta sin square theta. The limits, okay, the limits, r limit 0 to 1, theta limit 0 to pi, both are constant limit. You can integrate with any one variable, or because it is constant limit, you can solve by the variable separable also. Variable separable means I can integrate r cube separately, r cube dr, integral 0 to pi sin square theta cos square theta d theta. Okay, r cube integral r power 4 by 4. This is finished. Limit 0 to 1. The next integral, dear, if you call it as some f theta, na, if you call it as f theta, Please try f of pi minus theta. Two-way property I will apply. Let's say the pi is two-way. F pi minus theta, sin 180 minus theta, sin theta, okay. Cos 180 minus theta is minus cos theta, but you are taking square. So minus cos theta square will be cos square theta only. That means when you take f pi minus theta, it will be totally equal to f theta. Okay, so what you can do? Integral 0 to 2a is represented as twice integral 0 to a, property number 7 of the definite integrals. Okay, property number 7. So this becomes twice integral 0 to a, integral 0 to pi by 2. Okay, integral 0 to pi by 2 sin square theta cos square theta d theta. And how to write down the answer of this within a single line? How to write down the answer of this? This is nothing but your Wallis integral. This is nothing but your Wallis integral. So you can solve it simply by the Wallis integral. Writing down the answer. For the r, the limit is 1 by 4. Okay, then into 2. Just upper limit, lower limit was 0. Into 2. Now Wallis integral formula 0 to pi by 2 sin power m theta cos power n theta. It is given by 2 minus 1 double factorial. Again 2 minus 1 double factorial divided by m plus n. 2 plus 2 double factorial into k, where k will be 1 because both the powers are even. Both are 2, k will be 1. 1 by 4 into 2, 2 minus 1, 1. 1 double factorial will be 1. 4 double factorial is 4 cross 2. K is equal to 1. So final answer to the question is, one of the two will be getting cancelled. Right. So 1 by, sorry, k pi by 2. Both are even. Both are even. So k pi by 2. Okay, so into pi by 2. Yes, only a 2 cancelled and the answer is only 1 2 cancelled. So 16, 16 into 2, 32. Pi by 32 final answer. Pi by 32 final answer. Using polar coordinates, this problem was solved. Okay, using the polar coordinates, this was solved. And now the next question. Okay, coming up to the next question. Okay, coming up to the next question. Here it is. Let's move ahead to the next question. See the condition here. This was a homework I already told to you. Yeah, we have done. This was a decent good question. Okay, and we have solved this question. And now coming to the next concept, and that is the area enclosed between the curves. Any two curves given to you, y square equal to x and the other one is x square equal to y. What is the area enclosed between these two curves? Okay, so area, what you are going to do is to calculate the area enclosed. This is again a common question. Okay, area is primarily conceptually given by, okay, double integral dy dx, double integral of dy dx, or also equal to double integral over the region given. Okay, right, or it is also equal to what? Let's see here. Okay, so let me first solve this particular question and then go to the next question. So just to explain you this question, I will draw both the curves here. Let me explain you this question and solve both the cases here. Okay, let us solve both the cases here in just a second here. Try it out first. Okay, yeah, let's continue. Okay, so let me draw both the curves. Simple. Y square equal to x is a parabola opening to the right. Y square equal to x is the parabola opening to the right, and the next one is y equal to x square is a parabola opening to the top. It is a parabola opening top. Okay, this is y equal to x square and this one is y square equal to x. What is the region enclosed between them? And I just want the limits of this particular region. Okay, and again to find the limits of this region, I can take the vertical strip here. Okay, let me take the vertical, a very thin vertical strip here. Okay, and onto this vertical strip, the lower limit y equal to x square. The lower limit is y equal to x square. Upper limit y square equal to x, so y will be root x. This vertical strip will be slided from which point to which point? This vertical strip will be slided horizontally from see, this is 0 0, x equal to 0 up to what is this point? Up to what is this point? Okay, so you have to solve. This is a point of intersection. So you have to solve y equal to x square and y square equal to x. You have to solve both this. Okay, and what do you get? Just substitute, you will get 0 0, which is seen also. Okay, you will get 0 0, and next point that you will get here is 1 1. Okay, next point that you will get here is 1 1. Equation solving I leave to you. You can solve it up easily. The equation will be solved and the next point will be 1 1. So this vertical strip will be slided horizontally from x equal to 0 up to the x equal to 1. From x equal to 0 up to the x equal to 1. Clear, everybody? Okay. So if I have to solve this integral, what about my area? Okay. Let me do it here. So what is going to be the area? Area is double integral, as I told you, double integral. What are the limits of y? Lower limit x square up to root x. X equal to 0 to 1. Okay, only dy dx. Only the dy dx, correct? Okay, only the dy dx to be taken. Fine. Now have a look into it. First I will integrate with y because the limit of y depends on x. So integral dy is y. Okay, x square to root x. So since only dy dx is there and I've taken vertical strip, the first I integrate with y. Integral dy is always equal to the y, and because it is always equal to y, you will do the upper minus lower limit. Okay, so you can directly also write down this integral as a single variable integral. You can also write down, see, finally what is coming? Root x and then minus x square. So you can directly write down this as a single integral where what is root x? Root x is coming because of the upper limit. Because of the upper limit. Okay, let me call it as some upper limit fu and let me call this as some lower limit fl. So what I am trying to tell you is you can even write down this integral as integral, okay, integral with respect to dx, integral with respect to dx, okay, upper limit minus lower limit of I, directly you substitute fu minus fl, x equal to a to x equal to b, x equal to a to x equal to b. The same thing I have done here. Okay, you just have to complete the integral. What is the limit of x left in front of me? X is 0 to 1. Please complete and answer me whatever you are getting. Please complete and answer. Cell 1 is telling that the answer is 1 by 3. Cell 1 says answer 1 by 3. Cell 1 says that the answer is 1 by 3. Okay. So let's check it out. Okay, so I'm completing the integral then. Root x integral, x power 1 by 2 integral, x power 3 by 2 upon 3 by 2. And x square integral will be x cube by 3. Limit is 0 to 1. Okay, limit is 0 to 1. So this becomes 2 by 3. Okay, upper limit is just 1. Power 3 by 2, 1. And then again 1 by 3. Lower limit 0, 0. Okay, 2 by 3 minus 1 by 3. Yes, correct answer 1 by 3. Yes. The very correct answer is 1 by 3. Correct, Sale 1. Correct, Jayant. 1 by 3 or 0.33 is the final correct answer. Okay, is the final correct answer. This is the final correct answer. Next question then. Okay, now let me take you towards the next question on the related concept first. On the related concept first. Take this case. Yeah. Take this question. take this question first. Yes. Let's take this. Okay, dear. Find the area enclosed between the given curves. Find the area between the enclosed curves. Find the area enclosed between the given curves. Okay, let's do it. What are the curves given? Y equal to 3 plus 2x minus x square and above x-axis. Now, first of all, how do you draw this curve? See, y is 3 plus 2x minus of x square. 3 plus 2x minus x square. Y equal to x square definitely represents a parabola. Okay, but y equal to minus x square. Okay, minus of x square. Okay, this minus x square, this minus of x square can give you a hint that there has to be a parabola. Okay, there has to be a parabola opening down. There has to be a parabola that opens down because y equal to x square opens up. This is going to open down. What are only the important points if you note down? Huh? What are the important points? See, if you take x equal to 0, okay, y will be 3, right? And if you want to take y equal to 0, you are left with a quadratic equation. 3 plus 2x minus x square equal to 0, or you can call it as x square minus 2x minus 3 equal to 0. X square minus 2x minus 3 equal to the 0, or x minus of 3, x plus of 1 equal to 0. Okay, so x will be minus 1 and plus 3. Okay, so what type of parabola? At least parabolic curve, any type of parabolic curve you should be able to sketch in general also, not only for this particular area question. Okay, so there is a parabola opening down. Okay, x equal to 0, y equal to 3. That means on y-axis it should be crossing y equal to 3, and on x-axis y equal to 0 on x-axis. So x-axis cutting points are minus 1 and 3. The x-axis cutting points are minus 1 and 3. Minus 1, 3. Okay, so a parabola, okay, which is opening down, going to some peak value. Okay, and at x equal to 0, y has to be 3. This has to be 3. It peaks to what value? Not required, but approximately this is the parabola. Okay, so what is the area enclosed between this curve and above the x-axis? The area only above the x-axis. Okay, so this is what is your x-axis. Okay, what area I require here? What is the area I require here? This is the area I require above the x-axis. Area under this parabola, okay, and above the x-axis. And above the x-axis. So what is going to be your upper limit? See, na, if I write down any strip here, okay, this will be my upper limit, fu, y equal to, upper limit lies on the parabola, 3 plus 2x minus x square. And this is my lower limit, fl, which is on x-axis. The lower limit is y equal to 0. On the x-axis, y will be 0. So what is my area under this particular curve? What is my area? So as I directly told you, you can integrate from x equal to, the limits of x is clearly here, minus 1 to 3. X equal to minus 1 up to 3, upper limit minus lower limit. What is the upper limit? 3 plus 2x minus x square minus the lower limit, which was 0. Integrate with x and finish your answer. So this area will be integral 3 is 3x, 2x integral x square minus x square integral is x cube by 3, limit minus 1 to the plus 3. Okay, integration is done, correct? Now 3, 3, 9. Okay, plus 3 square 9 minus 27 by 3 again 9. This is the upper limit calculation, minus lower limit minus 3 and x square 1 and minus of minus 1 by 3. Okay, so the total, this is 9 and minus 2 minus minus plus, this is plus and then minus 1 by 3. So total answer 11 minus 1 by 3. So 10.67 is the final answer. NAT answer it is, NAT question. 10.67 is the final correct answer. 10.67 is the final correct answer. Okay, 10.67 is the final correct answer. Hope it is clear. 10.67. Let's do it the next question. Let's do it the next question. Okay, 10.67 is the final correct answer. Let's go for the next question. Find the volume of the region bounded by the surfaces y equal to x square, x equal to y square, and the planes z equal to 0 to z equal to 3. Z equal to 0 to z equal to 3. Let's understand, okay, how a volume is generated. Volume is for a particular 3D space. Na? Y equal to x square and x equal to y square are parabola. So if I talk what happens in the xy plane, okay, then see, first is z equal to 0. Z equal to 0 we know is the equation of xy plane. In the xy plane z is 0 and z equal to constant is any plane which is parallel to the xy plane. It is a plane which is parallel to the xy plane, correct? It is a plane which is parallel to the xy plane. Okay. If I talk about what is happening in the xy plane, what is happening within the xy plane, if I just talk about that story first, okay, if I just talk about that story, so again, parabolic functions, okay, just like our first area question, two parabolic functions are given, okay, y is equal to the x square, okay, y is equal to the x square, which is a parabola opening up, and x equal to y square, or y square equal to x is a parabola opening right. Is a parabola opening right. Okay, this is the region in the xy plane. This is what is the story happening in the xy plane. This is the region enclosed by these two curves. Okay, but what is the region bounded not only by these surfaces, okay, also within the plane z equal to 0 to z equal to 3. Z equal to 0. Now let me introduce the z axis and let me introduce a three-dimensional picture that will come up here. So what is going to happen is, okay, so to explain you now, let me take the z axis as vertical here for clear explanation. Let me say this vertical is the z axis. Okay, vertical is the z axis, and then the horizontal plane will become the xy plane. Z axis is always perpendicular to the xy plane. So this is the xy plane, x and y axis, and x cross y upwards direction. Okay, x means a direction pointing towards you, out of the screen. X is a direction which is pointing out of the screen. Okay, x cross of y, z. Right hand thumb rule also satisfied. Okay, what was happening in the xy plane I have shown you. What is happening in the xy plane? Okay, a particular region, let me call it as some leaf. Okay, there is a leaf. I'm just giving it as a random name, leaf, which is built in the xy plane. Okay, when the xy plane, in the xy plane, let me copy this leaf again. Okay, it's basically a leaf obtained by two parabolic arcs. Okay, this is what is happening in the xy plane. But for any value of z which is constant, z equal to 0, z equal to 1, z equal to 2, we get a plane parallel to the xy plane. Okay, and for any values from z equal to 0 to 3, okay, the relation between x and y is independently given as y equal to x square and x equal to y square. So even if you reach till z equal to 3, okay, xy plane is z equal to 0, even if you reach till z equal to 3, there will be a similar, okay, leaf to be formed by these same parabolic curves, by the same parabolic curve. Okay, let me join these respective endpoints. This is what is the complete 3D picture you are going to get. Okay. This is what is the 3D volume you are actually obtaining here. This is what is the 3D volume, or let me highlight the boundaries better by separate color only. This is what is the 3D region you are actually obtaining here. Is that clear now? Okay. Not exactly a cylinder, but let's say something of the kind of cylinder. Something of the kind of a cylinder here. Because if this was a circular base, it would be exactly a cylinder. Okay, it's something like a cylindrical volume that you are getting here. Okay. Yeah, but not perfectly a cylinder, to be honest. That's what I'm telling. Not definitely a cylinder, but something like cylinder volume, a cylindrical volume we have been obtaining here. Clear, everybody? Clear, everybody? Okay. Since it is a 3D picture, it will have a volume. That is what is the volume of it? Okay, again I repeat, if this base was perfectly circle, if in the XY plane you had a perfect circle, okay, then these top and ends both will be circle and you get a perfect cylinder. Okay, something of this kind. Again, this is not a perfect cylinder at all, but something of this kind, the picture will be there. Okay, but yeah, some 3D volume, some 3D space has been generated which will have a volume, which will have the volume. What is that volume? What is that volume? So volume always to be calculated by, okay, volume always to be calculated by is given by integral dv, where dv is the differential volume operator, that is dx, dy, dz, and it is nothing but a triple integral problem. Okay, it is nothing but a triple integral problem. Okay, now what are the limits? Okay, what are the limits? Okay, see, z is 0 to 3. Z is very clearly 0 to 3. But what happens in the xy plane? Xy plane, again you can take the strip which I have already shown you. Again in the xy plane there is a strip. Let me take the strip here. Okay. What about the lower point of the strip? What about the lower point of the strip? Y equal to x square. And what is the upper point of the strip? Y square is root x. So y equal to root x. Y equal to root x. So y equal to x square to root x. So let me first take the y limit here, y equal to x square up to the y equal to root x. Okay, and x equal to 0 to 1. Okay, so first limit of y depends on x, dy, and then dx, dz. Let me solve it in this manner. First integrating with y, the dy integral y, upper minus lower limit will be root x minus x square. Root x minus x square. Okay, then I'll be left with dx, dz. Okay, so now I'm going to integrate with x first, or now x and z, both the limits are constant. You can integrate with any variable, or you can do it by in a single step by separating the variable. X function with dx. So x power 1 by 2 integral x power 3 by 2 upon 3 by 2 minus x cube by 3. Here you will put the limit 0 to 1, and dz integral is z, limit 0 to 3. Here first answer you put down the limit, you will get 1 by 3. Second answer is 3 minus 0, that is 3. Final answer is 1. Final answer, yes, Jayanth and Selvan, correct answer. The final evaluated answer will be equal to the 1. The final evaluated answer is going to be 1. Clear? The final evaluated answer will be 1. Okay, next. Okay, next, have a look into this. A triangle in the xy plane is bounded by the straight lines. Okay, 2x equal to 3y, y equal to 0, x equal to 3. What is the volume above this triangle and under the plane? Okay, now again a volume question. Okay, but what are the limits? There is a triangle in the xy plane. Okay, okay, there is a triangle in the xy plane. Okay, there is a triangle in the xy plane. So firstly, what is happening in the xy plane? Firstly, what is happening in the xy plane? That picture is coming up here separately for you. What is happening in the xy plane? Okay, there is a triangle in the xy plane. The line is 2x equal to 3y. That means y equal to 3 by 2x. Okay, some line y equal to 2 by 3x actually. Slope less than 1 will be there. Y equal to 2 by 3x. Then y equal to 0. Y equal to 0 is x-axis. And x equal to 3. X equal to 3 is a line parallel to y-axis. This is x equal to 3 and okay, so this is what is happening within the xy plane. Okay. Okay, this is the line y equal to 2 by 3x. Okay, this is x equal to constant, line parallel to y-axis. So x equal to 3, this coordinate should be 3, 0 then. And this is of course origin. If x equal to 3 here, y will become how much? Y will be 2 by 3 into 3, y will be 2 here. Okay, and this is the x-axis. Okay, y equal to 0 means x-axis. Now this is the region. This is what is the region obtained here, and I want the limits that I will do later. But what is the question now? Volume. Okay, volume above the triangle. Where is the triangle? Now above the triangle. Triangle is in xy plane. Xy plane means, what is xy plane? Xy plane means z equal to 0. So what is the volume above the xy plane? Above the triangle means above the xy plane. Okay, that is z greater than equal to 0. And under this plane and on this plane, no need to draw this particular plane. Okay, no need to draw the 3D picture. The previous question was for explanation. Can you directly take out the limits? So there is a plane x plus y plus z equal to 6. So on this plane, z is 6 minus x minus y. And you want under the plane. So z less than equal to it. Under the plane means z less than equal to 6 minus x minus y. Okay, so what is the volume? What is the volume formula now? Let's do it later. Okay, so what is that volume formula? Let's complete it first. Okay, now z here, the limit of z is 0 to 6 minus x minus y. The limit of z depends on both x and y. So first we will solve with z. Okay, first we will solve with z, and then with respect to y and x, you can take either a vertical strip or horizontal strip. Either a vertical strip or horizontal strip. If I am taking vertical strip means limit of y will come. This is 0 and upper point is clearly 2 by 3x. Okay, so if I am taking the vertical strip, next should be dy, and the limit of y is 0 to 2 by 3x, and then take the x, limit of x 0 to 3. See here, the limit of x then will be 0 to 3. Done? Now just complete this integral. Now just complete this integral. First with x, first with respect to z, first with respect to z. Okay, then you will get expression of xy, then limit of y depend of x. Okay, then with respect to y, and then finally with respect to z. Finally with respect to x. Okay, so guys, only calculation part left. Better let's solve more variety of question. Calculation you can do as homework. The calculation you can do as homework. Clear everybody? The calculation you can do as homework. I have given you the structure. I have explained you the geometry of the problem. No need to draw the complete 3D region of this, just like the previous problem. Previous one was for the explanation. We drew a 3D figure to obtain how to understand how 3D space is being generated, okay, which will have a volume, okay, which will have a volume. But here, needless to draw the complete 3D picture, okay, and we have done it without it, but only part is calculations left. That too, first you have to solve with z, then y, then x, okay, then y, then x. Not going to be a tedious one, it's going to be simple only. With respect to z, it is 6 minus x minus y, that is solved only. dz integral z, upper minus lower limit, 6 minus x minus y, then it's a regular double integral which we have solved multiple cases, isn't it? Which we have solved the multiple cases. Okay. Right. Jayant says the answer coming up as 10. Jayant directly says the answer coming up as 10. Okay. Yes, answer will be 10 only. Correct. Answer is going to be 10. All right, guys. So, yes, more energy. Want to go more? See, if we want to go more, okay, let's come up first to discussions on functions of complex variable. Okay, some discussions on functions of complex variable. But what happened? Suddenly the attendance dipping. Okay, let's wait for 5-10 minutes. If it is that big a dip, then we can stop. I can understand that students are tired. Okay, if I have to have the energy for the entire day, I will expect the same from students, na? Very logical enough. If you give out on energy, then I will also give out on the energy. Simple. I told you in the morning, I'll continue as long as you are ready to have it. Multiple important topics done. Multiple important topics are done. Okay, so let's start here. Let us see. Okay, for how much time you are ready to move. So some discussions on functions of complex variable. Okay, so no, some mode change occurred. Yeah, it's okay now. Okay, so w is a function of z, okay, which is u plus iv, okay, starting with a function of complex variable, okay, where z is a complex variable. Okay, now the complex variable is z, which is x plus iy, and hence any function of z, is again expected to be complex in the form of u plus iv. It is expected to be complex in the form of u plus iv. Okay, how? Say for example, any function you imagine, just let's take a very basic example. Okay, say for example, z is a complex variable and there can be any function in the form of fz equal to z square. Okay, a square function, fz equal to z square. So what is going to be the value of z? The value of z is x plus iy whole square, which becomes x square plus iy whole square, a square plus b square plus 2ab. But when you simplify, you are going to get this function as I square is minus 1 actually. Okay, so that becomes real only. So x square minus y square plus here we have the imaginary number iota I2xy. Okay, I2xy. And because z is a complex variable containing some real and imaginary part, any function of it is expected to be complex, which can also be expressed in the Cartesian form as u plus iv. Okay, so before I take up any particular model of question from complex function, what I want to tell you is, given any complex function, you should be able to obtain its real and imaginary part. Okay. Like fz is z square, so u and v. U and v are further two variable function. Okay, u and v, it's basically expressible as this format: u and v, u of x comma y plus I v of x comma y, where u and v are two variable functions. Okay, so because some two variable functions, so definitely some partial and total differentiation will come up here. Okay, any other example, suppose if I take, another simple example, take exponential of z. Okay, so if you take e power z, z can be written as x plus iy. Z can be written as x plus iy. Okay, and we can now split it as e power x into e power iy. And to simplify it, we can use the Euler's formula for e power I theta. What is the Euler's formula for e power I theta? Okay, cos theta, that is cos y, plus I sin theta, I sin y. Okay, and hence what is fz now? Opening the bracket, e power x cos y plus I e power x sin y. Again expressible in the format of u plus iv. Okay, where u and v are again two variable real functions. Individually, u and v will be real functions. Okay, e power x cos y is the u function, e power x sin y is the u function. Okay, now if this is clear, okay, have a look into this question. For the function of the complex variable w equal to log z. So I first took a polynomial function z square, then I took an exponential function. Now I give you a function w equal to log of z. Okay, where w will be expressed as u plus iv and z is of course x plus iy. Then u equal to constant line get mapped in the z plane. Okay. Map. How will be the plot or how will be the graph for the curve u equal to constant? How will be the graph for the curve u equal to constant? U equal to the constant. How is going to be the graph for the curve u equal to constant? Clear? Let's see. So what is u and v? That is what I want. Okay, so w is log z. See, w is equal to log z. Okay, and log of x plus iy. See, in the previous two examples, I took z equal to x plus iy and then expanded. Okay, if it is z square, to x plus iy whole square or e power x plus iy. But can you expand here? Can you expand here? Log of x plus iy. Is there any log a plus b expansion? In fact, log of a into b expansion is known to me. Log of a into b is log a plus log b, but log a plus b we can't directly expand, isn't it? Okay, so if you take it this way, maybe we are stuck. So what we can do is, we can now take w equal to, okay, let's say, see, z is normally you take x plus iy, but it is also expressible in the Euler format as r e power I theta. Okay, where I is root over x square plus r square, r which is the modulus of z, the r which is also known as the modulus of z, root over x square plus y square, and theta, okay, theta is the face or argument of z. We also write it as angle z, and it is given by tan inverse imaginary part by real part. Okay, this is fundamental of complex, Now, if I put z equal to r e power I theta here, so now inside log you will have log of a into b type of term. Okay, w is equal to log of z. Okay, and if I take z in the Euler format, now this is log ab, which can be opened as log a plus log b, log r plus log of e power I theta. Okay, so this is log r plus I theta will come outside and log e will be 1. The power comes outside. And hence we have split this in the form of u plus iv. W is equal to log r plus I theta, okay, which is in the form of u plus iv, where u is log of r, that means log of root x square plus y square, correct? V is theta, and theta we know tan inverse y by x. So I told you x and y, u and v will be function of x and y. Now the question is, okay, u equal to constant, how it will be mapped in the z plane? So if I take the equation u equal to constant, okay, what is u? Ln under root x square plus y square is some constant, suppose c. So what is root over x square plus y square? Take the exponent on the other side, that becomes e power c. Since c is a constant, e power c is also a constant, suppose k. Okay, so what is x square plus y square? X square plus y square is k square. X square plus y square equal to the k square. Okay, that represents a set of circles. Okay, circles, okay, with the center at 0, 0. Okay, radius will be k. So only thing that can change for the circle is radius based on the value of c given. Okay, what is that constant value? Not mentioned. It may be 1, it may be 2, it may be 5, any value given. Based on the c, the radius of the circle will change. Okay, but all the circles, even if you change the constant, all the circles will have center at 0, 0, and hence we call it as concentric circles, the set of circles having common circle, having the common radius. I'm so sorry, the set of circles having the common center. So sorry for the words. That is what is set of concentric circles. A set of circles having the common centers, okay, but different radii. Okay, so that will be concentric circles. B is the very correct answer. Yes, Rohan, very good. Correct answer is B. If I can ask for V also, for the same problem, log Z, okay, if the question was how V equal to constant will be mapped or how this is going to be plotted. So what was my V function? V function was the theta function, that is tan inverse y by x equal to some constant, suppose V. So y by x, you can take tan on the other side, tan C. If C is constant, tan of C is also some constant like K. Okay, so what is the relation between x and y? Once you write down xy relation, then you know any of the common curves, like previous one was circle, y equal to kx. Y equal to kx will represent lines, okay, will represent lines passing through origin, because there is no C, mx plus C, there is no C. So all the lines are passing through origin, okay, and only thing that can change for the line is slope. Slope depends on k, k depends on the given constant. So based on the value of constant, your slope can change. But it is a set of lines and all such lines passing through origin. Okay, a set of lines passing through a common lines. Okay, these are radial straight lines. Okay, so radial straight lines. In this case, your answer will be, if the same question I repeat for V equal to constant, your answer will be A then. Okay, your answer will be set of radial straight lines. Okay, so right now this was A, the actual answer is B. Okay, but if I change the question to V equal to constant, answer is going to be A. Okay, answer is what? Answer is going to be the A. Clear? The answer is going to be A. Correct? Answer is going to be A. So, next question. Let S be the set of points in the complex plane corresponding to the unit circle. Okay, that is S corresponds to the point Z such that mod Z equal to 1. Okay, S is the set of points in the complex plane unit circle. Consider now another function fz is equal to zz star, where z star is the complex conjugate of z. Okay, then fz maps S to which one of the following in the complex plane? To which one of the following in the complex plane? Understand, this is basic complex functions understanding. Okay, but yet this is important. So if I talk about fz, which is z into z star, and here z into z star, you can remember, is always mod z square. See how? Because conjugate of x plus iy is x minus iy. X minus iy. Okay, so you know it will be a square x square, okay, minus b square. But I square is minus 1. So fz becomes x square plus y square. Okay, fz becomes a real value. Now fz maps S. Okay, fz maps S. What is S? S is the set of points. S is the set of points. Let me draw S here. What is S here? S is the set of points in the complex plane corresponding to unit circle. Okay, what is unit circle? Okay, what is the equation of circle? Mod z equal to r. Okay, but unit circle means radius equal to 1. Unit circle means radius equal to 1. Okay, so if I take one complex plane where I draw the points S first of all, okay, what is S given to me? S is the set of points lying on the unit circle. Clear? Okay, what is the unit circle? X square plus y square equal to 1. Radius has 1. Okay, so S is the set of all the points lying on this circle. S is the set of all the points lying on this circle. Okay, so now with reference to it, what is the fz? Fz is x square plus y square. Okay, now for any point lying on the set S, if any point lies on the set S is the set of points on the unit circle. Okay, that means x square plus y square equal to 1. So if you take up any point lying on this S, what will be the fz? Fz, which is x square plus y square, will also become 1. Okay, so how will you draw this complex function? What will be the mapping of fz for s? Okay, this is 1 means 1 plus I into 0. Okay, so if I show you this in a separate picture, if I show you this one in a separate picture, okay, how will you draw, okay, this function fz in the fz plane? Okay, let's say this is the plane where I am drawing the complex function fz. This is fz plane and this was the z plane. Fz is 1 plus I0. How do you draw 1 plus I0? Real part 1, imaginary part 0. It is just like the point 1 comma 0. Point 1 comma 0 or 1 plus I0. Okay, 1 plus I0. 1 plus I0. Right, so it just corresponds. Okay, the fz maps s to which one of the following? Okay, so when you take up any point on the s, put it inside the function. Okay, what is the plot and what is the mapping you get? You get the function fz which is 1 plus I0. That means any point lying on the circle, okay, is mapped to a single point. Is it clear now? Any point lying on the circle, okay, is mapped to a single point by this particular function. Okay. All the points of this S, they come and convert it to a common point. That is 1 comma 0. Clear? That is 1 comma 0. Many to one mapping. Oh, great to know, Naveen. Even, good for some of the students that, even some of the students are also continued till now. Okay. It's almost 9 hours done. It's almost 9 hours done. All right, next one. Now, next one. Now, analytic functions. Analytic functions. So, see, first of all, if I talk about derivative of a complex function, if I talk about derivative of any complex function, see, w is a function of z. Okay, so the dw by dz or derivative of fz, which is also f dash z, is represented by the same first principle which you apply for a real function also. Okay, the change in the function with respect to change in z, where the change in z is taken to be small. Okay, so suppose the initial value of the function is fz. Okay, for some value z, I change z to z plus delta z. Okay, the function changes to f of z plus delta z. So this is the change in function and this is the change in the value of z. Okay, where the change in z, delta z should be small. So what is this? First principle of differentiation. In the calculus, in the very beginning of the calculus, we studied this. This is nothing but the first principle of differentiation, correct? Because it is the first principle. Because it is the same first principle of differentiation. That means all your basic differentiation formula, will remain to be same. Good evening, Dharmendra. What are the basic differentiation formula? Suppose if I tell you w is z cube. Okay, so what is dw by dz? Okay, like the derivative of x cube. 3x square, it's going to be 3z square here. If I tell you w is equal to e raised to the power 4z, so what is the derivative of exponent function? Will remain to be exponent e power 4z, but by chain rule 4 will come outside. Okay, the 4 will come outside. If I tell you that w is equal to log of z, what is the derivative of it? 1 by z, and etc, etc, etc. Okay, same first principle. Okay, same first principle. Okay, that means the derivative formulas are same. Okay, so derivative formulas are same. Remain same. Okay, the question, let me quickly tell you, analytic function also produces question, but commonly only one important point here is Cauchy-Riemann equation. 2-3 types of models are there, but only and only on Cauchy-Riemann equation. Okay, so let me quickly take you towards Cauchy-Riemann equation. Okay, if a function is analytic, it will satisfy Cauchy-Riemann equation. So if a function is differentiable at a point and also in the neighborhood of this point, if a function is differentiable at a point and also in the neighborhood of that point, then it is said to be analytic at that point. Okay, and For a function to be analytic, final conclusion, let me go through the slides quickly. For a function to be analytic, let me come back to this point later. Okay, the necessary and sufficient condition for any function fz equal to u plus iv to be analytic are. Okay, so as I told you, fz, okay, w is a function of z which can be broken as u plus iv, okay, where u and v, which can be broken as u plus iv, okay, u plus iv, where u and v are functions of, we have been seeing they are further functions of x and y. For the necessary and sufficient condition for a function to be analytic are all the partial first order derivatives of u and v must be continuous. Okay, del u by del x, del u by del y, del v by del x, del v by del y must be continuous functions of x and y. Okay, must be continuous function of x and y, because what I told you in the calculus that if the derivative of a function is continuous, that means the function is differentiable. Okay, then del u by del x must be equal to del v by del y. CR equations. This is the important point to be highlighted from this particular analytic function theory. Okay, del u by del x must be equal to del v by del y, and del u by del y must be equal to negative of del v by del x. The equations, very, very important, the Cauchy-Riemann equations. Okay, the equations, these are known as the Cauchy-Riemann equations. Okay, the Cauchy-Riemann equation. The Cauchy-Riemann equation. Clear, everybody? Okay, so del u by del x must be del v by del y, and del u by del y must be negative of del v by del x. Okay, must be del v by del x. Okay. The Cauchy-Riemann equations can also be expressed in the polar form. Okay, can also be expressed in the polar form. Okay, if we know that u and v are functions of x and y, but sometimes we can also, like in the logarithm example, we can take the help of polar form and we can write down u and v in terms of r and theta. Okay, u and v in terms of r and theta. So if you write down u and v in terms of r and theta, okay, then the CR equation in the polar format will be del u by del r is 1 by r del v by del theta, and del u by del theta will be minus r del v by del r. Although not very important, but what is important is the CR equations, okay, in the Cartesian format. Okay, now what models of questions are expected? Let us quickly talk about that. Okay. Okay. I'll summarize, Vishnu Priya, what all we have covered and what all or more we are going to cover. I'll summarize about that. Thank you, Manoj. Hope you are learning and enjoying. So, some more points I was briefing out, and then we go to the model of the questions based on the CR equation. Okay, analytic functions can also be called as regular functions or holomorphic functions. Okay, if a function is analytic everywhere in the complex plane, okay, at all points in the complex plane, then it is said to be entire function. Now the important point is, if I am talking about the derivative definition, okay, it is same as first principle of differentiation, and hence the formula of derivatives are also similar. That is why some basic rules of calculus will keep following. Some important functions, like I told you, the sine and cos, the e power z, the polynomial. If I again take those example, okay, the sine z, cos z, e power z and the polynomial, okay, they are always continuous and differentiable. They are always analytic, and hence they will be here known as entire function. I repeat, if a function is analytic everywhere in the complex plane, it will be called as entire function. Okay, set of points at which a function is not analytic, singular points, which will be important when I go to the contour integral part. Okay, the set of points where the function is not analytic are known as singular points. The set of the points where function is not analytic are said to be the singular points. For example, if there is a sec function, okay, sec function, the derivative of sec theta is sec theta tan theta, na? Okay, if you talk about the derivative, okay, it will be sec z into tan z. Okay, but whether you take sec z or tan z, both of them will fail at pi by 2, because tan pi by 2 or sec pi by 2 both is undefined. Pi by 2 or even 3 pi by 2, 5 by 2. So these are some points where derivative will not exist, function is not differentiable and hence not analytic. And because the function is not analytic, set of these points will be singular points. Okay, we'll talk more about singular points upcoming time. That is more important once I start the contour integral part. Okay, that is more important once I start the contour integral part. Now, talking about the CR equation and then talking about the model of the questions. See here. If I take up if I take up an example, suppose fz is equal to z square. Okay, but we already broke the z square. See, z is x plus iy whole square, and solving it, we have written it x square minus y square and plus I to xy. Nothing, a minus b, a plus b whole square we opened and we got this, and this is u plus iv. U plus iv. This is polynomial function z square. It is expected that polynomial should be always differentiable and hence always analytic. That is what I expect. Okay. U is x square minus y square and v is 2xy. See now, see our equation, understand here. Okay, now what is del u by del x? Partial derivative with x, 2x. Okay, partial derivative with y will be minus 2y. Okay, v, partial derivative with x. Partial derivative with x. So 2y constant, x derivative 1. Del v by del y. Partial derivative with y. So 2x constant, derivative of y will be equal to 1. Clear? Now see, is it always equal? Del u by del x and del v by del y both are 2x. So 2x is 2x, na? 2x will always be 2x. 2x is equal to its own value. Del v by del y or del u by del y should be negative of del v by del x, correct, na? What is del v by del x? 2y, and del u by del y is negative of 2y. Satisfied? Okay, satisfied. This has to be related with the minus sign. With the minus sign, right? So always for any value of x and y, we are able to see here del u by del x will be del v by del y. That means, and the next del u by del y is negative of del v by del x. Okay, that means function is always analytic. Because it's a polynomial function, this was an expected calculation. Because this was a polynomial function, it is an expected calculation. Clear, everybody? It is a expected calculation. Okay, it is a expected calculation. Now next. Okay, next. Okay. Milne-Thomson theorem, which I will use in upcoming time. Just to note that if there is any analytic function and if you want to write it in terms of z again, suppose I directly give you a u plus iv format function. Okay, u plus iv, suppose for example x square minus y square plus I to xy. I to xy. Okay, if you want to write it back in terms of z, okay, what you can do, you can simply replace x by z. Just now I told you, na, this is analytic. Okay, Milne-Thomson theorem for analytic function, replace x by z, y by 0, and your function will then become z square minus 0 plus I into y0 to 2xy0. So this function should be z square function. True, na? From z square only I've got this format. So reverse. Okay, if you want reverse, no direct questions out of it, but this is useful some point. Just briefed it out. Milne-Thomson theorem. If there is an analytic function given in u plus iv format, xy format, and if you want to get it in the z domain, replace x by z and y by 0. Okay, x by z and y by 0. Take this question now. Suppose there are two functions, f1z and f2z given to you. f1z is z square and f2z is z conjugate, be two complex variable function where z bar is the complex conjugate of z. Choose the correct answer. Which of them is analytic or not analytic? Options are around that. Which of them are analytic or not? So see, fz equal to z square, polynomial. Polynomial, okay, so analytic. Always analytic. No need to confirm. No need to confirm. It is always analytic. So don't waste your time for the z square. I have shown you CR equations just now, but that was just to explain CR equation. If I see z square function, I should be able to directly say because of the polynomial category, it should be analytic. Okay, we don't have to do it. This was just to explain you how CR equations are being matched up. Okay, now what is the other function is given to you as a conjugate of z. Let's talk about the f2z function. What is the f2z function is given to you as conjugate of z, that means x minus iy. Conjugate of z is known as x minus iy, correct? X minus iy. Okay. Now compare it with u plus iv. Okay, so what is u, what is v? U here is x and v here is minus y. And let me write down the partial derivatives. del u by del x 1, del u by del y, partial derivative with y doesn't exist, 0. Okay, del v by del x would be 0, del v by del y, partial derivative with y minus 1. The first CR equation itself is failing. Okay, the first CR equation, del u by del x is not equal to del v by del y. These two should be equal, these two should be opposite sign. Second will match anyways, both are 0, so 0 and minus 0 same. But first is not matching, and if any CR equation fails, both the CR equation must be satisfied. Del u by del x is not equal to del v by del y, so not analytic. Not analytic, dear. Not analytic. So F1 and F2Z are not, only F1Z is analytic. Option number B. Option number B. Yes, Rohan Singh and Uzair, correct answer. It is option number B. It is the option number B, which is the correct answer. So one category of question can be just checking whether a function is analytic or not. Okay. Yes, L1 correct. Another one is here. Okay, given a function, okay, some function fz, iz plus k, real part z plus I, imaginary part of z. For what value of k will fz satisfy the Cauchy-Riemann equation? For what value of k will the fz satisfy Cauchy-Riemann equation? For what value of k will fz satisfy the Cauchy-Riemann equation, the CR equation? Okay, so what is the function fz given actually? I into z, that is I into x plus iy, plus k, real part of x, real part of z means x part, and I, imaginary part is y. Okay, so clubbing the total function, see, open up the bracket, ix, next is I square, which becomes minus 1, so minus y, then we have kx, and then we have iy. Okay, so clubbing the real and imaginary parts, okay, it is kx minus y, this is totally real, and with I part I have x plus y. With I part we have x plus I. Okay, so what is my u? Kx minus y, and what is my v is x plus y. Now for what value of k it will satisfy CR equation? Simple question it is. It is a simple question. First let me write down the derivatives. Del u by del x and del u by del y. Del u by del x k, del u by del y minus 1. Del v by del x and del v by del y also required. Del v by del x 1, del v by del y also 1. Now what are the CR equations dear? Okay, the first one is del u by del x must be del v by del y. From this only I think we can get the value of k. If you want del u by del x equal to del v by del y, that means k should be 1. Second, automatically satisfied. Second, automatically satisfied. Okay. Del u by del y should be negative of del v by del x, automatically satisfied. Okay. So second is automatically satisfied. Okay. From the first I got the k and that is what I wanted. So answer is B. For what value of k it satisfies CR equation? It is option number B, plus 1. Jayant and Rohan correct? Okay. Uzair, just recheck the calculation. It is plus 1. Yeah, correct Uzair. Plus 1 now. Okay, plus 1 now. Okay, plus 1. Next model of the question. Now, okay, to determine fz when the real part u is given. Okay, when the real part u is given. When the real part u is given. Okay, so suppose there is an analytic function. Yes, AP political facts, correct answer. Suppose there is an analytic function u plus iv which is not completely given, partially given. Partially means either real part, okay, or anything. Just understand the approach. Either u or v given, any one given. Okay, w is fz, u plus iv, u or v, any one parameter given, either real or imaginary part. What I will do, I will first differentiate the function. F dash z equal to dw by dz. Okay, and it is by CR equation it can be shown that, okay, I'll write down here. Okay, w is fz, na? Let's say w is some function of z. Okay, so what is dw by dz can be written as del w by del x or can be written as minus I del w by del y. Okay, these are again proved by CR equation, not required right now. Okay, the derivative of w with z can directly be obtained as partial derivative of w with x or minus I partial derivative of w with y. Okay, so let us use the simple one, del w by del x. Del w by del x. Now what is w is u plus iv. That means if you want partial derivative, del u by del x will come plus I del v by del x will come. Okay, but again only u given, assume. Okay, only u given. So what will you do? You will replace this by CR equation. V is not given, na? You will replace this by CR equation. So once you apply the CR equation, okay, del u by del y is negative of del v by del x. Which CR equation? CR equation number 2. Okay, so what is del v by del x is negative of del u by del y. Now because u is given to you, del u by del x and del u by del y both you know. That means you know f dash z. What you know? F dash z. So what can be f z? It is integral f dash z at z comma 0. Okay, why at z comma 0? Milne-Thomson theorem. Convert if you want, because you are getting f dash z in the, from u, and u is a function of x and y. That means you will get some xy answer here. To convert back to the z domain, I told Milne-Thomson theorem, replace x by z, y by 0. Understand by a problem. So you don't have to remember the final formula. Approach. Only for approach, I made it read here. Now let's understand by a question here. Okay, let's understand. There are two types of question actually. Given you, find the function fz. And second is given you, find the value of imaginary part directly. That is the second model I will show you. That is the second model I will show you. Okay, so come up here. Okay, u is equal to the real part of an analytic function. Then what is that analytic function? Okay, then what is that analytic function? If u is the real part of that analytic function. Okay, so see again dear, fz is equal to u plus iv. Fz is u plus iv. Only u is given. Okay, we will start with derivative. Okay, so derivative, as I told you, suppose this is w. So derivative means dw by dz or directly del w by del x. So when you take partial derivative with x on the right side, you will get del u by del x plus I del v by del x. Approach, only approach is important. But what is del v by del x? You will replace by the CR equation, minus del u by del y. Second CR equation. So del v by del x is minus del u by del y. You have to convert everything to u because u is given. Similarly, v is given, you will convert everything to the v format. Okay, so what is f dash z? Del u by del x minus I del u by del y. Now dear, u is given, na? So you can calculate both the partial derivatives of u, once with x, once with y. Then integrate f dash z at the integral f dash z at the z comma 0. Complete this and allow me a minute. Yeah, let's continue. If there is some answer. Okay, let's see if there is some answer here. Uzair says answer B. Okay, so let me put down the value del u by del x. Okay, so derivative with x, partial derivative with x is going to be how much? Y will be constant, so that is 3x square. Okay, y will be constant, so minus 3y square, x derivative is 1. Okay, then 3x square derivative 6x. Okay, then y constant, 1 constant, minus I del u by del y, derivative with y, so y square derivative 2y, so minus 6xy. Okay, then 0 and then minus 6y, okay, and etc. Okay, this is what is f dash z. This is what is f dash z. So now if I talk at the point z comma 0, at the point z comma 0, if I talk at the point z comma 0, okay, so what is the f dash z at the point z comma 0? Okay, so it simply becomes 3z square y0 and then next is 6z minus I y0 means totally 0. Okay, so the function is 3z square plus 6z. Okay, that is f dash z. Okay, so what is fz? So as I told you, fz will be obtained as integral of f dash z at the point z comma 0. So integral of the given function, that is 3z square plus 6z. Integral 3z square plus 6z. 3z square plus 6z dz. Okay, so 3z square integral should be z cube and 6z z square by 2, so 3z square. Okay, normally inside any indefinite integral, we add a constant of integral which can be added as IC. C or IC, that depends on option. But since real part was given without any constant, so maybe there is a constant in the imaginary part, we generally add it as IC. Okay, so z cube plus 3z square, or is what was it minus z cube plus 3z square? Did I miss anything? Okay, the derivative with x, 3x square minus 3y square plus 6x, correct? Derivative with y, x constant, so minus 6xy minus 3y, all looks good. And when I put y0, 3z square plus 6z, correct? So integral z cube plus 3z square should be there. Yeah, okay, plus y, okay, correct na, C. It is C, no problem, it is C, because you know the integration, any constant can be there actually. Okay, when you are solving this indefinite integral, I think more than you and me, the board is tired. It is behaving very randomly right now. Plus any constant of integral, that maybe some constant like C, or maybe some constant like IC, or maybe some constant like C1 plus IC2, any type of constant that you can look into the option. It is plus only, user. It is plus only, and the constant, this is the constant of integral. It is known as the constant of integral. Option number C. The function part has to be matched. That is more important. The function part has to be matched. That is more important. Clear? So z cube plus 3z square, correct? Okay. No, not necessarily options are wrong. Options can be fine also, not a problem. Okay. To determine the value of the constant, they may give some additional condition, but they usually don't ask it. Okay. Chalo, next question. Now, what is the next model? Okay, this was the model. Given you, find fz. The next model is given you, find the value of v. Okay, now this question can be presented in two different languages. Okay, so suppose fz is an analytic function. First of all, let me tell you one important point here. Suppose fz is u plus iv. Okay, and suppose it is an analytic function. U and v are the real and imaginary parts of each other. Okay, if u and v are the real and imaginary parts of a complex analytic function, if u and v are the real and imaginary parts of a complex analytic function, they are also both harmonic functions as x and y. What are harmonic functions? Okay, that means they will satisfy Laplace equation. That will satisfy the Laplace equation. Okay, both of them will satisfy the 2D Laplace equation, del 2u by del x square plus del 2u by del y square equal to 0, and also For v also, del 2v by del x square plus del 2v by del y square equal to 0. Why? By CR equation, again it can be proved. Both u and v will satisfy Laplace equation. Both of them are harmonic function and they are said to be conjugate harmonic functions of each other. They are said to be conjugate harmonic functions of each other. Okay, u and v are the real and imaginary parts of a complex analytic function and they are also said to be conjugate harmonic functions of each other. Okay, v is the conjugate harmonic function of u or vice versa, u is the conjugate harmonic function of v. Okay, and both will be individually harmonic, that is both satisfying the Laplace equation, the 2D Laplace equation. Okay, because of the Cauchy-Riemann equation. Because of the Cauchy-Riemann equation. Now see how the question language can be. How the question language can be. Consider the function u, determine its conjugate harmonic function. Or it could be as simple. It can be as simple as this. The real part of an analytic function is given, find the imaginary part. Both meaning same. Both mean the same. Given u, find the value of v. See, previous question was given u, find fz. Now what is the approach here? What is the approach here? I'll tell you two different approaches. I'll tell you two different approaches. What is u? Let us see what is the value of u given to me. What is the value of u given to me? 2x plus y cube minus 3x square y. 2x plus y cube minus 3x square y. Okay, method number one. Method number one, purely CR equation. Method number one will be purely CR equation. Okay, okay, given you, find the value of v. So what I do is, I will start with the first CR equation. Del u by del x is equal to del v by del y. That means write it reverse. Del v by del y is del u by del x, because u is given, so I can take the derivative of it. I can take the derivative of x. Okay, so take the derivative 2, x derivative 2, y is constant and then minus 3x square. Now since I know del v by del y, I can try to construct v. Okay, del v by del y is known. So what is v? Okay, what is v? So integration with respect to y. Okay, 2y. Okay, minus 3x square constant, integral dy will be y. Okay, 2y minus 3x square y. But remember, anytime we do the integral, we always add a constant of integral in the indefinite integral. Here, because it is a partial derivative term. Okay, see, why we add constant? Suppose I tell you c. Why we add the constant c? Why we add the constant c? Because when you differentiate v again, this constant, maybe it was there, I don't know. But if I differentiated v, this is not appearing here because the differentiation of constant is 0. So we assume maybe there was a constant. On differentiation, it is absent in the del v by del y. Similarly, not only this constant c, not only the constant c, it is a partial derivative term, partial differentiation with y, x is also constant. So dear, maybe there was a x term. Now again, when you differentiate with y, the derivative of x with y partially 0, so it disappeared here. So maybe there was a x, maybe there was a x square, or maybe there can be any function of x. So remember, this is not a regular integral, it is integral of a partial derivative term. Okay, so like you add constant of integral, you have to add the function of x, because that is like a constant when you differentiate with y. But the point is, I cannot leave the answer as phi x. So what is the value of phi x? Okay, what is the value of phi x? The next method I'll tell you will be a direct formula. But if you can remember more formulas, the second one is good. If you work more with logic, this first approach is good for you. That is why I'm telling you both. Okay, so what is the value of this phi x? Okay, for phi x, now we will go for the second CR equation. Okay, second CR equation which says that del u by del y is negative of del v by del x. Del u by del y, take the derivative with y. 3y square minus 3x square is equal to negative. Now v is obtained, roughly what is obtained. To take the derivative with x, y constant, x square derivative 2x. The first term is minus 6xy. Derivative with x I am taking. Okay, so minus 6xy. I think there is some calculation error or what? Del v by del y, derivative with y is del u by del x, correct? So 2 and yeah guys, at least you can correct me if something going wrong, because this was derivative of u with x. Okay, x squared derivative 2x, so this is 6xy. Yeah, there is a small correction here. This is 2y minus 6xy, and now I am going to put the correct value here. Okay, so del v by del x, differentiate with x, y constant. Similarly, if you differentiate with x again, okay, if you differentiate with x again, if you differentiate with x again, y will be constant. Y will be constant, but something that is again not matching is, what is not matching? Okay, sorry, correct. Okay, now I have to integrate with y, na? So 6y. Okay, so 6y, y integral y square by 2, integration was y was done. Okay, so y square by 2. Okay, so 3 by 2, 6, x was constant, 3xy square. Now I am differentiating with x, so I get 3y square minus 3y square, derivative of constant 0, derivative of phi will be phi dash. Correct now? Correct. Okay. Yeah. So 3y square minus 3x square minus again plus 3y square minus phi dash x. So 3y square cancelled out, minus also you cancel. What is phi dash x? 3x square. So what is the value of phi x? X square integral x cube by 3. So 3x square integral is simply x cube. The phi x function is obtained as x cube. Okay, so what is the v value? Finished. 2y minus 3xy square plus x cube. Okay, plus this constant. Finish. Okay, finish. Done. Method number 2. If you can remember more formulas, method number 2 is good for you. Okay. Method number 2, I will use the total derivative. Question is on V, na? I will use the total derivative concept. dv, which is given by del v by del x into dx plus del v by del y into dy. This is the total derivative, okay? Okay, del v by del x by the second CR equation will be minus of del u by del y. And from the first CR equation, okay, del u by del x is del v by del y. So you will replace it as del u by del x. Okay. Now this is of the form mdx plus ndy. Okay, this is of the form mdx plus ndy. Okay, and from CR equations it will be then proved. Okay, from CR equation it will be then proved that del m by del y will be equal to del n by del x. Okay, and this differential equation, what we learn in the differential equation, this will be an exact differential equation. So what is the solution of it? This will always represent an exact differential equation, and v will be given by integral of mdx, integral minus del u by del y into dx, okay, keeping y constant, plus integral of terms of n, okay, that is terms of del u by del x, terms of del u by del x not containing x. Okay, integral with dy. This is a formula to find the v, okay, which uses the concept of exact differential equation. Okay, total differentiation and exact differential equation. Okay, so if I have to apply this formula, see, if I have to apply this formula, what is u given to me? Let me write down the u once again. The u given to me in the question is 2x plus y cube minus 3x square y. 2x plus y cube minus 3x square y. Okay, so what are the del u by del x and del v by del y? Derivative with x 2 and minus 6xy. Derivative with y will be 3y square minus 3x square, correct? So what is v? As I told you, it is integral of what? It is integral of negative of del u by del y negative of del u by del y, negative of 3y square minus 3x square dx, and in the first integral y will be constant, plus integral of what? Terms of del u by del x which do not contain x. Terms of del u by del x, okay, not containing x. So del u by del x has two terms, 2 and 6xy, but this contains x. Okay, this contains x. So what is the term not containing x? Not containing x is only 2. Okay, so solving it, y is constant, so minus 3y square constant dx integral x, minus minus plus 3x square integral will be x cube. Okay, plus 2 dy integral y, plus add a constant of integral. Match your answer exactly the same as what I have written earlier. Just rearrangement is required. Okay, minus 3xy square plus x cube. See, minus 3xy square plus x cube plus 2y plus c. Same answer. Same answer. So if you can remember formulas, method 2 is for you. If you want to go with logic, method number 1, you don't have to remember any formula. It is just, the basic differentiation and integration. Of course, what you have to remember is CR equation. Any type of question on complex analytic function, CR equation is must. 100% to be remembered. All questions revolve around CR equation only. Around CR equation only. Okay. Around CR equation. Now, whether you want to use method 1 or method 2, I told you it is your choice. Okay, it is your choice. Answer will be same. And from this, I will give you a homework, a GATE 19 2-mark question. Okay. Right. Given u is a harmonic function, then what is the conjugate harmonic function v? Again, the similar model. Given u, find the value of v. Given u, find the value of v. You can do it. Method 1, method 2, take your call. Method 1 or method 2, take your call. Okay. Method 1 or method 2, take your call. Now, let's also discuss some important theorems around contour integral of complex function. Okay, first, let fz be an analytic function at each point within and on a closed curve C. Then what will happen? Okay, let fz be an analytic function at each point within and on a closed curve C. Then integral fz dz over the closed curve C. If it is purely analytic, then integral fz dz over the closed curve C is compulsorily 0. Okay, let me first explain you with an example here. Suppose if I tell you there's a question, okay, integral maybe of the form 2z square minus 5z, okay, plus 9 dz. Okay, over a curve C where C is given by mod z equal to 2. Now see here, mod z equal to 2 is a circle. Mod z, starting with the simple case circle, then if it is not a circle, any closed curve, we will come to that also. But even majority of your problems are also on circle only. So mod z equal to r is a circle, and circle means a closed path. Okay, circle always makes a closed contour. It's a closed path. Clear? Circle means it is a closed path. So since it is a closed path, now see. Circle means closed. Clear? And the function fz is analytic. What is the fz? Polynomial. Only polynomial function. So analytic. Analytic. So integral function, because fz is analytic. So how your problem now looks like? See, the problem is something like this. Integral fz dz. Okay, over a closed curve, over a closed path. Okay, integral of a function fz which is analytic. That is what Cauchy's theorem is all about. If you are integrating an analytic function which is analytic, not necessarily everywhere analytic. Polynomial to means always analytic. Polynomial to means always analytic. Okay, but what I want, if a function fz is analytic at each point within and on a closed curve C, okay, then the integral of such a function will always be 0. So the integral answer here, because it is the analytic function, integration of any analytic function over a closed path will be 0. Okay, but now the definition says it should be analytic within and on. Only that much is required. Here it is always analytic. So now have a look into the next question. Now have a look into the next question. My next question is, integral e power z upon z minus 3 dz. Integral e power z upon z minus 3 dz. Okay, where the curve is mod z equal to 2. Same circle I am taking, radius 2. Okay, mod z equal to 2. Okay, it's a circle of radius 2. Now, what is the function fz? See here. What is my function fz? E power z upon z minus 3. Okay, e power z upon z minus 3. What will happen at z equal to 3? If you put z equal to 3, okay, the function fz becomes undefined. The value of z for which the function is undefined, the value of z for which the function is undefined is known as the pole of the function. Okay, so z equal to 3 is known as the pole of the function, correct? Now, because fz is undefined, so f dash z, okay, also doesn't exist. If a function is not continuous, it cannot be differentiable. Okay, it cannot be differentiable. So derivative also undefined. That means function is not analytic. At z equal to 3, function is not analytic. Not differentiable means it is not analytic. Now, few minutes back I told you, the set of points where the function are not analytic are said to be singular points. Okay, so what is this z equal to 3? It is the pole and it is also a singular point. It is also a SP for me. Let me remind you, SP means singular point. I will keep calling it as SP. Okay, it is a pole and automatically it is a singular point. So there is a singularity of the function. Z equal to 3 is a point where function is not analytic. Okay, now talk about the given closed curve. Okay, you don't have to draw it. Understand for this question. You don't have to draw it. But just understand for this question. You have a circle of radius 2. You have a circle of radius 2. Okay. Circle makes a closed path. Okay. Okay, you have a circle of radius 2. That means this coordinate should be 2, 0. On the other side, it should be minus 2, 0. And function has a pole or a singular point at 3. How do we mark the poles, dear? We know that poles are represented by the cross mark. This is 3. Okay. Right. This is 3. Okay. This is 3. This is equal to 3. Now, what can be done? What can be done? Now, let's read the Cauchy's theorem statement completely. There is a point z equal to 3 where the function is not analytic. There is a point z equal to 3 where the function is not analytic. But is the point inside or outside the circle? This is the circle or the closed curve given. What I told you, once again, have a look into it. If fz be an analytic function at each point within and on a closed curve C, at each point, what is required? Minimum what is required is function should be analytic, okay, at each point on the curve and within the curve, within and on the closed curve C, within and on the closed curve C, okay, then the theorem will still hold. Then integral fz dz equal to 0. So what I am able to say here, let me come back to the problem. I am able to say here is fz is not analytic at z equal to 3. Okay, but the z equal to 3 is outside the given closed curve. Is outside the given closed curve. So what can I say? Function, can I say this? Function is analytic, okay, at each point, okay, at each point, because only one point it is not analytic, rest all other points it is analytic. So at each point within and on the curve C, can I say this? The function is analytic at each point within and on the curve C? Yes, I can say that. Yes, I can say that. It is analytic at each point within and on the closed curve C? Yes. And because the answer is yes, then integral of such a function, okay, over the closed curve will be 0. So what you want, the function should be analytic on the curve and within the curve. If it is not analytic outside, that will not affect your answer. Answer will be 0. Clear? I'll have it dinner. Don't worry, Ajay Kumar. Don't worry. Okay. But now if I change the question slightly, okay, if my question is integral e power z divide by z minus 1 dz, okay, over the same closed curve mod z equal to 2. Mod z equal to 2. Okay. Now you see here, what is your pole or singular point? What is your pole, which will also become your singular point, and that is z equal to 1. Okay, that is z equal to 1. Same circle, same radius. Okay, same circle, same radius. Okay, now the pole will be inside. Only difference is pole will be inside. Okay, okay, so this singular point, if it comes inside, then what will happen? Okay, if it is inside, what I want to say is Cauchy's theorem not applicable. Okay, then Cauchy's integral formula or Cauchy's residue theorem will come. Cauchy's theorem not applicable. Okay, so I don't say answer 0 or non-zero. I only say that Cauchy's theorem is not applicable. So if you have a pole which is inside, you can go for integral formula or the residue method. I will suggest residue method. Okay, I'll tell you why. First, let's read this Cauchy integral formula. Now see, if fz be an analytic function at each point, let me write it in our way only. Let us say I call it as some function nz. Okay, let me call it as some function nz. Okay, let nz be an analytic function at each point within and on a closed curve C, and z equal to a is a point inside C. Z equal to a is a point inside C. Then integral nz, this is n for me, integral nz upon z minus a is 2 pi I na. N means only numerator function. Or if it is a pole, repeated pole, integral nz upon z minus a power m, z equal to a is a pole occurring m times, is given by 2 pi I nma is nma upon factorial m. Nm means, I'll write it again more clearly here. This is 2 pi I nma upon factorial m. Nm means mth derivative of the numerator function. Okay, mth derivative of the numerator function. See this question now. Okay. Now this question is of the format integral nz, okay, upon z minus a dz. Integral nz upon z minus a dz. Or let me write down with values. Integral e power z upon z minus 1 dz. Where, okay, the numerator is e power z, which is analytic. Exponential is analytic, na? Okay, don't have to check that. Numerator is analytic. And what I told you, now let's go through it. If nz, numerator, be an analytic function at each point within and on the closed curve C, and z equal to a clearly says is a point inside C. Okay, so whatever is the closed curve C given, okay, whatever is the closed curve C given, suppose this is the closed curve C, okay, z equal to a, suppose this is a, okay, is a point inside C. Z equal to a is a point inside C. So definitely if the point comes inside, then Cauchy's theorem was not applicable. Then what is the value of the integral is given by the integral formula, Cauchy integral formula, which is 2 pi I na. Okay, which is 2 pi I na. So here I can say that nz is the numerator is an analytic function and z equal to 1 is a point inside. Yes, it is inside. Okay, then the answer is given by 2 pi I na. 2 pi I na. What is the n function? E power z. Na means at z equal to a. What is a? Is 1. Here a equal to 1. Okay, so this is given by 2 pi I e power 1. Okay. This is given by the formula 2 pi I e power 1. This is given by the formula 2 pi I e power 1. So answer for the question is 2 pi I na, that is 2 pi I e power 1. Okay, 2 pi I e power 1. Correct? Integral, same question I just did it. Okay, same question I have just did it. 2 pi I e power 1. Okay, same question I did it. Integral 2z square minus 5z plus 6. Now see, every time you don't have to draw the circle. Okay, there is a circle, mod z equal to r. Mod z equal to r is always a circle. So what is the radius of the circle? Radius is 5 by 2. That is 2.5. And where is the pole? Z equal to 2 will be the pole. Inside or outside? So since radius is 2.5, so 2 will be inside, na? 2 will be inside. Because if it was outside, then answer is 0. Then Cauchy's theorem. Okay, because it is in, then it becomes the Cauchy integral formula, where this is your numerator function, which is analytic. Polynomial, na? Numerator is analytic, polynomial. Okay, so answer of this should be given by, again, 2 pi I na. Ci formula. 2 pi I. Numerator function, put z equal to a. Okay, z equal to a, z equal to 2. So 2 into 2 square minus 5 into 2 plus of 6. So my answer is 2 pi I, 2 into 2 square, that is 8, and then minus 10 and plus 6. Okay, so that is 14, 14 minus 10, 4, 2 pi I into 4. Final answer is 8 pi I. Final answer for the question is 8 pi I. Final answer for the question is 8 pi I. Next question. Integral sine pi by 2 z upon z minus 1 whole cube. Integral sine pi by 2 z upon z minus 1 whole cube. Sine pi by 2 z upon z minus 1 whole cube. Okay. So again see, okay, the radius of the circle is 2. So z equal to 1 is the pole which is inside. Okay, but it is the repeated pole. Z equal to 1, 1, 1. Okay, and numerator sine. Sine is also analytic. Sine is also analytic. Numerator should be analytic. Sine is always analytic. Here the formula should be 2 pi I nma divided by factorial m. What is the value of m? Okay, what is the value of m? Okay. No. This is not the correct formula. And m minus 1a, sorry, a mistake happened, I think. It is given by n m minus 1a and m minus 1a, m minus 1th derivative divided by the factorial m minus 1. Okay. And m minus 1a, the derivative to be taken m minus 1 times, I think. There was a typo error here. Okay, because of that, I also just copied like that. It is n z minus a power m, so n m minus 1a divide by the factorial m minus 1. Clear? Divide by the factorial m minus 1. Divide by what? Divide by the factorial of m minus 1. Okay. So yeah, let's come back to that question. Divided by the factorial m minus 1. Okay. So now, what is the numerator function first of all? Okay, the numerator function is sine pi by 2z. Okay, and how many times derivative you want? Okay, you want the answer as 2 pi I n to a, m equal to 3, na? So m minus 1 will become 2, n to a, the value of a is 1, n to 1 divided by factorial 2. Okay, so n2, what is n1? First derivative. Okay, so sine theta derivative, cos theta, so cos pi by 2z by the chain rule pi by 2 will come. And n2, the second derivative, okay, it is not power, again I repeat, it is second derivative, cos theta derivative minus sine theta, again pi by 2 will come, so minus pi square by 4 sine theta, minus pi square by 4 sine theta. Okay, now what I want? This derivative at the location of the pole is at z equal to 1, n to 1, so minus pi square by 1, sine pi by 2 will be left, which is 1. Sine pi by 2 is 1. Okay, so your final answer here is 2 pi I. The value of the second derivative is minus pi square by 4 whole divided by 2 factorial, which is 2. So 2 getting cancelled, minus I pi cube divided by 4. Minus I pi cube by 4 is the answer. Minus I pi cube by 4 is your final answer. Correct, everybody? Okay, done. minus I pi cube by 4 is the final answer. Minus I pi cube by 4 is the final answer. Okay. Next question. Okay, now next, okay, let me also shift towards the residue calculation. Okay, let me also shift towards the residue calculation. Okay, to go to the Cauchy residue theorem. Okay, because what is the Cauchy residue theorem is? What is the Cauchy residue theorem is? The integral fz dz can also be calculated as, the integral fz dz can also be calculated as, integral fz dz over any closed curve C is calculated as 2 pi I into summation of residues inside C. Okay, into summation of residues inside C. Okay, what is the derivation of residues? I'm not doing, the time is not much, but yeah, all methods we'll discuss. So summation of residues inside the curve C. Okay, now how do you calculate residue of any pole at a particular point? Okay, if fz has a pole at the point z equal to a of order m, if fz has a pole at the point z equal to a of order m, then residue is given by the general formula 1 upon factorial m minus 1 limit z tending to a dm minus 1 upon dz m minus 1. That means m minus 1th derivative of z minus a power m into fz. Let's make it more simple. For more simplicity, let me put it this way. Okay, so let's say fz is nz upon z minus a. That means z equal to a is a simple pole. Simple pole means pole of first order. It is only repeated once. Okay, simple pole means first order pole. Pole appearing only once. Or fz equal to nz upon z minus a power m. That means z equal to a is a pole of order m. Okay, is a pole of order m. Two cases will split, and in both the cases this formula I have simplified and written here. Okay, in the first case residue will be given by simply limit z tending to a z minus a into fz, which can also be equivalent to na, which can also be written equal to na. Okay, na. Fz nz upon z minus a, solving it you get na. But better to remember this simple formula, limit z tending to a z minus a fz. Okay, if it is a pole of order m, then the residue will be given by nm minus 1a upon factorial m minus 1. Okay, basically in the CI formula, whatever was the factor with 2 pi I, that coefficient I have separated. Okay, nm minus 1a upon factorial m minus 1. In the simple pole case, na. Okay, which is represented by this formula. Okay, which is represented by this formula. Okay, once you calculate the residue, only calculate the residues which are inside the given closed curve, then integral is 2 pi I summation of the residues inside C. 2 pi I into summation of the residues inside C. 2 pi I summation of residues inside C. Correct? Okay, have a look into this case. Integral z sin z upon z minus pi by 2 dz. Okay, simple pole case. Okay, simple pole case, z equal to pi by 2. Okay, it is a simple pole. Okay, z equal to pi by 2. This is a simple pole. Correct? This is a simple pole. Okay, pi by 2 means 1.57, which is less than the given radius. So that means inside. If it was not inside, then we don't find. Okay, then we don't find any answer. So it is inside only. Okay, it is inside. What is the value of residue? Okay, because it is a simple pole, residue is given by what formula? Simple, limit of z tending to a, limit of z tending to pi by 2, z minus pi by 2 into fz. Okay, z minus pi by 2 into the given function. What is the given function? Z sin z upon z minus pi by 2. Okay, so as I was telling you, this z minus pi by 2, z minus pi by 2 automatically cancelled, and now put z tending to pi by 2. So pi by 2 sin pi by 2 is your answer. Sin pi by 2 is 1, so pi by 2 into 1, the residue is pi by 2. Okay, so what is the answer of the integral here? The answer is 2 pi I. Answer is 2 pi I into summation of the residues inside C. Okay, and the residue value is pi by 2. Okay, 2 cancel. The answer for the question is pi square into I. The answer for the question is pi square into I. Okay, answer is pi square I. Next condition. Okay, next case. Evaluate e power z upon z minus 1 whole square z minus 2 for the three different contours. Okay, first of all, what is the answer for individual contour? I will write down. Okay, see, because if I take mod z equal to 3, both these poles will be included. Okay, so I have to in any ways calculate both the residue. I have to anyways calculate both the residue. Okay, now what are the residues? If I first talk about the pole z equal to 2, that is appearing only once. Okay, so that one is simple. Z equal to 2 is a simple pole, clear? At least the z equal to 2 is a simple pole, we are clear about that. Okay. Now if it is a simple pole, what to be done? If it is a simple pole, what to be done? See here, z equal to 2 is a simple pole. What to be done? The residue is then given by limit of z tending to a, that is z tending to 2, z minus 2 into the fz, z minus 2 into the fz, e power z upon z minus 1 square, z minus 2. So z minus 2 will again cancel. Okay, and your answer will become z tending to, now you put 2 e power 2 upon 2 minus 1 square, which is 1. So answer is e square. Answer is e square. Okay, next pole is z equal to 1, which is a pole of order 2. Because z minus 1 square, it is a pole of order 2. Okay, so what will be the residue? Residue will be given by nm minus 1a. For pole of order m, nm minus 1a upon factorial m minus 1. That is the next formula I told you. Nm minus 1a divided by factorial m minus 1. Okay, m is equal to 2. So n1, 2 minus 1 is 1. n2, 1 divided by factorial 1. So what I need is only n1, 1. Okay, but what is the numerator function? Please take care. Okay, what is the numerator function with respect to z equal to 1? Now this is the important point. With respect to z equal to 1, if you call the z equal to 1 as the pole, okay, your function is e power z upon z minus 1 square into z minus 2. But the type of formula that I have given to you, dear, the type of formula that I have given to you, have a look into this formula. Okay, if I have given you the residue formula as nm minus 1a upon factorial m minus 1, I have taken the function fz as nz upon z minus a power m. That means only that particular pole z equal to a. Okay, that only z minus a power m term is in the denominator, nothing else in the denominator. If there is any other factor in denominator, you have to shift to the numerator if you are applying this denominator. That is the only handle with care situation. That is the only handle with care situation. Okay. Clear? So I will not use this as the numerator. I will actually write it like this: e power z upon z minus 2 whole divided by z minus 1 square. Now this is of the form nz upon z minus a power m. Clear? Now this is nz upon z minus a power m. Okay, now I want the first derivative. So what is my numerator function? I'll take it here. Okay, so what is my numerator function? Numerator function is e power z upon z minus 1. Upon z minus 2. Correct? E power z upon z minus 2. Come up, dear. Okay, e power z upon z minus 2. That is my numerator function. That is to be differentiated. That n dash is required. What is the derivative? Okay, numerator by denominator form. The denominator squared up, then denominator constant e power z derivative 1, e power z constant z minus 2 derivative will be just 1. So taking e power z common, z minus 2 minus 1 is z minus 3 upon the z minus 2 whole square. That is n dash z. And I need the value of n dash 1, putting e power 1 minus 3 upon 1 minus 2 whole square, which is minus 2e upon minus 1 square is 1. The answer is minus 2e. Okay, so this value dear, n dash 1 on solving is obtained as minus 2e. Now come to the question one by one. What is the first answer? Z equal to 1 by 2. If the radius is 1 by 2, okay, so both the poles are outside. The pole is at 1 and 2, both the poles outside. Both the poles are at 1 and 2 and both are greater than half. Both poles outside. Okay, integral answer 0. Okay, z equal to 3 by 2. Which pole inside now? 3 by 2 means 1.5. So 1 will be inside. Okay, the pole z equal to 1 will be in. The pole z equal to 2 will be out. Okay, so what is the integral answer? I told you 2 pi I into only the residues inside C. So only the residue of z equal to 1 pole. Only the residue of z equal to 1 pole, which is minus 2e to be put in the answer. Minus 2e. Okay, so overall answer minus 4 pi ei. Okay. Third question. Mod z equal to 3. So now both the poles are in. Both the poles come in because radius is 3, which is greater than both 1 and 2. Both the poles come in. So what is the value of the integral? 2 pi I into summation of residues. Okay, the residue was e square and the next residue was minus 2e. This will be the third answer. Okay, this is what is going to be the third answer. So I have taken 3 different regions. Suppose if the question was only mod z equal to 3 by 2, suppose now, any one question can be there, na? So then I know only z equal to 1 inside. So the z equal to 2 residue will not be required. I will not spend even a single second onto it. Only you need the residues which are inside C. Okay, so if it was mod z equal to 3 by 2, only the one pole is inside, this residue will be required. Clear? Okay, hope that is clear. Any doubts? Please ask me. Next question. What is the value of the contour integral z plus 2 upon z square plus 2z plus 2, GATE 23 1 mark question, where the contour is z equal to modulus of z plus 1 minus 3 by 2 j equal to 1, taken in the counterclockwise sense, anti-clockwise sense. Okay, if not mentioned also, by default the positive direction of integration is, counterclockwise. Okay, that is the positive direction of integration. The value of the contour integral z plus 2, okay, upon z square plus 2z plus 2. Okay, but what are the poles here? See, not always the poles will be real, na. It may be complex. Z is any complex variable. So if you want to talk about the poles, okay, you will have to solve this denominator and you will get minus 2 plus minus root over b square minus 4 ac 4 to z divided by 2a, and on solving minus 2 by 2 minus 1, this is 2j, so plus minus j. Okay, minus 1 plus minus j, both the poles are complex, but which is inside, which is outside? Okay, which is inside, which is outside? Now see the next discussion here. Which of the pole is in, which of the pole is out? That is the next point to be discussed. I'll tell you 2 things here. If we have to say which is in, which is out. If you have to say which is in, which is out. Okay, so I have the poles minus 1 plus minus j and I am only looking whether they are in or out. The first thing is I will draw the circle. What is my circle? Okay, what is my circle given to you? Okay, you can rearrange it like this. Modulus of z plus something, na? Write it as modulus of z minus 1 plus 3 by 2j. Take a minus outside equal to 1. Now the general circle mod of z minus z naught equal to r. What about the equation of circle? We know this r is the radius. In the complex form, the general circle is given by mod of z minus z naught equal to r, where z naught is the center. Where z naught is the center. Okay, so whether your poles are in or out, first you can draw the circle. And then I will tell you one more simple method. Okay, first you draw the circle. Okay, the center is, okay, so let me just draw this circle. And what is the center of the circle? Okay, you draw it, and what is the center of the circle? Let's see. The center of the circle is at the point -1 comma 3 by 2j. That means x minus 1 and y 3 by 2, and radius equal to 1. Radius equal to 1. So there is this point, okay, -1, the real part -1, and let's say this is 3 by 2. This is the center of the circle, and the radius is 1. The radius is 1, so -1 plus 1, it is going to pass from here, and the radius is 1. Okay, so 3 by 2 minus 1, this lower point will be 1 by 2, this will be 5 by 2. Now what are my poles? -1 plus minus j. Okay, -1 plus j. So here comes my one pole which is inside. Okay, okay, this should be 1. Okay, -1 plus j. But definitely the other pole, -1 minus j, if this is -1, okay, this is out. This goes out. Okay, and this comes in. One pole is inside, one pole is outside. Clear? Okay, or what you can do is, okay, or what you can do is, given the circle, modulus of z plus 1 minus 3 by 2j equal to 1. This is given, na? Modulus of z plus 1 minus 3 by 2j equal to 1. Okay, put down the pole. Z equal to -1 plus j. Put down this one. When you put down z equal to -1 plus j, what will happen? Okay, what will happen? Put down here. Okay, so -1 plus j plus 1 minus 3 by 2j. Keep calculating the value. So this is equal to how much? -1 cancel. Okay, you have modulus of -1 by 2j, and magnitude it is 1 by 2, which is less than 1. Any point lying on the circle, any point lying on the circle will satisfy the equation of circle. But now you are getting a point such that the modulus of z plus 1 by 2 minus 3 by 2j at that point is less than 1. That means the point is inside. Okay, that means the point is inside. Okay, it has to be an inside point. Okay, and similarly, if I take the other pole -1 minus j, put down the value here, modulus -1 minus j and plus 1 and minus 3 by 2j, this becomes how much? Okay, this becomes modulus of -5 by 2j, which is 5 by 2. Okay, which is greater than 1. Okay, so now that point is getting the magnitude which is greater than 1. Definitely that goes outside the circle. Okay, that goes outside the circle. So this way also you can say, if you don't want to draw the circle or any other random curve given, okay, just substitute the value of the pole on the left hand side, and if left hand side equal to right hand side, then that is a point on the curve. But if left hand side less than, it is a point inside. If left hand side becomes more than the constant value 1, then it is the outside point. Clear? Then it is the outside point. That is one more way you can check inside or outside. So anyways, one point inside in the picture, also one point outside. Okay. Okay. Both the poles are appearing once. Okay, both are appearing once. Okay, both are simple. -1 plus j, -1 minus j. These are the two poles, both are simple. Okay, but I want the residue of only one of them. I want the residue of only one of them. Clear? I want the residue of only one of them. My integration, okay, my integration, sorry, let me first write down the function only. My function is z plus 2 upon z square plus 2z plus 2, which I can factorize now. I have calculated the roots of the denominator. Pole means the roots of the denominator. The first one was -1 plus j, and the next one was -1 minus j. Okay, now I am only looking for the residue of z equal to -1 plus j, because this was the only pole which is inside. Don't calculate the residue of the pole which is outside, because it is a simple pole. Because it is a simple pole, so the residue will be given by the formula limit of z tending to a, z minus a, z minus a into the function fz. And once again, okay, this z minus a cancelled. Now put z tending to a. Okay, z tending to minus 1 plus j. So minus 1 plus j plus 2 in the numerator. Denominator minus 1 plus j, and then minus minus plus 1 and plus j. Okay, so the numerator is like 1 plus j and denominator contains 1 cancel, denominator is 2j. Okay, denominator is 2j. So the integral answer is dear 2 pi j into the residue, which is 1 plus j divided by 2j. So 2j got cancelled. Answer should be pi into 1 plus j. Pi into 1 plus j. The answer is pi into 1 plus j. Pi into 1 plus j. That means option number B. Pi into 1 plus j. That is the correct answer. Another important gate question, gate 18 2 marks question. Okay, so see, sometimes not a circle but any random curve given, but it is closed. Okay, it is closed. See, we are looking for the contour C given below is on the complex plane z equal to x plus iy. Okay, good. What is the value of the integral? 1 upon pi I integral dz upon z square minus 1. Okay, integral dz upon z square minus 1. So if you talk about the poles, z square equal to 1, that is z equal to plus or minus 1. If you are talking about the poles, so z is equal to plus or minus 1. Clear? The poles will be z equal to plus or minus 1. Z equal to plus or minus 1. These are the location of poles. Okay, fine. Okay. Shown both are inside. That is what. Sometimes it may not be circle, but any random closed path is whether it is closed, yes. Whether C is a closed path given, yes. Okay, minus 1 and 1, both are inside. Very clearly you are able to see. Both inside. That means both the residues are required. Okay, both of the residues will be required. Okay, so very simple calculation it is. Okay, both are inside. Okay, and what is the function fz? But there is a small catch in the question. That's why I told you it's important. Let's take only the function inside the integral 1 upon z square minus 1, which is factorizable as 1 upon z minus 1, z plus 1. Okay, so what is the residue for z equal to 1? Both are simple pole. Limit z tending to a, z minus a. So z minus 1 into fz. Again z minus 1 factor cancelled, and when you calculate, put down z equal to 1. So 1 plus 1, the denominator is 2. Similarly, residue z equal to minus 1. Limit z tending to minus 1, z plus 1 into fz. Okay, so z plus 1 cancelled this time. Put down z equal to minus 1 in the denominator. Denominator is minus 2. So overall minus 1 by 2. Let me write down this one. Overall minus 1 by 2. Clear? Overall this is minus 1 by 2. Now, the catch in the question is both are inside. Okay, both are in. Okay, but. Okay, but the important point. Z equal to 1. If you look into z equal to 1, the z equal to 1, look into the path around it. The z equal to 1, okay, has been traversed by the closed path in the anti-clockwise sense. But if you talk about, yes, very good Sai Vikas. If you talk about minus 1, it is traveled, it is enclosed by the closed path, okay, but in the clockwise sense. Okay, so z equal to 1 is enclosed in anti-clockwise sense. Anti-clockwise is by default positive only. But z equal to minus 1 is also enclosed by the closed path, but that is in the clockwise sense. As I've shown you, this is in the clockwise sense. Okay. So since I've told you anti-clockwise integration is positive, so clockwise integration, just you have to put a negative sign. That means what is my final value of the integral? Okay, my question is, now come up here. My question is 1 upon pi I integral dz upon z square minus 1. Okay, this should be equal to 1 upon pi I, and integral is given by 2 pi I into summation of residues. Okay, 2 pi I into summation of residues. Okay, 2 pi I into summation of residues. Okay, into summation of residues. Okay, so what is the residue? For z equal to 1, which is enclosed in the anticlockwise sense, for z equal to 1, which is enclosed in the anticlockwise sense, okay, you will take the positive value only. Okay, positive value. What was the residue? The residue is 1 by 2. Okay, so this is 2 pi I into 1 by 2. Board is totally gone very slow now. 2 pi I into 1 by 2, but plus minus 2 pi I into the other residue, which was minus 1 by 2. Why I am taking this minus 1 by 2? Okay, because of the clockwise nature. Because of the clockwise integral will be taken as minus. So if you normally say integral is 2 pi I into residue, here I will say minus 2 pi I into residue. Here I will say minus 2 pi I into residue. Okay, so that is 1 upon pi I. Okay, 2 cancelled. The first is pi I, second also becomes minus plus. Okay, and 2 cancelled. Pi I plus pi I, 2 pi I upon pi I. Final numeric type question answer is 2. The final numeric type answer is 2. Next question. Next question, again with some learning. Okay. All right, Fayaz, yes. So more than 10 hours non-stop crossed. What is the value of this given integral? Okay. Now it's a fourth order denominator, 4 poles will be there. What is the value of the integral? Evaluated over a counterclockwise circular contour. Counterclockwise circular contour in the complex plane. Okay, what is that circle? Definition also not given, but counterclockwise, positive direction given. Anticlockwise circular contour enclosing only the pole z equal to I, where I is the imaginary unit. I is the imaginary unit. Okay, I is the imaginary unit. Now see, if you want to talk about the poles, understand the theme of this question. 2z power 4 minus 3z cube plus 7z square minus 3z plus 5. Clear? This is what is equal to 0. Okay, you will calculate the pole. Okay, there will be 4 poles. Z equal to something. 4 poles will be there. Okay, given one pole. Okay, now the complex contour also encloses only one pole. Given only one pole whose value is z equal to I is inside. Okay, is inside. So what is the value of the integral? Integral should be 2 pi I into residue of z equal to I. So why do I want the other poles? I don't want the other poles. Clear, na? Why do I want the other poles? I don't want the other poles because they clearly mentioned z equal to I is the only pole inside. And the pole which is inside, only that residue is required. Only that residue is required. Okay. So I only require one residue, but still you will face some trouble. So I will tell you a technique. Okay. What is the residue for z equal to I? It is given by limit z tending to I, z minus I into the fz, z minus I into the fz. And what is the fz? Numerator is 6z. Numerator is 6z. Denominator, now since you don't know all the factors, how will you cancel this time? Okay. Come up, dear. Okay. Two z power 4 minus 3z cube plus 7z square minus 3z cube plus 7z square. Okay, plus what? Okay, minus 3z plus 5. Minus 3z plus 5. Minus 3z plus 5. This is what it is, correct? Okay. Now, the problem is the terms cannot be cancelled. They can be cancelled, but for that you have to factorize. Okay, but that will be in fact a long process. Okay, so you will be sometimes stuck that terms do not cancel. Okay, no problem. No problem, dear. Even if the terms do not cancel, if you put z equal to I, okay, this will be 0. 0 into something, 6 into I, divided by denominator 0. Why denominator is 0? Because z equal to I is a pole. Confirm, na? Okay, pole means it will satisfy denominator 0. So what you are going to get is 0 by 0 form, and if the terms do not cancel, you solve it by the L'Hospital rule. You solve it by the L'Hospital rule. Okay, because limit 0 by 0 can be simplified by L'Hospital rule. Okay, so residue will then become L'Hospital rule, limit z tending to I. Okay, now numerator, product of two terms, 6. If z constant, derivative of z minus I is 1. Okay, plus z minus I constant, derivative of z will be 1. Divided by differentiate the denominator. So 4 2s are 8 z cube minus 3 3 9 z square, 7 2 14 z minus 3. Now put down z equal to I. Okay, if it is still 0 by 0, we'll see. Okay, 6 z equal to I. So I, okay, plus I minus I. So no, not equal to 0. Divided by 8I cube minus 9I square plus 14I minus 3. So I once cancelled. So numerator is 6I. Denominator becomes I cube is minus I. So minus 8I. I square we know is minus 1. So it becomes plus 9 plus 14I minus 3. So we have 6I is divided by 9 minus 3, 6, and again 6I. 6 if you cancel, so I upon 1 plus I. I upon 1 plus I. That is the residue value. Okay, or simplifying it further. Okay, residue is I upon 1 plus I, or simplified by factorizing it, rationalizing it. Sorry, the 1 minus I, 1 plus I, 1 minus I. So I into 1 I minus I square. So minus I square will become plus 1 and denominator will be 2. Okay, the value of the integral 2 pi I into this residue value, which is I plus 1 upon 2. So 2 cancel, 2 cancel, and the answer is pi I into 1 plus I. Pi I into the 1 plus I. Pi I into the 1 plus I. Pi I into the 1 plus I. This is also I. Pi I. I have a I missing here or what? Residue is correct. 6I upon 6 plus 6I. That is I upon 1 plus I. So I into 1 minus I into 1. And I square is minus plus 1 I have written. Denominator is also perfect. 2 pi I into I plus 1 upon 2. Something has been missed here. Okay, no problem. Maybe they have taken pi inside only. Better to shift pi inside only then. Okay, so if I shift pi inside, I plus I square, that is minus 1. So the answer then can be written as minus 1 plus I. No problem. I square is further minus 1. So pi into minus 1 plus I. Pi into minus 1 plus I. Option number A then. Pi into minus 1 plus I. Yes, option number A is matching out. Option number A. Yes, Rahul, correct. Option number A. Correct, only correct. Okay. Option number A. One homework I will give it to you. Lot many cases I have told you. One homework I will give it to you. Okay. You have to try on your own. One actually topic I am giving for you. Okay. What is the value of integral z square e power 1 by z? And here, okay, what is the homework you have to research here? Okay, you will have a pole which is z equal to 0, which will be an essential singularity. Now, what is that essential singularity? If you get time, go through, not very important. Okay, so those who are not at all done with the syllabus, for the first timers, you can leave it right now. Okay, otherwise you go through it once. What is that essential singularity? Just go through it once. Okay. So one homework, self homework. I mean, this is not a question to solve. Okay, just try to take the solution of it. try to understand what is that essential singularity. Now dear, I think that's it for today. It's almost going to be 10.5 hours, and whatever we could do, we have done it. Okay. I'll tell you two important things here. Why I did not touch vector calculus. I'll tell you two important things here. I touched differential calculus, integral calculus, linear algebra, okay, and complex functions. The reason I didn't touch vector calculus, if you want to understand vector calculus, okay, just you can watch, okay, the EMF part 1 marathon. Hemant sir has nicely covered the vector calculus there with all conditions. Okay, so if you are not done with vector calculus, okay, you can watch the EMF part 1 marathon. Okay, just happened 3-4 days back only, na? If you already followed, very good. Okay, then the next area, probability distributions. Again, very important. You can't skip it. If you talk about probability distributions, okay, what you can watch? You can watch my videos maybe around 2 weeks back or so. Okay, maybe around 2 weeks back or so, or somewhere end of December, I don't know, 2-3 weeks back. Okay, I took a session, okay, 21, okay, expected questions where all your probability distributions will be covered up. Okay, in nice detail. 21 expected questions on probability distributions on the same channel, on the OM channel. It is available on the OM channel, that is available. Okay, so for probability distribution, you can take the help of that. For probability distribution, you can clearly take the help of that. Okay, you can clearly take the help of that. Let me see if I can find it. So firstly, I am sharing you the link of the EMF marathon. Okay, the EMF marathon, you can refer to it for vector calculus. Although it's EMF, but don't worry, you can still complete the vector calculus from that, because the integral part of EMT is vector calculus. Very detailed, you need the integral calculus. And then what I was telling you is not 21, it was 25 expected questions. I'm sorry. Okay, so this is the next video. Okay, not 21, it is 25 expected question. 25 expected question on probability distribution. You can watch it nicely. I have shared you the link. Okay, so that you don't spend time on, searching it. Okay, and recent video only, not like some old video I'm asking you. Okay, so all probability distributions, you can, refer from that one. You can refer, just 3 weeks back I took. Okay. But basic questions of PDF, PMF, mean, variance, the normal distribution, uniform distribution, binomial, Poisson, geometric, everything is there. Okay. Okay, right. If time permits, we will plan for marathon also. So what I was updating you is, number one, okay, now 21st of January, okay, you will have power system, big subject. So Giri sir is going to take it in 2 different parts. Okay, 21st and 22nd January. 21st and 22nd January. Okay, then these are the details I told you for vector calculus and probability distribution, and also the password. I told you in midway also, one more time to say the password. Oh, sorry. What was the password? Yes, guys, I think I took Maxima. Na? I took it 5-6 hours back. I forgot, but I think I told you Maxima. The password, I think I told you Maxima. Okay, the password I told you is Maxima. Maxima. Okay, everything in small. This is the password. The PDF, you will get it in my Telegram group. Okay, in my Telegram group. Once again, let me share you the Telegram link if you are not connected. Otherwise, you will search here and there for the PDF. Okay, so this is the Telegram link. Okay, this is the Telegram link that I have shared with you, correct? Okay, Maxima. All right, guys. So the first regular offline batch, okay, for GATE 26 from 24th of February. Okay, additional 4,000 early bird discount till the end of this month, that is 30th of January. And for the students looking for online live course, the first online live course from 8th of February, okay, for GATE 26 and 27 both. And okay, here also till 30th of January, early bird additional 25% discount will be applicable on the fees mentioned. Okay, right, this is the OHM scholarship test. This was actually already conducted today. It has been conducted today only. Okay, and if you or your friends are looking for AE offline courses, okay, for Telangana, Transco and Discoms, and as well as for AP Transcom and Discoms, okay, the next AE offline, new AE offline batch starts this Thursday, January 23rd. For any details, you can contact 95156 94053. Okay. So guys, 10.5 hours almost. Okay, if you have still not liked the session, put your attendance before going. Do like the session. Okay, and yeah, next power system sessions will be there for you. Okay, and of course other subjects will also be there. You next immediately what I'm telling is power systems will be there for you Tuesday, that is 21st of January. Okay, so if you want to attend all of them regularly, I again suggest you do not forget to subscribe to the channel, because if you are subscribed, okay, you will not miss any notification. Okay, and you can attend all the sessions in the live manner. You will be regularly updated. Okay, so if you are not subscribed, immediately just subscribe the channel. And bye bye, thank you, good night, stay safe. PDF I'll share to you, password I have told you. I don't commit the PDF tonight. Okay, I'll try if I have energy left, if I sit in front of system. Okay, so I don't commit tonight, but by tomorrow morning I'll see if after dinner if I'm left with some energy, because 10.5 it was almost non-stop only. So I'll share you the PDF that I commit tonight. I don't know, but by tomorrow first half I will share to you. So little bit patience you please keep. Don't ask repeatedly in the Telegram. But by tomorrow morning, tomorrow first half I'll share you for sure. If I'll try in night, if possible, I'll do it. But that's not a commitment from my side. Bye bye, good night, thank you, stay safe and take care of yourself.